With immense pride and great pleasure, I welcome you all to this momentous occasion. Today, we gather not only to celebrate a remarkable journey that spanned over 7.5 decades, but also to reflect, learn, and envision the path ahead for mineral exploration in Singhbhum Shear Zone. We are deeply honored by the presence of some of the most eminent personalities with us from the geoscientific and mining community. It is my privilege to extend a very warm welcome to the chief guest of today's meeting, Dr. Santosh Kumar Satpathy sir, Chairman and Managing Director of Uranium Corporation of India Limited. I express our sincere gratitude to you for accepting invitation despite your busy schedule. Once again, I welcome you, sir. I extend my hearty welcome to the guest of honor of today's meeting, Sri Dheeraj Pandey sir, Director, Atomic Minerals Directorate for Exploration and Research, whose presence is not only a source of inspiration, but also a reminder of unwavering dedication, excellence, and remarkable journey in geological endeavor. I take this opportunity to welcome a visionary geoscientist who has great insight into Singhbhum Shear Zone for more than 1 decade. None other than Sri Mayank Agarwal sir, Additional Director Operation 1, connected through the virtual mode. Welcome you, sir, in this one-day theme meeting. I extend my hearty welcome to today's special guest, Dr. Sandeep Ghosh Chaudhary, Director, CSIR, National Metallurgical Laboratory, Jamshedpur. I extend my hearty welcome to today's invited guest, Sri P.K. Sharma sir, Additional Director, Operation 2, and Sri K.L. Mundra sir, Additional Director, Research and Development. Most importantly, from the core of my heart, I welcome the former colleagues who have joined the meeting on virtual mode from different corners of the country. I extend my hearty welcome to the dignitaries of the dais. Sri Manoj Kumar, Director Technical UCIL, Sri Chanchal Manna, Sri M.K. Singhai, Executive Director, Sri Manoranjan Mahali, DGM Jadugoda Group of Mines, UCIL, Sri Prashant Das, Chief Superintendent Geologist, UCIL, Sri Abhishek Verma, Chief Superintendent Geologist, UCIL, Sri Shoman Tripathi, Additional Deputy Geologist, UCIL. I extend my hearty welcome to the dignitaries from GSI. Sri J.P. Mohakul, Director, GSI State Unit, Bhubaneswar. Sri Sushobhan Niyogi, Senior Geologist, GSI State Unit, Bhubaneswar. I extend my hearty welcome to the dignitaries from HCL. Sangham Kesri Das, Sri Manager R&D. Sri Amit Degvekar, Chief Manager, Exploration, HCL. Kamaleshwaran, Manager, Mines, HCL. I extend my welcome to the regional directors, group heads in charge of different investigations and laboratory, seniors and their colleagues, connected through virtual mode and physically present in this Homi Bhabha auditorium. Once again, I welcome you all, and we are truly privileged and honored by your presence. 75 years, when India was still finding its feet as an independent nation, visionary geologists turned their attention into the Singhbhum Shear Zone. The discovery of uranium deposit in Jadugoda in 1950s was a turning point, not just for atomic minerals, but also for India's self-reliance in strategic minerals. The Singhbhum Shear Zone, a remarkable geological domain with its unique structural complexity, enriched mineralization, and persistent geodynamic activity, were always attraction for academicians and mineral explorers. Over the past 7.5 decades, the Atomic Minerals Directorate had systematically mapped, prospected, and evaluated this region, led to the delineation of several significant uranium deposits. This team meeting is an attempt to bring together the best, vastly experienced professionals, earth scientists, engineers, policy decision makers, and head of unit like UCIL, AMD, and senior representative of GSI and HCL to discuss, deliberate, share experiences of understanding and challenges to arrive at a general consensus on metallogeny and ore body geometry, which has a great impact on future exploration strategy. With these words, Now, I will request Sri S.K. Das, sir, Regional Director, Eastern Region, and convener of this event, to accompany our chief guest, Dr. Santosh Kumar Satpathy, sir, CMD UCIL, Sri Dheeraj Pandey, Director AMD, along with today's special guest, Dr. Sandeep Ghosh Chaudhary, Director CSRI, National Metallurgical Laboratory, Jamshedpur, on the dais. Now, I request Sri S.K. Das, sir, please welcome our chief guest with shawl and presenting him a sapling as a token of love, respect, and gratitude. Now, I request Sri S.K. Das, sir, please welcome our today's special guest, Dr. Sandeep Ghosh Chaudhary, with shawl and presenting him a sapling as a token of love and respect. Now I request Sri S.K. Das, sir, please welcome our today's guest of honor, Sri Dheeraj Pandey, sir, Director AMD, with shawl and by presenting him sapling as a token of love, respect, and honor. On behalf of AMD Eastern Region Jamshedpur, we virtually welcome our Additional Director Operation 1, Sri Mayank Agarwal sir, with digital bouquet, and I request sir to accept our token of love and respect. Now I request Sri B. Panigrai sir, please welcome P.K. Sharma sir, Additional Director Operation 2, by presenting him sapling as a token of love and respect. Now I request Sri B. Panigrai sir, please welcome K.L. Mundra sir, Additional Director Research and Development, by presenting sapling as a token of love and respect. Now I request Sri B. Panigrai sir, in charge Singhbhum Shear Zone investigation and organizing secretary of this meeting, please welcome Sri S.K. Das sir with shawl and by presenting sapling as a token of love and respect. As a mark of respect to all previous directors, additional directors, and regional directors of Eastern Region who guided, implemented, and executed successful exploration program in Eastern region and provided us what we have today in Singum Shear Zone. Please accept our respect through digital bouquet. We have distinguished guests from UCIL, GSI, and HCL with us of the dais. Now, I request Sri M.K. Birwasa, in charge CGGC investigation, to welcome Sri Manoj Kumar, Director Technical, Uranium Corporation of India Limited, by presenting sapling as a token of love and respect. Now, I request Dr. R.K. Mandal sir, welcome Sri M.K. Singhbhum, Executive Director, Uranium Corporation of India Limited, by presenting sapling as a token of love and respect. Now, I request Dr. R.K. Mandal sir, in charge Chemistry Laboratory, to welcome Manoranjan Mahali, DGM, Jadugoda Group of Mines, Uranium Corporation of India Limited, by presenting sapling as a token of love and respect. Now, I request Srimati Shashwati Rai Chaudhary, in charge AMDC, to welcome Sri J.P. Mahakul, Director GSI, State Unit, Bhubaneswar, by presenting sapling as a token of love and respect. Let us begin this auspicious event with tradition, lighting of lamp, and invoking the blessings of divine. Light signifies victory over darkness. Flame of light represents knowledge of wisdom, hope, and prosperity. To honor our tradition, making this event more meaningful, now I request our esteemed dignitaries on the dais to join us in Deep Prajalan. I'll request Sri P.K. Sarma sir, KL Mundra sir, to join the Deep Prajalan. Namo Namah. Ya Kundantu Tusandhar Dhavala Ya Shubhravastabrita Ya Veena Varadanda Mandita Kara Ya Sita Padmasana.
या ब्रह्मा च्युतशङ्करा प्रभृतिभिः देवैः सदा पूजिता सा मां सरस्वती निशेषजाड्यपः ॐ सरस्वती नमो नमः.
May this light inspire all of us towards great understanding and auspicious beginning of today's meeting. Any event begins with a thought, and it needs vision, passion, and effort to turn into reality. The man who worked tirelessly to make this meeting meaningful and live is none other than Sri S.K. Das sir. Now, I would like to call upon Sri S.K. Das sir, Regional Director and Convener of this meeting, to deliver the welcome address.
Thank you. Namaskar. Happy Sunday. Good morning, all of you. Honorable Chief Guest of today's function, Dr. Santosh Kumar Satpathy, CMD UCIL and Outstanding Scientist, Uranium Extraction Division, BRC Mumbai. Our special guest, Dr. Sandeep Ghosh Chaudhary sir, Director NML Jamshedpur. Guest of honor, Sri Dheeraj Pandey sir, Director AMD and Outstanding Scientist. Invited guests, Sri P.K. Sharma sir, Additional Director Operation 2, and Sri K.L. Mundra sir, Additional Director Research and Development AMD. Esteemed delegates from UCIL, HCL, GSI, senior officers of AMD who have connected with us through digital platform, including AD Operation 1, Sri Mayank Agrawal sir, all former regional directors of AMD Eastern Region, Jamshedpur, all incumbent regional directors of all 7 regions of AMD, group heads, in charges of sectional offices, colleagues, dear friends of AMD Eastern Region as well as across all regions who are physically present over here or directly connected through digital platform, representatives from electronics and print media. I welcome all of you to AMD Eastern Region with hearty greetings for the theme meeting on 75 years of exploration in Singhbhum Uranium Province, historical insights, contemporary concepts, and future perspectives, ESUP-2025. Welcome to all of you. At the very outset, I extend my sincere gratitude and respect to all my former directors of AMD, additional directors of AMD Eastern Region, and all regional directors of AMD Eastern Region Jamshedpur, who has collectively shaped this region in general and Singum Shear Zone in particular as the flagship thrust area of AMD for uranium exploration and resource augmentation. As we all know, AMD, which is the oldest unit of Department of Atomic Energy, has celebrated its 75th Foundation Day last year on 29 July, and it was inaugurated by our Chairman, DAE and Secretary AEC, Manti sir. And as a part of year-long celebration across the country on all the regions, Eastern Region has got the chance to conduct this theme meeting today on a very apt topic, which is exploration in Singhbhum Uranium Province. It is an honor for me to deliver the welcome address to the august gathering as the convener of this theme meeting. It is worth mentioning that the exploration for uranium in India started from this very domain. After the inception of AMD, after it has come into the fold of Atomic Energy Commission in 1949, the first assignment that was given to AMD officials those days was known as RMSU. So that time, the first team led by Khedkar Saab, they have identified, they have discovered this first anomaly near to Jaduguda in 1950-51 field season, and that was the beginning of the story. And from that day onwards, continuously we are working in this domain effortlessly through generations of people. So from the pioneering fieldwork in the early decades to the integration of cutting-edge geoscientific knowledge today and technology that we have today, our journey reflects the resilience, innovation, and commitment of generations of geologists and engineers. We are truly honored to have amidst us stalwarts and visionaries from organizations that has played a vital role in shaping this story. Uranium Corporation of India Limited, the Geological Survey of India, Hindustan Copper Limited, and my very own Atomic Minerals Directorate for Exploration and Research. We are also having the contribution of ore processing and metallurgy through NML Jamshedpur. So our collective contributions have laid the foundations for India's mineral self-reliance and energy security. I got some objection from the audience that I welcome with happy Sunday. It is Saturday and Sunday too. Why I am telling Sunday? As you all know, this very day, this is 3rd May 2025, is International Energy Day. And it is International Sun Energy Day. And briefly it is known as Sunday, not Sunday, Sunday. So on this very day, this reflects our commitment towards going towards the renewables. As you all know, we collectively, globally together are committed towards making the world carbon free, the net zero emission we are adhering to. So in that process, we are going to the safer side, cleaner energies. And we all know that there are different sources of energy, and we all know what is the importance of nuclear energy in this particular field. And when we talk of nuclear energy, also India, I need not elaborate over this platform, but we are committed towards making this energy security for India through nuclear power as much as possible. And when you talk of nuclear power, for the supply of the sustaining the fuel chain, what is the role of AMD, that I need not reiterate. Over the years, we have augmented the resource. We have worked tirelessly, generation of people, not only geologists, geophysicists, drilling engineers, everybody they have committed from staff to everybody has committed towards this goal. And what we achieved today is a achievement of a generation of people. After working 75 years, we have made rapid strides in uranium exploration, resource augmentation, mining, and ore processing. Despite having understood several key aspects, as a student of geology, we still have many questions in our mind. Have you understood everything of the Singum Shear Zone, even after working 75 years? How is that the incompatible and compatible elements they are enriched together in this particular domain? How is that copper, uranium, molybdenum, Re, chromium, nickel, and host of minerals they are occurring together in the same domain, same place? Not only that temporarily associated, they are spatially also associated. So what geological process, what metallogenic process, what tectonic process is making it possible? As long as you are eating apple, getting apple, we are not bothered where from you are getting. Whether it is falling, flying, somebody is gifting, or we are, whatever means, till that time we are not bothered. But will it continue forever? So for that, as a student of geology, we need to understand what is the genetic process which is contributing to this uranium, thorium. Re, and host of critical other minerals. So after working so hard for years, 75 was a very long time. We are celebrating the Diamond Jubilee, but still there are still many knowledge gaps in our mind. So to address these knowledge gaps, this theme meeting is conceived, and I am thankful to my director that he has allowed me to conduct this particular theme meeting in Eastern region itself. It has got two broad topics, I would say. One is to bridge the knowledge gap so as we can understand the process. As a scientist, if you don't understand, routine jobs you cannot do. As a scientist, you have to understand, then only you can do better. This is the first aspect. We have to understand, bridge the knowledge gap. We'll deliberate upon those things. Of course, in a single day, it is not possible. Our young scientists, they will express their thoughts, their understanding, what they know about the observation aspect, they will discuss. And the stalwarts present across different organizations, HCL, UCIL, AMD, NML, GSI, all together will discuss about this threadbare for this particular aspect. And second, most important, we're augmenting uranium. What next is mining, processing, and socio-environmental issues. So that has to be addressed. These are the key issues. The socio-economic address or socio-environmental aspects, they are not peripheral to our system. They are very much central to it. We cannot neglect all those things. And how to process these low-grade ores, how to mine these low-grade ores, that is opportunity. I will never say that is a challenge. So that is another aspect of our theme. So I would request all my youngsters, friends, across all regions and all my friends over here in Eastern region, that you showcase your talent, what you understand, you present your things over sessions to the stalwarts, and from the experts, you try to understand. Experts will share you their experience and wisdom and try to gain the maximum possible knowledge through this theme meeting, one-day theme meeting. Without taking much time, I wish this theme meeting to be a grand success. I thank all of you for the cooperation. I would lastly say to all my friends, be involved, stay committed, and enjoy your work with passion. Thank you. Jai Hind.
Thank you, sir, for your inspiring words, insight, understanding, and vision for future exploration perspective. I extend my hearty welcome to the distinguished guest from Hindustan Copper Limited, who have just reached now, Sri Sangam Kesri Das, Senior Manager, Research and Development, Sri Amit Degbekar, Chief Manager, Exploration, HCL, Kamlesh Shoren, Manager Mines, HCL. I welcome you all, sir. Now, I request Sri Enar Ekasar, in charge Singhbhum Shear Zone East Investigation, to welcome Sri Amit Degbekar, Chief Manager, Exploration, HCL, by presenting sapling as a token of love and respect. Let this 75 years Odyssey be both a tribute to the past and a pledge to the future. Let us honor the legacy of those who came before us by pushing boundaries, nurturing talent, and setting benchmark of excellence. Yes, I am talking about every dynamic regional directors of AMD Eastern region whose visionary leadership has transformed challenges into opportunities, paving the way for growth, success, and brought the AMD into a greater height. With a mark of deep gratitude and respect, we have designed a special souvenir volume. Now, I will request esteemed dignitaries on the dais to unveil the souvenir. So now we will look into the screen. After relocation of AMD ER headquarters to Jamshedpur in 1994, the regional directors who have immensely contributed to shape of today's eastern region are, if you will see in the page from bottom to top, Sri A.K. Das, Sri A.K. Bagchi, Dr. P. Krishnamurthy, Dr. S.A. Pandit, Sri P.V. Ramesh Babu, Sri Binod J. Katti, Sri Pramod Kumar, Dr. D.K. Sinha, Sri Anirban Saha, Dr. Kalyan Chakrabarti, Sri J.K. Patnayak, Sri D. Bhattacharya, Sri Sujit Kumar Das. So in the last page of this photograph, the first one is the Badhuvarag open cast mine and second one is Trech conglomerate from Rakha area. So now we have reached the most awaited moment to witness the unveiling of work that represents year of hard work, research and dedication. Yes, the Atlas of Singum Shear Zone. Before unveiling, I would like to share that Singum Shear Zone is structurally very complex with multiple phases of deformation history, which is very well written on rock surface. We have tried to capture those features from field as well as by petromineralogical investigation. Of course, 75 years of exploration by AMD in this domain has unfolded many hidden features, and these were incorporated as field and core photographs. We have dedicated 75 exclusive pages with requisite photographs marking 75 glorious years of achievements in Singhbhum Shear Zone. Now, I will request the dignitaries to unveil the Atlas of Singhbhum Shear Zone. I request the audience to please give a big round of applause. So I would like to share that the cover page of the atlas represents whole spectrum of exploration. Surface exposure of uraniferous metaconglomerate, pay horizon in Jadugoda represents surface exploration. Core photograph represents subsurface exploration, and photomicrograph represents laboratory technique used to identify the presence of uranium and other associated minerals. The last cover page of the atlas depicts first radioactive outcrops identified in Jadugoda area, team led by V.R. Khedkar sir in 1950s. These are the outcrop photograph which is depicting the surface exploration. This is the core photographs which represents the subsurface exploration. And these are the photomicrographs which represents the techniques, laboratory techniques we are using to identify the uranium and other associated minerals. And this is the last page of this cover photo. Last page. First page of the photograph, which represents the first exposure of the meta conglomerate, which is the pay horizon in Jadugoda. And this discovery is done by V.R. Khedkar sir in 1950s. Now I will request Sri Dheeraj Pandey sir, Director AMD, to address the gathering. Before he will start the speech, I would like to read his brief biodata. Sri Dheeraj Pandey, Director and Outstanding Scientist, Atomic Minerals Directorate for Exploration and Research, is an eminent exploration geologist with more than 35 years of experience in exploration and research for uranium and other atomic minerals in various geological domains of the country. He has noteworthy contribution in prospecting and development of Rohil uranium deposit in Rajasthan, Turamdi group of uranium deposits in Jharkhand, Tumlapalli group of deposit in Andhra Pradesh, and Kanchankai Halkal uranium deposit in Karnataka. He is recipient of prestigious National Geoscience Award in the year 2019 by the Ministry of Mines, Government of India, for his significant contribution in the discovery and development of Rohil uranium deposit. With these words, I will request sir to address the gathering.
नमस्कार। आज रवि दिवस की आपको बहुत बहुत शुभकामनाएं। सबसे पहले मैं यहाँ पर एक बहुत ही हार्दिक अभिनंदन करता हूँ हमारे आज के मुख्य अतिथि डॉक्टर संतोष कुमार सतपथी, चेयरमैन एंड मैनेजिंग डायरेक्टर यूनियन कॉर्पोरेशन ऑफ इंडिया लिमिटेड, हमारे विशिष्ट अतिथि डॉक्टर संदीप घोष चौधरी, डायरेक्टर नेशनल मेटलर्जिकल लेवल, के कन्वीनर के दास, रीजनल डायरेक्टर, और हमारे साथ यहाँ पर उपस्थित के एडिशनल डायरेक्टर्स श्री पी.के. शर्मा साहब, श्री मुंद्रा साहब, UCIL, HCL और GSI से आए वैज्ञानिक अधिकारीगण, ऑनलाइन माध्यम से जुड़े हमारे एडिशनल डायरेक्टर मयंक अग्रवाल साहब। जैसा कि मेरे पास कुछ नामों की एक सूची है जो लोग ऑनलाइन अभी उपस्थित हैं, उसमें श्री S.K. पाल DMG झारखंड से हैं, श्री R.K. पांडे DMG झारखंड, श्री देवाशीष भट्टाचार्य पूर्व क्षेत्रीय निदेशक पूर्वी क्षेत्र, डॉक्टर B.S. बिष्ट पूर्व क्षेत्रीय निदेशक पश्चिमी क्षेत्र, श्री A.R. मुकुंदन प्रेजेंटली रीजनल डायरेक्टर साउथ सेंट्रल रीजन हैदराबाद, श्री जयदीप सेन, डॉक्टर जयदीप सेन रीजनल डायरेक्टर नॉर्दर्न रीजन दिल्ली, हमारे फॉर्मर एडिशनल डायरेक्टर और मेरे परम मित्र श्री D.K. चौधरी साहब, एंड प्लानिंग एंड मैनेजमेंट सर्विसेज हैदराबाद के प्रमुख श्री N.K. पंडा जी, और भी बहुत से अधिकारी साथ में जुड़े हुए हैं। मैं आप सभी का तहे दिल से हार्दिक धन्यवाद करता हूं इस संगोष्ठी में, इस टीम मीटिंग में भाग लेने के लिए। जैसा कि इस थीम मीटिंग की जो टॉपिक है 75 इयर्स ऑफ एक्सप्लोरेशन इन सिंघुम यूरेनियम प्रोविंस, हिस्टोरिकल इंसाइट्स, कंटेम्परेरी कंसेप्ट्स एंड फ्यूचर पर्सपेक्टिव्स, इससे आपको विदित होगा कि पिछले 75 वर्षों में जो निदेशालय ने कार्य किया है तब पूरे देश में और स्पेसिफिकली सिंघभूम शेयर जोन में तो उसकी जो उपलब्धियां रही हैं उसके बारे में चर्चा करने के लिए एक संगोष्ठी का आयोजन किया गया है, और उपलब्धियों के साथ साथ जो आगे हमारे आने वाले समय में जो चैलेंजेस हैं, जो अपॉर्चुनिटीज़ हैं, उस पर भी हम विचार विमर्श करेंगे। और सबसे पहले मैं इस थीम मीटिंग के कन्वीनर श्री S.K. दास साहब और उनकी पूरी टीम, ईस्टर्न रीजन की जो टीम है, उसको बहुत बहुत बधाई देता हूं कि आपने इस तरह की एक थीम मीटिंग का एक सोच रखी और उस सोच को आपने एक आज के दिन में उस सोच को आपने एक एक्शन के तहत उसको बदला है। और जैसे आप सभी जानते हैं, दास साहब ने भी इसका जिक्र किया कि पिछले साल हमने अपनी 75वीं वर्षगांठ मनाई थी 29 जुलाई को, और तभी एक डिसीजन हुआ था निदेशालय में कि साल भर की एक एक्टिविटीज़ रखेंगे हम अलग अलग क्षेत्रों में। तो उसी के तहत पूर्वी क्षेत्र ने भी आज ये मीटिंग ऑर्गेनाइज की है। और ये एक कोइंसिडेंस ही है कि हमारे जो निदेशालय के 75 वर्ष पूरे किए हैं, तो सिंघभूम यूरेनियम प्रोविंस में भी हमारे 75 वर्ष पूरे हुए हैं, क्योंकि सबसे पहले यही कार्य शुरू हुआ। तो इट इज़ अ बिफिटिंग befitting gift for Eastern region that we are celebrating this theme meeting today. You are all aware that Singum Shear Zone today is a well-known geological domain hosting major uranium resource of the country. In fact, the second largest resource after Tumalapalli. And besides, we have a host of deposits of copper and many critical minerals, which are in the main focus of everyone today. For example, like molybdenum, rare earths, cobalt, nickel, platinum group elements. And जो भी resource establish हुआ है, whether it is uranium or copper or say other associated minerals or elements, it is a result of tireless efforts of our predecessors, and they have really put in their sweat and blood. They have contributed immensely in bringing Singum Shear Zone in the mineral map of the world. So on this occasion, I pay my respects, my tribute to their hard work and their leadership skills. Today we are following that path only. And on this occasion, I would like to just put in my observations. ऐसा कहा जाता है कि अपनी जो इतिहास है या अपना जो पास्ट है उसको बदला नहीं जा सकता. But nothing prevents us from revisiting our past and of course altering the course of our future. I will quote two examples from Singhbhum Shear Zone because this is specifically a theme meeting on Singhbhum Shear Zone. Late 80s में Singum Shear Zone का मैं एग्जांपल लेता हूँ तुरमडी ग्रुप ऑफ डिपॉजिट्स का. तो तुरमडी के आसपास जब कार्य हो रहा था तो डिफरेंट टाइम्स में डिफरेंट टीम्स वर वर्किंग ऑन इन दैट पर्टिकुलर एरिया. तो अलग अलग समय पे वहाँ छोटे छोटे डिपॉजिट्स आए. फॉर एग्जांपल पहले उनको जो कहा जाता था उस टाइम में तुरमडी वेस्ट, तुरमडी ईस्ट, तुरमडी साउथ, केरा डूंगरी. एंड ऑल दीज डिपॉजिट्स जो है वो विद इन से ऑफ 1 or 2 स्क्वायर किलोमीटर्स के क्षेत्र में इस्टेब्लिश हुए. सब्सिक्वेंटली एक सोच आई, हमारे पूर्व निदेशक आज नहीं हमारे साथ, वो श्री आर के गुप्ता साहब थे उस समय. तो 2003 के आसपास उन्होंने एक इस तरह का एक मुद्दा उठाया कि इतने छोटे से क्षेत्र में इस तरह के अलग अलग डिपॉजिट नहीं हो सकते. अगर हम अपनी सोच बदलें तो हो सकता है दिस में बी अ सिंगल डिपॉजिट विच इज लिंक्ड इन द सब सरफेस. तो इस सोच के तहत उन्होंने एक ग्रुप बनाया. उसमें जिन्होंने पहले कार्य किया था तुरमडी एरिया में उस टाइम में, उनकी जो पूरी टीम थी, उस पूरी टीम के जितने मेंबर्स थे वो ईस्टर्न रीजन ऑफिस में आए. 2 बार हम लोग मिले उस समय, और फॉर्चुनेटली मैं भी उस समय ईस्टर्न रीजन में कार्य कर रहा था. 2003 की बात है. 2 बार एक हफ्ते के लिए सारे मेंबर्स वहाँ इकट्ठे हुए. और वो जो मेंबर्स हैं उनमें से बहुत से बाद में कोई रीजनल डायरेक्टर बने, कोई एडिशनल डायरेक्टर बने, कुछ डायरेक्टर के पद से रिटायर हुए. इट वाज अ टीम विच हैड सॉलिड बैकग्राउंड इन एसएसजेड इन दैट पर्टिकुलर डोमेन. और जब हम लोग साथ मिलकर बैठे तो वी वर फॉर्चुनेट इनफ, आई वाज फॉर्चुनेट इनफ रादर टू बी पार्ट ऑफ दैट टीम. दिन रात हमने सुबह 8 बजे से लेकर रात को 11-12 बजे तक हम लोग बैठते थे. एंड वी revisited the entire reports, sections of each deposit. जितने हमारे वर्टिकल लॉन्गिट्यूडनल सेक्शंस थे या स्ट्राइक सेक्शंस थे, ट्रांसवर्स सेक्शंस थे, सभी को भी रिविजिटेड. जहाँ ज़रूरत पड़ी उसको हमने मॉडिफाई किया. लिंक देखा गया कि कैसे अगर उसको सब सरफेस में कहाँ पर गैप्स हैं, अगर वहाँ पर अगर बोरहोल डाला जाए, उस कमेटी के जो रिकमेंडेशंस थे उसके हिसाब से हमने 2-3 बोरहोल्स भी बाद में किए. वी फिल्ड अप दोज गैप्स and ultimately we carried out an exercise on different cutoff grades for ore reserve estimation. और उसका end result या जो उसका नतीजा यह निकला कि we could establish that all these smaller deposits were in fact a single deposit. And subsequent to that report, UCIL was fortunate enough to have opened the first open cast mine of uranium in the country, that is Bandurang, and the underground mine at Turamdi. So this was a result of this exercise. what I was giving example कि you revisit the past and alter the course of your future. Probably ये exercise अगर ना हुआ होता तो आज this बंदूरांग mine and तुरमडी mine may have been history. मतलब कब आते पता नहीं. And another example of the latest example that we have from Singum Shear Zone of this kind is the Baglasai Machua Jadugara North deposit. हमारे predecessors ने काम करके जादूगरा डिपॉजिट स्टैब्लिश किया, भाटन डिपॉजिट स्टैब्लिश किया. उस समय कुछ कंस्ट्रेंट्स थे, डीपर ड्रिलिंग के कंस्ट्रेंट्स थे. 300-400 मीटर से ज़्यादा की गहराई पे हम ड्रिलिंग नहीं कर सकते थे. सब्सिक्वेंटली 2008 के बाद हमने रिविजिट करना शुरू किया सिंघभूम एरियाज में. एक सोच उभर कर आई कि जो माइंस हैं, ऑलरेडी एग्जिस्टिंग माइंस हैं, उनकी लाइफ को कैसे एक्सटेंड किया जा सकता है, और कोई नए क्षेत्र अगर कुछ नॉलेज गैप्स हैं वहाँ अगर कुछ काम करके कुछ नए एरियाज आ सकते हैं, या कुछ एग्जिस्टिंग डिपॉजिट्स को ही हम इन्हांस कर सकते हैं, ऑगमेंट कर सकते हैं उसमें रिसोर्स. तो उसके तहत जो उस समय वहाँ पर यहाँ जो लोग काम कर रहे थे उनकी सोच में बदलाव आया. और we started in a different fashion with, of course, we had the additional inputs of geophysical surveys that also were used, and ultimately we could establish a new deposit just north of the Jadugada deposit that we call the Jadugada North, and uska western extension Baglasai Machua. Now these deposits together, this Jadugada North, Baglasai Machua, today they hold a resource which is 4 times the original resource of Jadugada mine. So this is what is the result of revisiting the past and altering the course of future. So इसी ड्रीम और इसी तरह के एक कॉन्सेप्ट को लेके हम लोग अब आज आगे बढ़ रहे हैं. And we should keep up this kind of spirit. Lot of new talent is with us in AMD now. Bright future is there for AMD and specifically for Eastern region. And if this kind of work continues, probably Singhbhum Uranium Province will become the leader in uranium resource augmentation in very few years. So with these few words, I'll conclude this my speech, and I wish this theme meeting a great success. And once again, congratulate Shri S.K. Das and his team of Eastern Region for organizing this theme meeting. Namaskar and Jai Hind.
Thank you, sir. Sir, revisiting the past and find the present. Thank you, sir, for these words. We will try to incorporate in future during our course of exploration. Now, I will request Dr. Sandeep Ghosh Chaudhary to address the gathering. Before he will start his speech, I would like to read his brief biodata. Dr. Sandeep Ghosh Chaudhary joined CSIR National Meteorological Laboratory, Jamshedpur in 1996. Sir has more than 30 years of experience in alloy development, phase transformation, thermomechanical processing, crystallographic texture development. He was a visiting professor for many international institutions. Sir has more than 125 publications with 20 patents, and he has published 2 books. Now I will request Dr. Sandeep Ghosh to please address the gathering.
Namaskar to each one of you. Dr. Santosh Satpurti, Chief Guest of today's function from UCIL. Sri Dheeraj Pandeji, the Director of Atomic Minerals Directorate. And of course, Sri Sujit Kumar Das, presently the Regional Director of and as well as the convener of today's functions. Several dignitaries from just off the dais, former directors who are there online throughout these programs. And of course, when I am coming over here, I could see that there are several organizations, people from GSI, people from HCL. Thank you very much for coming over here. And it's my honor and privilege to be here in this program. I really didn't know those things that we are NML 75 years now because we have been established in 1950, and my neighbor is also like this. I'm sorry that I didn't know those things, that my neighbor is also 75 years old, and Jamshedpur is such a very, very prestigious city for the India, because we know that Tata Steel, the industry which is pre-independence era, the first mini industry which was there before the independence, that is the Tata Steel. But we too are there, who are the backbone of India's, not only the industry, and today it is the very, very things that clean energy, energy security, and all these things. I think today this word minerals, I think it is no more there except in few academic institutions or few of the institutions of importance there. But whenever I saw these things word, that minerals, and although I was called, I think I was there in Dhanbad, and that time I got the mail and my office told me that Mr. Das is looking for me. I said, okay, let's see that, because these are the places, those are, I think we call it that very danger, your species which are dangerous or which are basically in crisis. Some of the people today, we are very much, today it is required, but unfortunately for the last 20 years, we never bother about them. I think the mineral engineers, geologists, those who are even my own discipline, metallurgy, who are in the earlier days have been going to be wiped out. I think today you people are there, and today you are the scariest animals of this planet, but today you are the most important animals in this planet. So you must be congratulated for your 75 years of exploration, and that too for the exploration on this very, very immense thing, that is the uranium. Because today, I think whoever talks about carbon emissions, our Honorable Prime Minister goes to the meeting in the World Forum and talks about that yes, by 2050, 2070, we will have zero emissions. And being a metallurgist, it's dangerous because we get nearly about 10 to 12%, because next 2 hours there is Tata Steel. You are outside, little bit outside of the Jamshedpur, but we are at the heart of Jamshedpur. So we know that what is the pollution, what is the carbon dioxide is there. So we really know that what is the things carbon dioxide can do. And my journey in NML started in 96, and I interacted with, started from Dr. Kakotkar. At that time, he was not the director of BRC, but he was my external examiner for my MTech thesis at IIT Bombay. So that's why my interactions. And then I think our groups, Dr. Sri Kumar Banerjee, who is a metallurgist, so we have closely interacted because my area and his area branches quite similarly. But unfortunately, everybody talks about so many hypes, so many things. But I think today in this about energy security, clean energy, I think your contributions cannot be ruled out. Your contributions in immense on these things. And I think the government is now, or the country is looking for it, that how it can be revived and where we are standing today. Because nobody other than you people can think of the minerals such a better way. Yes, I was there in Dhanbad, so I was talking with the director that I want to go to the mines. Coal mines, generally we know that a lot of pollutions, but I want to go to the deep and see that what you exactly do. Because we call ourselves scientists, of course you are not. So being a scientist in the mining engineering, what exactly you do? You just dig and go there. So where is the science? So science, of course, we dig into those things, but that doesn't mean that the earth crust, I will dig into this. We dig into some specific problem and dig into that scientific contribution of it. So the director says, okay, next time when you visit me, I will arrange that you can go there and explore that. What is the science there? Not exploring coal and other things, but explore where the science is. So thank you very much. I think earlier when you talked about Mr. Gupta, I think he said one. Yes, we had a good interaction, but I do not know what was the reason that we lost our connections between AMD and NML. But when Mr. Pandey is there and Mr. Das is there, I think we should revive our interactions, because what you do, and I think one of the scientists, or few of the scientists who worked, those who were retired, but that time I was new, I knew that this uranium leaching, uranium ore that is leached by bio-leaching process in an autoclave, I think that was done at NML. And we are proud that we did some work, and we showcase some of the things that yes, you are also there in these radioactive regions of those things, not in. Today, minerals means rare earth minerals, critical minerals. Ministry of Mines are giving too much importance to those things. But before that, those things were not there. So lucky those insurgents has come. The geopolitical scenario has changed. China said, we are not going to give it to us. So we are the front of the nation, because unless we are there or you are there, I think country cannot progress. So these are the very, very vital things today, because no energy, because electricity is there. Now there is no electricity, so we cannot speak properly. Our mobile phone cannot be charged, or such and so forth. So our whole daily life is dependent on some of the people like yours who can control that whole India's luxury or necessity, whatever you can say that those things, these are the things. Today, air conditioners and all those things are not more a luxury. now it is a necessity. In my car, the AC, nobody is talk about. Even in the Nano, which Tata thought about it, he tried to put into the AC air conditioners into those things. For all those requires energy, whether it is in the form of electricity or it's from the battery and all these things. And when you talk about the battery, I think they are not only you, rather we are also coming into picture, because the critical minerals nowadays, it is the one of the backbone for the countries in India. Who has more number of critical minerals, they are the big shot. And that's why today China is, even though there are, you know, the newspapers that Trump is giving 120% of taxes and all these things, but China says, okay, stop the export to USA. So that kind of things, they can do those things. So that way, you don't have a war, these ammunitions and all these things, but these are the technical know-hows or technical equipments which you have in your mind, which can control India to be in the forefront. Jointly work hand together, I think we can build up a new India, energy secured India, or so-called whatever the things possible to be the best in the world. I think we can have all those things. I think I don't take much time, but I think once upon a time there is a movie by your three scientists. I think our space gentleman, this Vikram Sarabhai, and this Rocky, that is a rocket scientist. I think if you go through those things, and I think there was a nice quotation was there by the person on which that auditorium is named, Homi Baba Auditorium. He said that we have to harness those things, and he said that the future of India lies in the ability to harness the power of the atom. And I think today that atom is there, and you are the core of those atoms. So kindly do those excellent work. And it's not 75 years, as long as India is surviving or the world is surviving, you give the path to the people or to humanity of all those things. And I think let's have a peaceful and a energy secured nation. As the nation, we can lead the world for another 75 or 100 years. Thank you very much once again for being with us.
Thank you, sir, for your inspiring words. Now I will request Dr. Santosh Kumar Satpathy, sir, CMD UCIL, to address the gathering. Before he will start his speech, I would like to read his brief biodata. Dr. Santosh Kumar Satpathy is a chemical engineer, outstanding scientist, having more than 30 years of working experience in uranium extraction division, UED of Bhabha Atomic Research Center, BRC. At present, he is also holding the additional responsibility of Chairman and Managing Director, CMD of Uranium Corporation of India Limited, DAE. He is a recipient of several awards, namely Scientific and Technical Excellence Award, DAE, DAE Group Achievement Award, and Kullur Memorial Award of IICHE, Atmanirbharta Award of ISAS, etc. With these words, I will request sir to please address the gathering.
Namaskar, Johar. Good morning to all seniors, delegates in the dais and off the dais and online also, dignitaries and participants. Sabko Namaskar. Thanks to RD Regional Director, Eastern Region, and Directors of AMD, and I am privileged and honored for inviting me for attending theme meeting of 75 years of exploration in the Singhbhum Uranium Province. This is historical, yes. So this is a historically, it is a rich history of uranium exploration and mining also. And if you see, it is started with the first uranium deposit discovered in 1951 at Jadavguda. Now, why it has started from the Jadavguda? Anyway, that will be unveiled. But thing is that if you see, based on discovery of uranium in 1951, just immediately after the independence, and thereafter, and before that, AMD started their activity, and it was formed. That's why they are celebrating this 75 years. If you see, with respect to that, we are from the UCIL also, we are stakeholder of being a stakeholder of this uranium. So basically that is also a celebration for UCIL also. And this area, this is Singhbhum Shear Zone area, characterized by the Singhbhum. This area is called the Singhbhum Shear Zone. It is known for its diverse mineral wealth, including copper, nickel, uranium. Uranium mining is the area started 1967, though it was discovered 1951, but mining and other and milling operation or further processing, it was started in 1967. But with respect to DAE activity, this is mining, but uranium activity started just immediately, maybe before uranium activity, just before independence, uranium activity in DAE. As of now, in SSZ, 7 mines and 2 mills are in operation, and a promising exploration domain. Why? This is recent exploration efforts by AMD in south side, that is a SSZ, are oriented to augment additional resources in the blocks adjacent to the established deposit and existing mining centers in order to extend the lifespan of mines. Several discoveries are on the way for making India as strong self-reliance. Appraising that South SSZ, this area, they have discovered a long, about 35 kilometers stretch between Jadugoda and Khejurdari, the southeastern part, and which hosts the major copper deposit with significant uranium mineralization in some known sectors, is being extensively worked by AMD. Conceptual model-based exploration strategy has given encouraging results and has helped to identify new deposit. The potentiality of the quartz pebble conglomeration, that is called in short UPC, at the base of iron ore group, in short IOG, and Danjori group is being evaluated for uranium and gold mineralization in the western and central part of the shear zone. Integrated modeling of the geographical, geophysical, geochemical data along with the subsurface exploration data modeling of AMD helped SSZ continues to potential domain of augmentation of uranium resources and center for focused geological research. Contribution of AMD, especially eastern region of AMD, is sincerely recognized and appreciated. If we go for the AMD's activity in the, after 75 years, basically it needs little review, and then with that respect, one thing we still to get, that is called mineral separation research. That adequately that is to be improved. I feel from my side that is like the moment this is having uranium. If it is a uranium, only uranium? No. So this is, it is having some other mineral also. So that is, what is the road path? Because see, uranium is there, then thereafter whether I can treat it as a waste? No, you cannot. Because it is having maybe copper or gold or molybdenum. So what to do then? That research that is to be done also. Though BRC parallelly they are doing, but it is not adequate. That research scope is lying because UCIL basically it is not a research organization, so that we want that help also. Another aspect I feel so that another aspect that feasibility study, technical, economical, whatever it is, the moment we are getting this mineral, whether it is feasible to mine, that the moment UCL will tell for the with respect to the uranium, then it will be like this. You would not want to work. That's why it should be done from the other party. So, and I will request that AMD should come up with that. My request, then they should, so that yes, this is the economical part is defined. We know all. At least technically it is feasible, and you have to do it. That type of role we want from the AMD. Another thing is that another very interesting research, though we have started in BRC, that is in defined mill, that uranium is being recovered. Suppose some uranium is detectable in the in maybe Jamshedpur. Somebody got that this is some uranium has been detected over here. So from here it has come. Whether it has come from the 3 mills, it may come from the also that is called Tumalapalli also. From that investigation work that is to be done, that is to detect that. Basically, we this was clicked later, but anyway, we have started that job. So whether it is a Tumalapalli source or that Turamdi source or this is a Jadugula source, that will be very difficult during if we do not do that type of job. So that type of jobs are lagging basically, that already we are doing. If you see in last 60 years, uranium has become the world's most important energy material. While uranium is almost, it is generally used for the power, electricity, but very important to mention over that, from the uranium, maybe little bit, and some medical isotopes are separated and used for the societal requirement. And the uranium, who all are in the world, who all are leading, we know that resources सबसे ज़्यादा है Australia. So Australia is having around 28% of stake in the world. Kazakhstan around 13%, Canada 10%. For the supply, maybe reverse or different. But interestingly, abundance of uranium is more than gold, silver, and mercury. Everywhere uranium is there. Here also is there. Only percentage or the quantities are different. In Earth, we know that this is in the Earth crust everywhere, 2.5 or 2.6. Rather, we should tell that 2 to 3 ppm. It is there already. And then in water also, it is having 3 ppb, 2.8 exactly, but 3 ppb in common sense. 3 ppb, water is huge. So that's why 80% is the water in the earth. So you can just multiply, the quantity itself is very huge. But it is not economical, or it is the technology has not got sufficient maturity. Because of that, it is not possible to recover now. In the world, basically, uranium mines, in 10 mines of 5 countries, it is giving 57 to 60% contribution to the world. That we know that Kazakhstan, that Shigar Lake, Basically, Canada, that is giving 14%. But overall, if you see in the world average grade, I'll come to the grade now. So average grade in the world is 0.1%. It is noted and reported. Though we know that it is started from 0.02% to the Canada is having the highest grade, about 26%, 0.02 to 26%. Those who are having that 26%, how lucky they are, because we know the importance of uranium. And for the exploration part, that I will come, that searching for uranium in some way easier. Why it is easier? Rather than other mineral, because it is having radiation. So Becquerel, he has developed, he has discovered that this is a radioactive material. It gives radiation. So that's why, so based on that signature of radiation, generally, and radiation from uranium as well, basically for the decay products. So from that signature, basically, we detect that uranium. And this allows deposit to be identified and mapped from the air. And that is very interesting because of that radiation. Grade control is usually achieved by measuring radioactivity as a surrogate for uranium concentration. It helps for lesser waste rock, so and lesser waste rock removal, and so lesser environmental impact. Uranium mining is no different from other kinds of mining unless the ore is very high grade. If it is a high grade, then processing, mining process, milling process, especially mining process, this needs special attention. If it is high, then special attention is required because of radioactivity and air pollution, then that field pollution and other that ventilation that is to be taken care of, and then more strict engineering or design control and administrative controls are required for the purpose. So it is always, it is not that growth, if the grade is higher, then that life will be easier. It is not like that, but processing life will be little bit comfortable. And then with respect to, if you see, and very interesting that it is in 0.1%, it has been analyzed, 0.1% of uranium, because it is a world average, it is having radioactivity of 150 becquerel per gram, 150 on an average, 0.1% of U3O8. And if you see, after processing, major radioactivity goes to the waste. That remains about 90%. 90% is going to the tailings. And then very interestingly, after some day, it is coming down to 70% because of short life. That short life radioactive materials are decaying. Because of that, it is coming down. And mainly, it is having the problem, if you see that uranium decay series, which basically ultimately it is leading to the, though that end product is late, but in between more there's some radium and radon. For the uranium-238 especially is giving very bad. That I have just compared, I have seen that 235 is better because that radon stability is that is called half-life is very, very less if it is coming from the 235. But for the 238, that radon stability or the half-life is little bit more, and because of that, basically radon gas, that whatever from the 238, it is little dangerous. And parallelly, we have checked that radon gas comes from the radium. That radium is having half-life is much more. Because of that, that needs to be separated. Rather, I will tell that AMD should advocate for that. And then process yet to be, that we know that process, the separation of radium is very easy, but purification of radium is important, though it is a very less because specific activity is more. So that's why in a small quantity also keeping the field much more. All uranium mining and milling operations are undertaken under the code of practice of safety guides. Different safety guides are there, radiation production manual, and then International Commission on Radiological Production, that is called ICRP, sets strict health standards for radiation and radon gas exposure. And strict design control and administrative control mechanisms are adopted for mining and milling. International quality control standards such as ISO 14001 applying to environment management are followed in major mines. Safeguard and other policies are used to prevent military use of it. And then at the last, not the least, congratulations to AMD for successful completion of 75 years and for facilitating and extending the life of South, that is a Singhbhum Shear Zone mining activities for about, that DASA will tell correctly, about 40 to 50 years. So this is a great contribution of the AMD, and this is a basically that contribution to the country, because we know that uranium activities are something different, and for the purpose, that's why the director of MNL is there. Why more people cannot contribute for the purpose? Because handling, because of its radioactivity. That the moment it is radioactivity, some permission is required. The moment laboratory will be radioactive, they will come under the AERB permission. Otherwise, it is not allowed. So, India government, as per policy of the government of India, you have to have the clearance from the AERB before handling the uranium or radiation related activity. That's why not all that laboratory will be able to do these uranium related activities. So for that purpose, I would request, BRC is there one way, but AMD as closely related with the uranium activities, I will tell their that research planning or research activities to be extended much more than the even the BRC. Though the BRC is doing in a different angle, from different perspective, but I should advocate that AMD also in that way, in that manner, that R&D activity should increase. Thank you very much, and thanks for giving me the opportunity to come over here and give some talk over here. So Jai Hind, thank you.
Thank you, sir. Thank you, sir, for your insight understanding in uranium mineralization and Singhbhum Shear Zone. Handling of uranium extraction technology with health safety really inspire the young generation like me and the young generation present in this auditorium. Thank you once again, sir. Now I will request Sri B. Panigrahi sir to deliver the vote of thanks.
Namaskar and very good morning.
First and foremost, I would like to extend our heartfelt thanks to our esteemed guests from various scientific organizations present here. We are honored to have such distinguished experts gracing this occasion with their presence. We are immensely grateful to our esteemed chief guest, Dr. Santosh Kumar Satpathy sir, CMD UCIL, who readily accepted our invitation. He was kind enough to express that he would like to extend all possible support from UCIL side. We are enormously thankful to you, sir. You also mentioned about nuclear forensics and environmental radioactivity. Thank you very much, sir, for enlightening us with your kind words. I express profound thanks to our special guest, Dr. Sandeep Kumar Ghosh Chaudhary, Director CSIR NML, for readily accepting the invitation to grace the meeting. Sir, amidst your busy schedule, you have given us a much valuable part of your time. Your words have truly inspired and enlightened us. Thank you very much, sir. I express humble gratitude to our guest of honor, Sri Dheeraj Pandey sir, our beloved director, who despite his hectic schedule has graced the function. He has always been a source of inspiration and pillar of strength for all of us. Sir, I am sure under your leadership, Eastern region will definitely reach greater and greater heights. Thank you very much, sir, for your kind presence here. I would like to extend our sincere thanks to Additional Director Operation 1, Sri Mayank Agrawal, sir, who has joined the meeting on virtual mode. Sir, your constant mentorship and guidance in planning the exploration program and inspiring us to think out of the box has helped us in successfully organizing this program. I express my heartfelt thanks to invited guests Sri P.K. Sharma, sir, Additional Director Operation 2, and Sri K.L. Mundra, sir, Additional Director Research and Development, for taking out their valuable time in guiding us in execution of this theme meeting and enlightening us with the keynote, who will be enlightening us with their keynote lectures. I convey my deep sense of thankfulness and gratitude Sri S.K. Das, our Regional Director, Eastern Region, and convener of the theme meeting. He has been instrumental in organizing the program. Every aspect of the program, right from planning, arrangement to execution, has been possible because of his continuous involvement, encouragement, and guidance. Thank you very much, sir. It's my privilege to express our collective gratitude to former directors of AMD, former additional directors of Eastern Region, and all retired officials and former regional directors of Eastern Region who has helped steer this region to a greater heights. We are immensely grateful to Sri Manoj Kumar sir, Director Technical, UCIL, Sri M.K. Singhai sir, Executive Director, Sri Manoranjan Mahali sir, DGM Jadugada Group of Mines, for your gracious presence here, sir. It's my pleasure to express our sincere gratitude to JP Mahakul, Director GSI, and his team, Sri Amit Degwekar, Chief Manager Exploration, SCL, and his team, who have readily accepted our invitation and joined the program in physical mode. I express sincere thanks to officers of UCIL and SCL for their participation in physical mode, which has enhanced the value of the meeting. I am sure it will enrich the AMD, UCIL, and SCL synergy. I would like to extend our sincere thanks to regional directors of different regions of AMD, heads of different groups, and colleagues who have joined the meeting by virtual mode. I am indebted to our retired colleagues who have joined by physical mode and virtual mode also. My humble gratitude to Head Planning and Management Services Group Hyderabad and his team for providing editorial support in finalization of Souvenir and Atlas, especially Sri S. Rakesh, who has put tremendous effort in scrutiny and fast tracking of the documents. Thanks are due to Sri Sudhakar Gupta and Dr. Swati Pant, who will be presenting the papers from Southern Region side by virtual mode. My heartfelt thanks are due to the teams involved in this Souvenir and Atlas for executing the task in a very fast pace. A special thanks to the organizing committee for their tireless efforts in planning and execution of this event. Your hard work and dedication means so much to this region. Sri Divakar Ghosh deserves all the thanks for coordinating, organizing the event, and providing all possible technical and administrative support. Special thanks are due to the officers and staff of Engineering Services Group of Eastern Region and AMDC, who have extended all possible services in conducting the meetings in a short time span. I extend my deepest appreciation to dispensary section, administration, accounts, security sections, drivers, and auxiliary staff for their valuable and timely support in arrangement and smooth conducting of this program. DGM Ranchi and DGM Odisha, who have joined this program online, they are thanked for their valuable presence. I have to express my profound thanks to the media personnel available here. We are thankful to our sponsor, Mrs. Geoservices Maritime Private Limited, Navi Mumbai, for their generous support, which has made this symposium provide a better experience. Last but not the least, thanks are due to the persons whose invisible hands are there in organizing the meeting. Thank you one and all. Jai Hind.
Thank you, sir. Now I request everyone present in this gathering in Homi Bhabha Auditorium to rise for national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
We came to the conclusion of the inaugural function of this theme meeting. With the permission of the chair, now I request one and all to proceed for inauguration of poster session and for group photograph, which will be followed by high tea just outside the auditorium. We will gather here again after for first technical session in 30 minutes at 11 o'clock. We will be gathered for first session at 11 o'clock. I, Chanda Maji, behalf of AMDER, Jamshedpur, wishing you all a vibrant learning experience and pleasant time during this meeting. Thank you. Namaskar. Good morning to all distinguished guests, esteemed speakers, and delegates who have joined us through both virtual as well as physical mode today. Before starting the first session of this theme meeting, I would request our convener, sir, to honor Sri Chanchal Manna, sir, with a sapling. Chanchal Manna, sir, is the GM of Ramdi Group of Mines, UCIL, and he has joined us currently. Sir, please. It is with great pleasure that I extend a cordial and scholarly welcome to each one of you to session 1 of today's technical program. This session is dedicated to keynote addresses, with each speaker presenting insights that span decades of pioneering work in critical minerals, uranium technology, and exploration. I request everyone to kindly settle down and ask the other delegates to join us as well, because this session is the most important part of our technical meeting today. So as we proceed, it is my honor to introduce the session chair, Dr. Santosh Kumar Satpathy, sir, Chairman and Managing Director of UCIL. So before requesting you to chair the session and give your keynote address, I would like to introduce you to the audience. Dr. Santosh Kumar Satpathy is a chemical engineer and an accomplished scientist
with over 30 years of experience in uranium processing and extraction technologies. He holds a BTech in Chemical Engineering from Calcutta University, MTech from IIT Kharagpur, and a PhD from SBNI Mumbai. He has served in various critical roles at the Bhabha Atomic Research Center, where he led the uranium extraction division with his contributions spanning nearly 30 years, wherein he managed projects on uranium, thorium, and rare earth processing, metal and alloy production, and radioactive waste management. He is an outstanding scientist who heads the hydroprocessing and special metal facilities at BARC, and additionally serves as the CMD of UCIL, so spearheading uranium production for India's nuclear energy needs. He has received several prestigious awards, including Scientific and Technical Excellence Award of DE Group Achievement Award, Kulur Memorial Award, and Atmanirbharta Award of IAS, to name a few. He has authored several national and international publications and continues to lead major strategic programs under the Department of Atomic Energy. To begin this session, I now invite Dr. Santosh Kumar Satpathy sir, CMD UCIL, to deliver his keynote address on development of uranium technology in India and overview. So the stage is all yours.
Good morning once again. I will start, I will give basically that the DE is sufficiently mature to give the uranium related any solution. Uranium related any solution. That I will just present over here. See, we have started. See, that uranium processing technology in India, you know that uranium is a key element. The uranium is a key element because of that energy security. It is having, this is a material basically जिसका अंदर में energy भरा हुआ है. So what is the use of the uranium? That you can see that is a primarily this is a for the electricity generation and for the purpose that nuclear reactor. For the purpose nuclear reactor. What is the chemical reactor? This is not a, that is to be the, this is not a chemical reactor. This is a nuclear reactor, and that we know also. So along with that, some other uses are there. So other uses are there. This is being a heavy material basically. Density is about uranium metal density is 19 gram per cc. So you can understand this is a very useful for other purposes also. We have started using in earlier days as that is a coloring material, because uranium chemistry is very interesting. Different salts are very basically is having different color. So this is a colorful chemistry. So problem started when that uranium has participated for the fission reaction. And then by the fission reaction, enormous heat we can get. That is because of basically mass difference that we know. And then that is that equal to mc square we know all. So from that point of view, we are getting that this material, that is, we are getting that energy. And energy comparison, these are all known basically, that this is a very, very energetic material. Along with that, here I want to point out that this fission products are basically very, very, that half-lives are much more. So these are basically now people are working on this strontium, cesium, iodine, and then technetium, all those material, how it can be separated out in the back end of the nuclear fuel cycle. So people are working, and then these isotopes are basically very useful for majorly medical application. Then who all are doing over here? We know that AMD is having the starting point. AMD's role is the starting point. So from there, after exploration, then it is coming to the next UCIL, mining and milling activity. Thereafter, it is going for the before fuel fabrication, purification circle. So purification, that is to be done. Thereafter only it can be purification. Thereafter some processings are there, and then after that, that fabrication part is there. Metallurgy and mechanical part. Yes, after that fabrication, it is going to the reactor, and from there it is coming back. Then it is called spent fuel. That is okay. And then what about the change of light? It's not important. Anyway, and thereafter, when it is coming out from the reactor, that is called spent fuel, that is being processed by that DAE also. Because that country has taken the decision, we have to go for the closed loop cycle. That's why this is closed, completely closed. So that's why some rings are there. Thereafter, we started, as I told, the morning also, we have started very early job, and then uranium metal separation was done basically 1959. Before that DAE, during that time, name was different. So DAE already started the job, and then thereafter, and then that uranium activity was started from the rare earth source material. So this is the physical and chemical properties. Here, this is to be noted that uranium, out of all uranium, that uranium-235 is the fissile material, not the 238, and which is having around only natural uranium is 0.7%. And then a specific activity, you can see this is not much. This is in short, basically 25 becquerel per milligram. So as I told, basically, during the processing, basically it is having problem with respect to that radium and radon, because of this radium and radon wastes are problematic, including ore. What is the condition? It is naming that this is a very common for any mining. Here I want to tell that secondary sources are also coming up for contributing to the uranium material. So, and this is known. Simply I've changed the thing. Anyway, that's why I'm worried. Different mining method, basically. These are all different mining method. So where that uranium is, UCIL is standing over here. This is basically few, that is in this shear zone, Singhbhum shear zone. We are having 7 mine and 2 mills. This is the journey of the UCIL. So recently, we are planning for different projects. The problem will come later. So this is the modernization. This is a contribution to mining technology, has been changed, mining process has been changed. Slowly we have adopted, UCIL has adopted with that technology, and then they are usually adopting the latest technology. The problem is that this is if it is the world is having that average 0.1%, but we are setting up the cutoff is the 0.02. And then so because of that, certain high stripping ratio, waste dumping management, exploring the innovative idea for the deeper level of mining, all those problems are coming. And then if you see, this is the mill flow sheet, reduce the DAE. DAE is processing, whether it is acid leaching or alkali leaching. Acid and alkali, only two, because there is no in between or neutral leaching. So acid or alkali, but this is a generic flow sheet. You can see this is after leaching, that is for the acid leaching part, that is a chance of that is called purification, or that is called making of concentrated solution. But for the alkali leaching, that stage is absent. It needs to be developed now. So the work is going on. This is a further value addition to the process. But for the acid leaching, this is all sufficiently mature. This is the acid leaching process. You can see this is basically different slide. Anyway, we'll continue. Time has gone already. This is these are the quality basically. Where is that different for the thorium? Actually, I am not interested for thorium, but that monazite is having thorium as well as uranium. Both things are there. So uranium for the because of uranium, that is also secondary source, monazite. So from that we have the DH have that separation of uranium, thorium, and rare earth from the monazite. That is for the sand. That technology already had. So technology is there. So we are separating out first mineral separation using their magnetic and physical properties and along with the densities. So using that mineral beneficiation, thereafter also process is ready. You can see this is done by the IREL. So process is ready to separate thorium, uranium, and rare earth. And then in the rare earth, basically 14, 15 elements are there, and then separation of those elements are also available with the IREL. Now we'll come to the purification side. You can see we are getting maybe 0.02, 0.03. So we'll start with the 0.02 and more. So and then thereafter UCIL is doing that 75% approximately U3O8 purity, but we have to go 99.9% purity. So we know that every percentage gives needs sufficient research. So and then purity is having the cost. If you see, so that is obviously it will come. So in this slide, though it's not clearly visible, but I will tell that from the whatever that uranium material we are getting, BRC is having all sort of technology, process is ready, available for making uranium in any form and any composition. Like suppose if you want metal, that is also available. That process has been developed. If it is a ceramic fuel, that process is also developed. And then if it is a alloy, that is also is available with the BRC. So in totality, DH is a complete technology is sufficiently matured. Just one example I'll give over here. You can see this is a purification set. If we take this single one, this suppose reduction. So this is a purification stage. After purification, then there is a precipitation. This is the purification, solvent extraction. Then there is a precipitation. So after that, then it is calcined to get the IO3. interesting. Why not from there directly we are not getting by thermal decomposition or so? So that type of options are there. This is the different method. Just one only I will give. So we have developed, all those things has been studied basically, and then based on requirement, then only processes are being chosen. So very interesting. See, direct method, indirect, all those methods are well studied, and based on this physical and metallurgical properties, that process is being selected. It is not only this method has been developed. So, and then one thing that will that uranium metal, basically UET, and that BRC is making uranium metal for the Dhruva reactor only, that research reactor over there for that purpose. That is a metallic fuel. But ingot size, that is called ingot, whatever that production is there, that is basically ingot. Ingot we started in the beginning, we have seen that 44 kg. 44 kg. Now we have the technology single this ingot of 1000 kg. So we have enriched ourselves, batch size. So this is the journey during Corona period. Corona has given so many things, and including this one also. And then I will not take much time. All technologies are available. Here I have to see that radiation is not only that because of uranium we are getting the radiation. So basically radiation contribution of the uranium activity is much lesser than the whatever the public get from the other sources. Thank you very much. I will not take much time. Because time is I should say first. Okay, thank you very much.
Thank you, Dr. Satpathy sir, for this insightful overview on BRC's role in DAE as well as the process flow sheets. Sir, I request you to chair this session, please. The rapporteur for this session will be Sri M.K. Birwa sir. Sir, I request you to kindly assist the session chair with technical notings. Moving forward, we are all eager to hear from Dr. Sandeep Ghosh Chaudhary, who is the director of CSIR NML, and is known for his work in rare earth metallurgy and strategic materials development. It is an honor to introduce Sir to the audience. Dr. Sandeep Ghosh Chaudhary is a leading metallurgist and the director of CSIR NML with over 25 years of distinguished research and leadership in alloy development, thermomechanical processing, and phase transformations. He is also a professor at the Academy of Scientific and Innovative Research. Dr. Chaudhary has been honored with several prestigious awards, including Fellowship of the Indian National Academy of Engineering in 2022, Metallurgist of the Year by Ministry of Steel in 2015, Alexander von Humboldt Fellowship of Germany, multiple B.R. Nijwan Awards and technical paper recognitions at NML. He has held visiting professorships at top institutions in Germany. He has over 125 journal publications and 20 patents. He also serves as an editor of the Transactions of the Indian Institute of Metals and has several other accolades to his name. Sir, I request you to kindly give your presentation.
Yeah, surely. So I was worried she was introducing me for so long and it is repetitive. Anyway, thank you very much for bringing me here at this program of 75 years of exploration in Singhbhum Uranium Province. And today I came to know that Singhbhum Shear Zone, SSW, I think that's a very important milestone for us. So this is my laboratory, and I'll be talking on these extractions of rare earth elements, the role of CSR-NML. Obviously, I don't work much on this nowadays, but this is done by my colleagues. So my acknowledgement to them, and as because we are 75 years, that's why the logo on the other side is 75 years logo on that. Well, when we talk about the rare earths, so these are the various critical elements tapped by CSR-NML, which are marked with rights, that is rare earths elements. We call rare earths because we require a lot of things in that, but unfortunately, most of the things are, you can find it out, there's 100% import, 100% import. So they have become very important for us in the daily life, whether it is energy security or in our daily life. There are several equipments we are employing, whether it is a medical or whether it is our regular social things like mobile phones and others. So this is a necessity for our days. It is no more luxury for us today. So what we do that, I think last Dr. Satpathy has shown that monazite was there in the beach sands, and the monazite, the quantity, it was in single digit, I think 7 point something, whereas the others are in double digit in others. So you can understand that what is the quality of those things or the quantity of those things. So out of those things, we just get that rare earth oxides, and then we can try to make high purity rare earth elements. Today we have lanthanum and cerium, thanks to IREL, because they have a plant in Bhopal, and through that element, with the help of DMRL technology, today at Vizag, we have a magnet manufacturing plant in Visakhapatnam. And we are also trying to have those things. It is a prestigious project for us because in India, we had no other magnet materials, but nowadays we have. And approximately there are mixed rare earths and individual rare earth oxides and halides. And the major area too, that is the recovery of the rare earth are products from the secondary resources. One is the first, that means that they are ores, that is the primary resources, and the secondary resources. Primary resources, as I said, that the quantity is quite low, but when you talk about the secondary resources, yes, the concentration is quite high. So as per the yield, you can find it out, yes, but then there is another problem comes up. So I'll just show some of the things out of those things. So these are the major areas like salt for neodymium oxides, gadolinium, neodymium pristinum alloys, and then there are major areas too. We have quite a bit on that line. These are the facilities we have. We don't work only because when NML was created in 1950, the purpose of these things that we have a lot of boards, like the AMD has been created. Similarly for us, the metallurgical industry that will serve in Tata Steel or the regular industries to get our natural resources. And why that time it was Bihar, because this is the belt where it is highly rich with respect to the minerals. So we help the country to get those minerals, and then there are industries which came up in the first 5-year plan, the second 5-year plan, a lot of steel plants and others, non-ferrous industries, so they can get those mineral beneficiation unit, and that's why you know that each sale is also nearby. So we help them. Although there was a bad patch for the HCL, but I think now they are going ahead, and we are working with their Odisha plant also nowadays for upgradation of the copper in that. So these are the techniques, and we have not only at near that station where we are, but we have 2 other places where we work with the pilot plants. And these are the one of the examples of those pilot plants at our places. And like some of the cases, you can see that your capacity of those things. And really we are working nowadays to make it pilot scale so that the industry gets interested to make some plants out of those things. So these are the things, monazite, Korean and Indian, these are end-of-life products, and then the industrial residue. So our aim is to get all these materials out of those things, but these are the elements which will come up from those things. So let me give you something like we work with neodymium, gadolinium metal from salts, and we try to have some kind of a electrolyzer, because there are various pyrometallurgy, hydrometallurgy, and electrometallurgy. You people are very much well famous with the hydrometallurgy, because that's the one you can do with this selective bleaching and all these things. But here we are using the salt and high temperature so that it gets dissociated with respect to the anode and cathode. And we also work in these areas on this, not only neodymium and gadolinium. Gadolinium is of course interested for you that in your nuclear power reactors. So we helped to give some 50 grams or some 500 grams to IGC or Kalpaktam on that region, whether they can find it out that the purity of this gadolinium is all right or not. This is from the rare earth recovery from the end of life spent neodymium iron magnets, because today India is not only buying your defense products, rather India is exporting the defense products. So whether it is a missile or any other your healthcare units and all these things, the magnet is a very important factor. So we're not only interested in the soft magnets, we are interested in the permanent magnets. And as I said you, these spent magnets, we have plenty of spent magnets, although there is no Indian company who makes those things. But DMRL and we are now projecting onto those things, although we tried to work on those things. So based on our work, now the DMRL has tied up with that will come up with the spent magnets, and the spent magnets will make the actual ND out of those things. And then, and of course, if I can make ferroboron. And when I talk about all those things, please assure it is not like metallurgical grade or things. It is a high purity on these things, because otherwise the magnetic product will not be of sufficient utilization, and we have to again depend on the China itself. This is also work with this phosphor, because we are so-called societal elements. So in the Ministry of Mines, in this critical elements list, and out of the 30, you will find phosphor is there, because phosphor is very much required for our agricultural purpose. So that's the thing which we are trying to do. And we had gone up to 50 kg scale, and we have shown it to this Food Corporation of India, all those things, that this is the way we can get into out of those things. This is again the recovery of samarium, but again, this is the secondary sources. So this technology is yet to see the light of any things which can come up with that. But I hope that when Visakhapatnam plant will be ready and we are producing the samarium cobalt magnets, that time it will be vital, because we will be producing, and generally the magnets life is 20-25 years. So that time, and we are also upgrading the process, because unless and until you give a cost-effective solution to the industries, nobody will be interested on those things. So that we are trying to be in that, so that let's see that at the actual time, our process can be working on that places across India. This is one of the very prestigious project for us, that is rare earth metals from the EV batteries. And we are trying to get it several things out of those things. And like Nova Sense Recycling is a very young guy, and that Asim Tripedi, he now got a license from Rajasthan government to make his own plant. And I think if you go to this Nova Sensa and you put the LinkedIn, you'll find him. Every day he is doing something in that, and very energetic person for me, is that because he makes our life easy and make publicized NML for this kind of work for those things. This is another project, Red Mart. This is a Niti Aayog project, and there are 3 aluminum industries today in India. Although when we were students, except Nalco and Balco, there is no more aluminum production companies are there. But today we have Nalco, we have Hindalco. Balco has been bought by Vedanta. And one company which could not or lost is that is Starlight. So we have a Balco, we have Vedanta, we have Hindalco and Nalco, these 3 companies, and we have NML Jamshedpur. Then we have our sister organization IMM Bhubaneswar, and JNRDDC, which is under the Ministry of Defense, Ministry of Mines. We 3 work together, because India, this aluminum industry, they produce a lot of red mud. The mud, because that is a pond kind of things. If you go to Mumbai, or if you go to Jharsuguda or Bhubaneswar, you'll find wherever this plant is, an Angul plant of the Nalco, there are just next to that there are a pond, and this has red mud. It's in that Ministry of MOE FCC, you'll find that it is also hazardous things, because if it is there in that places, then it will be dangerous for that. So how to get the rare earth elements out of that? And one of the very prominent rare earth in that is the scandium, because that is used for the aluminum industry. Because aluminum and scandium, we can make a very high temperature aluminum alloy, and that can be used for our space as well as for our defense applications. So this 12th June, Dr. V.K. Saraswat is going to launch the actual report of these projects, and my colleagues have done it, that whatever it was there in the level of 0.1 or something like this, now we are going to have 3%. So obviously we could get something out of the red mud, but there is another part that we can take out the scandium and all these things, but the red mud, the residue is there. So now people are working whether the residue can be worked on those things, so that ultimately the full waste to wealth utilization can be done. Now this is the way forward for us, that we want to upscale and the process improvements. And of course, we are trying to work with reactive distillation of IRE metals for high purity metals, because today when I talk about these things, so I was there with that, because we work in the metallurgical industry, and they are 95% is okay. All right, but he said, no, Sandeep, it is not the 95%. You have to come to 99.99, at least the 6N or 7N is the purity. So then only you can think of that the semiconductor industry or any electronic industry can be interested to make your things product into those things. So that's why we now change over ourselves. There is no more metallurgical industry, rather we go to this high purity metals. So do those things. And one of the high purity metals is that either you go for the electrochemistry or one of the by this pyrometallurgy, because these are the ways you can make those high purity metals. Because hydrometallurgy, some other trace elements come into picture, but then you have to again tune those things with the pyro and the electrometallurgy to purify all those things. Now, just to give it to one thing that, we worked, NML was the first company who are the first laboratory who make the magnesium in the 60s, the 56 to 9. We did it, but unfortunately we transferred the technology to a company in Vizag. The company could not because of the Chinese incursion. The source low cost they have provided. So across in the globe nowadays, China is the sole producer of magnesium. Now magnesium is recorded not only is the lightest element required for the automotive, but it is a very strategic nowadays. The strategic in a sense, our titanium industry, there is a defense metallurgical research lab or DRDO, they require the Crolls process, the TiCl4 transformed to titanium if the magnesium is there. So magnesium chloride and the titanium comes up. Now the zirconium, which your parent organization requires, zirconium chloride to magnesium, so it is a magnesium chloride zirconium. So that's the reason why magnesium is now becoming a indirect strategic materials, and that's what we are trying today. That on that again started, though we didn't stop in that, but what we tried to work in that now not only the magnesium as a from the road, because we have a lot of dolomites across our western belt as well as in Jharkhand also. We are not only like this, we are trying to work in the magnesium scrap. And what my people have told her, or the DMRL and other people, that don't restrict with the 99.95% purity, rather it is higher purity, because whether the zirconium or titanium we are talking about, it should be highly pure. In that case, the product titanium and zirconium also will be pure. So that's what we have tried, and my people have already done it 2.5 kg, and now in that pilot plant we are going in a very ambitious project. It is already 1.5 years over. We are now trying to have 120 kg per day, which cost will be lesser than the Chinese. And if we make a mass production more than 120 kg, then the cost will be coming down below the Chinese. And obviously the purity is 99.95 purities that we are restrict on those things. So it can be applied for the defense industries as well as for the atomic energy for the purpose of zirconium reductions. So this is the magnesium metal. I'm not going to those things. And the next one is the sodium, which is also important for this BRs and others, because sodium is nowadays, after this Fukushima blast, I know that sodium is one of the best coolant for those things. So we worked with this, and now that 300, we did up to 500 amperes in our lab, and then we went to that 3000. I know I'll coming back to those things. Yes, I'll not take too much time. So this is one of the areas where NML is prominent. There is the Urban Recycling Center. And this is the Indian map that where our technology is there. So I proudly say that we are in most of the cases, except some of the states where their in knowledge on this is very, very poor. And this should be 2 more additional of that. Like we are working with one Chennai-based plant. Of course, they are basically from Calcutta, but they're going to make this plant in Chennai, and another Hyderabad-based plant is coming up to take our technology on those things. I'm not talking about those things. That we are also working on this battery to battery, that the Spain batteries we are taking care of, and then trying to get those lithium, nickel, cobalt out of those things and try to make the new batteries. Of course, we are not the expert in battery making, rather we have another sister organizations, they are in those things, but we have giving them those things out of those things. And then tungsten, obviously we did it for the defense, but what we are trying to work on nowadays is polymetallic synnodules. You know, this is synnodules which is there very much in our coastal areas. When we started this project in the 70s, I didn't join at the time, but India worked a lot of things on this, that we have so many oceans and we can't put those things. But today the technology has been improved. Now there are underwater vehicles who can go deep into those things, and India can go up to 200 kilometers across both the seas, either Indian Ocean or it is Arabian Sea or it is the Bay of Bengal. We can go those things and we can get those things, and we have cobalt, we have manganese, we have nickel and all those things out of those things. So this is coming up in a bigger way for our polymetallic nodules, and this is the one which we try to work on those things. And the last one is that this is the one that we are trying again in a project on spent solar panel. What important in that, this spent solar panels, we get the silicon. We are not interested in the metallurgical grade silicon, but again, taking the silicon, making it a purity of the 9P7, 7N or 6N purity and put it in the photovoltaic for the again. So that today, whatever solar panels are there, they are 25 years old. And I hope that my colleagues will be happy to make it that such a cost-effective solar solutions or recycling solutions for the silicon. And not only silicon, solar panel also uses silver. Today, silver is a very good jewelry things. And you know that how much production, if you go from silver ore to the silver, it requires nearly 1/7 of that carbon emission of that is 1/7 when you go from solar panel to the silver for those things. So this is not our data, this is the international data. So this is the way we can reduce the carbon footprint of those things. Today, the electronic appliances, we have plenty. I think all of us have plenty of this kind of electronic appliances. So how to get those things? There is a small PCB inside those things. It's a small, but the concentration there is very high. So that's what we're taking. We're taking the LEDs. Today, you have all those LEDs present, but not only LEDs, I do not know the screen, but nowadays everybody is talking about smart city. So there are a lot of screens, a lot of billboard and all these things. But there are a lot of other material, iridium, which is very important for us. So that is there in that. So that's the technology we're trying to do those things. And of course, the air conditioner. It is no more a luxury for us that we have air conditioners. It is a necessity that we have to have air conditioners. And space like Jamshedpur and others, you require all those things. So the air conditioner, there is a high things is that high pure copper. So which we can get it from out of those things. So these are the few things which we'll be doing it for the next couple of years and we hope that we'll get back with good technology which can be transferred easily. Thank you very much.
Only one remark, sir, that magnesium you are trying to produce, that is a great, but you please do that job also, because ultimately suppose NFC zirconium material they are producing, but in the last it's scroll process, whatever you told, that they are doing chloride route. So then ultimately magnesium is converted to the magnesium chloride. So magnesium from the magnesium chloride, that technology is recently required.
Yeah.
Can help in that line that.
Yeah, that is also the brine solutions we are trying to make it. That's the electrometallurgy route we'll be trying to unlock. This is fully pyrometallurgy, but that will be your electrometallurgy. Yes, that also in tandem with that, so that the magnesium chloride which is there, that can be again further utilized for those things.
Very much, sir. Thank you.
Thank you, sir, for enlightening us with the recent advancements in the metallurgical aspects of rare earths. I request the session chair, Dr. Satpathy, sir, to honor Dr. Sandeep Ghosh Chaudhary, sir, with a memento. Moving on, now we'll be hearing from Sri Dheeraj Pandey, Director AMD, a key figure in uranium exploration across the nation. Sir, please let me introduce you for 2 minutes. So Dheeraj Pandey is a veteran exploration geologist. Sir, please.
Thank you. Since this is a celebration of 75 years of AMD's achievements, thought it prudent to have this topic, the OA, 75 years of exploration Odyssey in the Singhbhum Uranium Province. Singhbhum, as you know, copper uranium belt of India, has been worked since quite long. And for India also, it is a landmark area because our investigations for uranium started in Singhbhum. You can see those photographs. It was Homi Bhabha's foresight, great visionary, that even before he set up the Department of Atomic Energy, he set up the first task force under the leadership of the doyen of geology, Dr. D.N. Wadia, to explore uranium in the country, because he knew that this is the raw material which is required for the nuclear power program. And a steady supply of these materials will be required if you are to pursue this ambitious nuclear power program. And having known at that point that there were very modest resources of uranium, he envisioned a 3-stage nuclear power program where thorium, which was abundant in the country's shores, could also be utilized. So subsequently, you know the history of AMD. It was set up in July 29, 1949, under the leadership of Dr. D.N. Wadia, and subsequently it was renamed AMD later. And since 1949, AMD has been continuously working in the areas of mineral exploration that are required for the nuclear power program of the country. This already Satpathy sir has shown. So here you can, I'll just point out that besides the front end, AMD also works in the middle for site selection of nuclear power projects, and of course at the end for the site selection for the repositories. This is how AMD was formed. It started as a rare mineral survey unit in GSI during the World War, primarily to look for beryl. Subsequently, in 48, this RMSU was transferred under the Ministry of Natural Resources and Scientific Research, and consequently, on 29 July 1949, as I said, this was brought under the control of Atomic Energy Commission. And in 53 and 58, it went renaming from RMSU to Raw Materials Division, that is RMD, and subsequently to Atomic Minerals Division. That's how it came to be known as AMD. And on its golden jubilee, it attained the status of a directorate, retaining the acronym of AMD. Coming to the history of exploration in India for atomic minerals, it was way back in 1909 with the discovery of monazite on the shores of Kerala that the radioactivity was discovered by Schorner, a German chemist. And in 1913, as early as 1913, the records of Geological Survey of India, they show that the occurrence of gamete and a 36-pound uraninite nodule in Gaya district was observed. And later in 1990s and 20s, Murray reported the occurrence of torbanite and autunite in Singhbhum. So actually, the occurrence of uranium in Singhbhum is recorded as way back in as early as 1920s. And subsequently, the first extensive surveys, as I said, the task force was formed for the exploration of uranium. And the first extensive surveys for uranium in Singhbhum began in 1949. There was a team of 18 members, 7 each from AEC and GSI, and 4 from Damodar Valley Corporation, led by V.R. Ketkar. And they surveyed this entire Singum Shear Zone. And as Satpathy sir was asking why we started from Jaduguda, because it was the analogy was followed from the vein type deposit in Shinkolo Bay of Congo district, where copper was occurring in association with uranium, and in Rocky Mountains, USA. So that time it was thought that this is the ideal location because already copper mineralization was known in Singhbhum belt. So the uranium investigation started from Singhbhum. And in 51, the first report on radioactivity in India for regarding exploration for uranium was submitted by the Ketkar committee. And subsequently, in 1955, we had the discovery of Umura deposit in Rajasthan. The first airborne radiometric survey in the country. AMD again is a pioneer for these. It started way back in 1955. And in 1957, the exploratory mining started at Jaduguda and Umra simultaneously. So you can see those photographs, the drilling rig in Singhbhum, exploratory mining in Umra. These are from the archives. This is the left side photo that you see is the photograph of the first page of the report. And a total of 57 anomalies were reported by Ketkar and his team in 1951. And in the bottom right, you see the first anomaly location near Jaduguda, which was reported by Ketkar. And now till 2013, the uranium mineralization, the deposits in Singhbhum, we were classed as vein type. Structure controlled vein type hydrothermal mineralization, we used to call it. But in 2013, IAEA came up with a new classification wherein these vein type deposits, they were classed under metasomatite and metamorphite. And subsequently now the Singhbhum deposits are classified as metamorphite types. This is a uranium map of India. The highlighted ones that you see, the metamorphite type in Singum Shear Zone, granite related in Bhima Basin, and metasomatite type in the North Delhi Fold Belt in Royal Rajasthan. All these earlier was classed under vein type deposits, and now there is a subsequent change after 2013. Those vein types are now recognized as metamorphite type in India, granite type, granite related, and metasomatite type. These are the progressive changes in the uranium exploration strategies. Exploration till the late 70s was confined to these shear zones in India and this granite hosted uranium mineralization. But subsequently in late 70s, we had a paradigm shift in exploration strategy. We started exploring the Proterozoic and Phanerozoic sedimentary basins which are developed close to the fertile granitic terrain in the country after the discovery of Cigar Lake and those deposits, unconformity type deposits in Canada and Australia. And in the right side, you can see how progressively the exploration has been followed. In 51, it was the first report of mineralization. Then 56, discovery of vein type mineralization in Umra. Subsequently, this vein type in Bodal and Chhattisgarh in 1973. Then first unique strata-bound hosted uranium mineralization in Tumbalapalli in 1986. Subsequently, uncontrolled type deposits in Lambapur, Telangana in 1991. Then sandstone type deposits came up in late 90s, 94. And in 1997 came the discovery of Bogi. And after that, the success story continues. As on today, we have almost 428,000 tons of uranium oxide in the country. Coming to Singhbhum Odisha Craton, this well-known geology is there. Only thing I would like to highlight here is that the crustal growth of the Singhbhum Craton has extended over a protected period of 1.5 gigaannum, right from 4 to 2.5 gigaannum. And this already, it has been pointed out, it's a copper uranium belt. Of course, many other critical elements are associated, for example, like molybdenum, nickel, and tellurium. And it has been the province of India's first uranium discovery. And as on today, there are 17 uranium deposits in the Singum Shear Zone, and out of which 7 are being mined by UCIL. Coming to the reappraisal of uranium exploration in Singhbhum Copper Uranium Province. So as I said, there was a strategic shift of exploration between 70s and 80s, consequent to the discovery of unconformity type deposits in Australia and Canada. We shifted our focus to the Proterozoic and Phanerozoic basins for different types of mineralization apart from vein type. And we did discover some mineralization in Bordal Jajawal sandstone type in Domia. But due to various constraints, logistical or socio-economic constraints, commercial mine development outside SSZ did not materialize because of these constraints. So again, in the 80s, the focus shifted back to Singum Shear Zone because this was a known province. Subsequently, Turamdi Group, Bagjata, Kanaluka resource augmentation took off. And as I referred up to these multiple cutoff grades, optimum grade utilization in Turamdi Group, that exercise in 2003, that led to the utilization of these deposits. The Turamdi deposits came up, both the Bandurang and the Turamdi, and subsequently the Turamdi mill also started functioning. And now after 2008, there was a shift in, again, the exploration strategy. Now we are targeting the blocks which are contiguous to the existing mines to increase the mine life. And significant resource augmentation has been done in Banadungri and Rajda in central sector, close to Narva Pahar, and Bangurdi in the western sector. These are all mineable deposits, as and when the UCIL requires it, the same can be mined. Again, this is mostly a repetition, showing the milestone in Singum Shear Zone. Here, the important thing is, in 1957, the exploration mining commenced in Jadugoda, and in 67, the commercial mining started. So as early as 1950, 51, the discovery was there of the anomalies. 57, the exploratory mining commenced in Jadugoda. Then in the 2012-16, as I said, several landmark, it was a landmark year. Moholdi mine was commissioned. Jadugoda North exploration was completed. The Baglasai Mechwa exploration, both the contiguous blocks north of Jadugoda, that has given the second largest deposit of India as on today. The discovery of Kudada was also there in that particular decade. And in 24, the total resources in Singhbhum crossed 1 lakh ton. And as I said, with the kind of exploration that we are doing and the augmentation we are getting, Singhbhum province may soon become the largest uranium resource, may give the largest resource from, we may get it from Singhbhum. Now, currently, we are employing advanced techniques to explore for uranium using the high resolution remote sensing, airborne and ground geophysical surveys. We have deployed this hydrostatic drilling rigs for enhanced productivity. We have introduced state-of-the-art analytical facilities like borehole multipara logging and trajectory logging systems for boreholes. And on the left side, this is just an example. You can see this is the total magnetic intensity map of central part of Singum Shear Zone, where the magnetic anomalies, the breaks in the magnetics can be used to mark the major faults like the Tirukocha, East-West Tirukocha, the Pathargoda, Sorda, and Gohala faults. And along these faults, you are aware that we are getting good mineralization both in Tirukocha area, that is the Baglasai Mechua, Sorda Pathargoda sector along these Pathargoda fault. And of course, there is a shift between Kanyaluka and Bagjata deposits because of this Gohala fault, and we are using that conceptual modeling to explore that particular area now. This is one example of that Bagla Saimacho, which I already said. It is within last 10 years, we can see this conceptual modeling and new approach to exploration. It has added more than 30,000 tons uranium. So it is a big work done by Eastern region, and I congratulate the entire team of Eastern region for that. Again, this is the same. You can see the shift in the Jadugoda load. The dexterous slip along the Tirukocha fault for more than 1 kilometer. This is the ore model of the body. Here you see the Jadugoda mines of 1957. Bhatin started somewhere in 1962. And subsequently now this is the new block, Jadugoda North Baglasai Mechua block, just adjacent to the Jadugoda mines, which is giving us now more than 30,000 tons. That is almost 4 times the resource of Jadugoda. Again, a recent discovery, the Kudada. It's a unique polymetallic mineralization in a rock which is unknown in the rest of the part of the world as on today to host uranium mineralization. So it is a very unique kind of a deposit. Still, we need a lot of studies to see what is the kind of genesis that has led to this kind of mineralization, because it is basically a rock, a peridotite, serpentinized peridotite, which theoretically should not contain economic grade uranium. But the facts are otherwise. 3,500 tons of uranium, along with chromium, copper, nickel, cobalt, molybdenum, and magnesium, and rare earths. So it is a very unique kind of a deposit, and it is a challenge, as the RDR pointed out, I should say opportunity for Eastern region to come up with a detailed kind of a study to really pinpoint the genetic aspects of this kind of a mineralization. I could talk about Surda Pathargoda area. Here you can see this is the Pathargoda fault. It has displaced the Surda mineralization along this strike slip. Movement is there, slip along that strike. The load has now come up here. So again, we are targeting these areas, and we are getting one of the very good mineralized sectors in SSZ. These are some of the upcoming areas. We have already established, after 2000, we have already established 2 deposits in the western sector, that is Rajgaon and Bangurdi, 2 in the eastern sector, that is Bagjata and Kanyaluka. And in the western sector, now we are working along Bangurdi extension, Simulbera, Rangamatia, Sankati. Kumari Kamalpur, we are trying to link Mohaldi and Bandhuran. This is the intervening area. And Surda I have already talked about in the eastern sector. This is the result of the exploration of AMD. There are 6 underground mines which are now being run by UCIL, and 1 open cast mine, the only open cast uranium mine in the country at Bandhuran. 2 mills, one at Jadugoda, another at Turamdi. Now, summarizing the entire exploration in Singhbhum for the past 75 years, you see there have been 3 major phases of exploration, right from 1950s to 1974. Subsequently, there was a gap when we shifted to other areas, the Phanerozoic and Proterozoic basins. Again, came back in 80s from 79 to 2000, the second phase. Then there was a shift in that paradigm shift that I was talking about, our conceptual modeling and all that came around 2007, and we are still continuing. So till now, almost 9,96,000 meters of drilling has been done in Singhbhum since 1950s, with a resource productivity of almost 10 meter per ton of uranium oxide, which is one of the lowest in any part of the country. Thank you for the patient listening. Last year, actually on 29th July 2024, we unveiled our new logo, this one, and the tagline, innovation through exploration. So I hope this kind of activity will continue. We have to innovate, and of course, attain Atmanirbharta in atomic resources. And once again, my congratulations to Eastern region. And Eastern region has to play a big part if we have to achieve Atmanirbharta in this atomic minerals. So thank you so much. Jai Hind. questions, if someone has, I'll answer.
Sir, one question, whether for the uranium cutoff grade you are putting 0.02 or molybdenum, what is the cutoff rate?
Sir, what we have done is, I'll give you an example of Rohil. Whatever uranium loads that we have in Rohil as of now, we have taken those uranium ore loads, analyzed that particular load for multi-metals. For example, in Rohil, we have molybdenum, copper, cobalt, nickel, vanadium. So within the ore loads, we have taken the cutoff for uranium as O2. And within that particular load, we have calculated the concentration, the grade, and the tonnage of these associated elements. So for example, in Rohil, I can tell you, we have around 4,800 tons of molybdenum associated with the uranium, and almost 21,000 of copper, tons of copper. So this is how we are not calculating the cutoff grades for different associated elements. We are taking the cutoff for uranium, and in those ore loads, the content of these associated elements is being calculated.
Thank you, sir, for walking us through an impressive legacy of AMD in resource development in strategic minerals. I request the session chair, Dr. Satpathy, sir, to honor Dheeraj Pandey, sir, Director AMD, with a memento, please. Up next, I take immense pride in welcoming Sri Prem Kumar Sharma, sir, who is the Additional Director Operations 2 of AMD. He's a senior exploration geologist with over 36 years of experience in Atomic Minerals Directorate. He's a postgraduate from Kumaon University. He has significantly contributed to uranium and atomic mineral exploration across diverse geological terrains of India. His major achievements and contributions include leading aerial surveys and geochemical explorations in regions such as Shillong Basin, Meghalaya, NDFB Rajasthan, Chotanagpur Granite Gneiss Complex, and in the Himalayas. Coordinating strategic exploration activities in the Singum Shear Zone and the CGGC terrain as Deputy Regional Director. As Regional Director of South Central Region, he has successfully led several uranium exploration activities in the Kadapa Basin and supervised effective functioning of laboratory and field operations. As Additional Director, Research and Development, he has guided various activities of groups such as beach sand and offshore investigations, rare metals and rare earths, instrumentation, physics, chemistry, airborne survey and remote sensing, exploration geophysics, and Atomic Minerals Data Center. In his current role as Additional Director Operations 2, he oversees exploration activities across northern, central, and south central regions, as well as multiple technical divisions, including airborne survey, remote sensing, and geophysics. He has contributed to over 40 national and international publications, reflecting his depth of expertise in atomic mineral resource development. Sir, I request you to please deliver your keynote address. The stage is all yours, sir.
Good afternoon, sir. Lot have been told about the uranium status in the Singum Shear Zone. So I will be talking about this, about the high resolution geophysical data, which is very much important for the uranium exploration. And as our director has told in the morning session that we are the first in the country which have utilized this airborne surveys since 1955. Earlier, we were doing only the radiometric and magnetic surveys, but later with the advancement, now we are doing, earlier we are doing fixed rig surveys, now we are doing heliborne, this high resolution heliborne survey using all radiometric, magnetic and radiometric surveys, electromagnetic surveys. So for the benefit of the youngsters, my colleagues, I will say that while using this airborne survey data and this other remote sensing data, we should be very much careful. We should know that how we should utilize it, what are their limitations, what they indicate, how in exploration we should use it. And so my topic is high resolution geophysical data in the SSZ. As we have flown complete SSZ earlier by these heliborne surveys, that is a very good tool for identifying the potential targets. Next, please. Yeah. Okay, so just a brief background I will give here, the Singhbhum Shear Zone. This is the Googlean, the IRS 1C satellite image of the Singhbhum Shear Zone. You are seeing there. कर रहे हैं थोड़ा कर दीजिए फुल स्क्रीन yes, so it is a 200-kilometer long belt. As you are seeing that red line, below red line, that is its thickness is varying from 0.5 to 5 kilometer, which extends from the Behragoda to the Dota Pahad in the west. It is passage in the northern part of the Singhbhum Craton and having this contact with the North Singhbhum mobile belt. And this Singhbhum Shear Zone is having, as I told earlier, varying thickness, so it widens in the central part and it bifurcates in the western part. Next. This is there are actually, as our director told earlier, now there is no vein type of mineralization as such, but for that all come in the metamorphite type now as per IEA classification. Next. But there are if you go that 4 distinct types of uranium deposits and the occurrences are there in the Singhbhum Shear Zone. Next. This first is type 1, that is in the mainly Jaduguda Bhatin and this Nimdi Jublatula area, which is mainly in the quartz-granular rock in the matrix of quartz pebble conglomerate and typical vein type mineralization. Then type 2, that is in mostly in the biotite chloride cyst and quartz muscovite cyst. It is also fracture controlled vein type mineralization. Next. This is third type, that is in the this Turandi, Narwa Pahar, Bandurang, that main host rock is chloride quartz cyst. There it is the strata bound, sorry, it is stratiform fracture control mineralization. And this last one, fourth, that is the in between Bandurang, this is typical strata bound disseminated type of mineralization you see. Now all these come under the one category, that is the metamorphite type. However, the host rock and this ore body type is a little different. Next. Besides this, there is different serpentinite hosted fracture control mineralization we have got in the Udada area, which earlier it has been discussed. Next. Now I am coming to the most important part. As the director told, there are 15 types of the uranium deposits are there for in Indian constant contest. Uncorrelated sandstone and metamorphite types and metasomatites are most important. These deposits are characterized by distinct lithology and structural features. And even in beach sand, you see, they are characterized by the different radioelemental signatures. RMRA deposits also, in the different deposits in the country, they are characterized by distinct radioelemental and signatures, structural features. So the heliborne geophysical survey, what we are talking about, it aids in the direct ways as well as indirect ways for the exploration of these deposits. Youngsters should understand that directly only this radiometric data which gives uranium, thorium, potassium distribution is helpful in the exploration. However, this magnetic data and this electromagnetic data that is helpful in directly telling the indirectly helps in the narrowing down the target areas for further exploration. Because sometimes mineralization is associated with the conductors and controlled by the various structures. So indirectly, these electromagnetic and magnetic data help in the identifying areas and going from known to unknown areas. So the role of here Hellebone survey, how it comes. It is very important this acquiring this data because it is a high resolution data. And there is simultaneous large area is covered in a small time, and it gives the broader picture of the whole area. And there is very good accuracy. Data perfectly in grid pattern because in perfectly line interval the data is collected. This gives some information up to even 400 meters in the case of electromagnetic, and this radiometric it is very thin superficial information. And it is a very effective tool, as I told earlier, in narrowing down target areas. And 2D, 3 modeling and the model-based areas can be identified for the further exploration and going from known to unknown. Next. This is the area in the Singhbhum block, which has been covered by this Hellebone surveys by all magnetic, time domain EM, and the gamma spectrometry in 2011-12. And most of you may be knowing, and it has been studied very well. And many new areas have been extrapolated based on this data, and we are exporting there. Next. You see that, as what Dr. has already shown, this magnetic data clearly, this is the magnetic image of the Hellebone data. So it clearly brings out the structures. And first, the curve in the feature of the Singum Shear Zone, and the structures you see, many faults. You see there Pathargora fault, Tirkocha fault, Guhala fault. How nicely this magnetic data shows the breaks, and you see the thickness of this Singum Shear Zone. As we go to the western part, the thickness is 3 to 4 kilometers. In the central part, it is 0.5 to 1 kilometer, and in the east of the Guhala, it is about 1 to 2 kilometers. Next. Next. Just next. This is the TEM data, which time domain electromagnetic data. Here the decay constant analysis, that is the in geophysical term, highlights the presence of conductors in the western part as well as in the central part, and some in the very clearly it gives the conductors where these are present. Not directly these conductors are associated with the uranium mineralization, but they are very useful and associated and can provide a clue for the base metal. It provides a clue for base metal, and sometimes they are associated with the uranium mineralization. Conductors in the central part of the display SSZ, they are associated with known copper deposits, and also they are, have indicated the high tau values. And these conductors in the central part, many places, has indicates the alterations. Next. This is you see the ternary radiometric image. This is the uranium, thorium, and potassium image, which has highlighted the presence of uranium occurrences along the shear zones. You are seeing the number of blocks demarcated by these yellow blocks. They are the blocks identified by this radiometric survey having the higher uranium content based on uranium U by TH and U by K ratios. And this Singhbhum granite you see is indicated by red and whitish color in the southern side because it is having high potash content. Next. This is that integrated map based on this radiometric, magnetic, and TMI data. And these structures are demarcated by this magnetic data mainly, and the anomalous zones from this T1 to T10 have been identified based on this radiometric data, and EM data is also used for seeing the conductors of that area. Next. Up now I will say some case histories are there. I will show there where this airborne server data has been utilized successfully. Next. You see in these two areas, one is this in Kumari area, we see that it is completely soil covered area. So the lithologies have been demarcated, these grain polygons you see are the magnetic bodies. They are that pseudogeology interpreted based on this magnetic data. And these interpreted structures you are seeing completely these major shear zones, boundary of shear zones, and other faults have been demarcated based on that. Other you are seeing here in Tricocha fault. This magnetic data has helped in planning the boreholes in this Baglasai, Machua, all these areas by seeing the disposition of this Tricocha fault and the new areas further westward, the area is still open for the further exploration. So from known to unknown also, we can go by utilizing this data as well as where we are working, there it aids for the exploration. Next. You see here is a Tricocha fault, again same. Here this total magnetic intensity image of this showing this drilled boreholes where. So you see that if we go westwards, that continuity is still there. You can still drill in the west of this Baglasai block there. This is magnetic susceptibility at 300-meter depth we are seeing here. So Tricocha fault, how it looks at the different depth. A little variation will be there, but the general trend remains same. This is the integrated map you are seeing there. Geological map has been prepared based on this magnetic as well as the as well as this ground information, ground checked information, which gives the complete picture and areas for the further exploration. Next. Yes, this is the another area that the Bandurang, Kumari and the Moldi area. You see that how nicely this broader boundary of the major Singhbhum shear zone as well as these landslide zones in between around Kumari as well as this Bandurang area have been demarcated by this magnetic data. And in this Kumari area, which is mostly soil covered, and you are seeing the same extension of the similar rock types in the Kumari area. So that area was identified further because earlier we were drilling in the southern side, but in the northern side also similar features are there. So that area has been identified Kumari, and it has helped in planning the boreholes in the Kumari area. Next. This is again that map. You are seeing this. These rocks have been identified magnetic bodies by the magnetic data. The green polygons, this geology has been interpreted, and the structures in between as well as the broader zones, this Singum Shear Zone has been inferred from this magnetic data, and lithology in ground is also extrapolated, and which helps in the further exploration. Next. This is without the data, complete interpreted block I wanted to show, and how this Singhbhum shear zone varies from the within this Moldi to the Bandurang area. Next. And one more, next please. Next, just one more area I wanted to show here. In this western part of the Singhbhum shear zone, where this Singhbhum shear zone bifurcates, here we have drilled some boreholes along this magnetic high zone. However, this magnetic high zone, as we, with the experience in the other areas, magnetic high zones, we have some anomalies were there on surface, on the basis we have drilled. But in the other areas, we see when we go towards the slope of this magnetic high zone with the lower to moderate magnetic high zone, and where radiometric anomalies are also there by the airborne survey, to further north, from further north, this area can be a future target for the subsurface exploration and or possible another deposit in the western part of the Singhbhum basin. Next. Thank you.
Any query?
Question I will answer. Only. Yeah. Yeah. Yes, yes. It is the strata bound only, but they all four comes in the one type now, metamorphite types. But it is within that particular strata there. Yeah. But by magnetic data, you cannot see the upthrown and downthrown blocks. Only by if the exposures are there, with the help of the higher resolution satellite data and integrating with the magnetic data, then can be interpreted up to a extent. Not only on the basis of, I think, that if we have the higher resolution remote sensing data at 1:10, photographs also. Yeah. Data, but how much upthrown and downthrown, you can have an idea, and that again you have to confirm in ground. You cannot say it is the completely upthrown, because in neotectonics study, that high resolution remote sensing data have been used by seeing the how much strike slip movement as well as upthrown downthrown blocks. Only on the basis of the magnetic data, I don't think that how much it has been upthrown and downthrown, it can be calculated. There are the certain limitations in the this magnetic and all other data, remote sensing data. They are indirectly only help. Thank you.
Thank you, sir, for shedding light on the power of geophysical methods in mineral targeting. I request Satpathy sir to honor Sri P.K. Sharma sir with a memento.
Next one.
Our final keynote speaker for this session is Sri K.L. Mundra sir, who is Additional Director R&D AMD. He is a senior geoscientist with 36 years of dedicated service in AMD. His expertise lies in the exploration of critical minerals, especially lithium, rare metals, and rare earth elements. Among his landmark achievements are the discovery and development of India's first and largest hard rock RE deposit at Ambadongar, Rajasthan. The exploration of this deposit has led to securing India's future RE demands. Further, he has played a very key role in identifying India's first pegmatite-hosted lithium deposit in Marlagalla, Karnataka, a major milestone in India's quest for indigenous critical mineral resources, and significant contribution in the RE exploration of Sivana Ring Complex, Rajasthan, and Pakkanadu Alkaline Complex, Tamil Nadu. His work is well published in top geological journals and has greatly advanced India's geoscientific knowledge. For his contributions, Sri Mundra sir has received DAE Group Achievement Awards in 2015 and 2020. He currently serves as Additional Director, Research and Development at AMD. Sir, I request you to please deliver your keynote address. The stage is yours, sir.
Good afternoon. I'll be talking on occurrence of rare earth element mineralization along Singhbhum Shear Zone. As you have already heard our director Sri Dheeraj Pandey, that we have almost 17 deposits In last 75 years, we have located nearly 50 anomalies in Singum Shear Zone, out of which 17 have been converted into deposits by almost 1 million meter of drilling, nearly 10 meter per ton of uranium explored. So I want to tell that this copper uranium province not only contains copper and uranium and other base metals, but almost all the deposits are also associated with some or other quantity of rare earth elements. I got the opportunity of working almost in entire Singhbhum shear zone, right from Singhpura in the south to Bangudi in the northwest, and proved that genotype mineralization along with other RE is associated intricately with all the uranium deposits. Here, the main association of RE mineralization is along apatite magnetite veins and mostly in the metaphyletic rocks. You can see that the major RE minerals, they are hosted by apatite magnetite veins, are mainly genotype, sometimes monazite and allanite. However, the commercial exploitable placer deposits are identified so far at Kanyaluka only, where we can extract them on an economical scale. And in addition, these metaphyletic rocks of some schistose rocks and some serpentinized rocks, they can be a secondary source of RE along with uranium deposits. We can see that this is the Google map of Singhbhum shear zone, where I have shown from Khejurdari to Tamadungri, where I have located these anomalies. In my very initial years, I joined at Kanyaluka during 1988, the very first year of my joining in MD, and I worked for about 4 years. The area was left unexplored in between, and recently, last 3 years, we have again started this investigation for rare earth deposits. You can see that here the genotype or RE minerals are occurring as a IOA type of deposits, that is iron oxide apatite deposits, which are mainly found in Kiruna, Sweden, Baf, Iran, and El Laco, Chile. Of course, those deposits are mainly of volcanic origin. We have not yet established that source here, but because of their iron oxide association, we have considering these deposits of iron oxide apatite type of deposit. These apatite magnetite mineralization, they occur all along as irregular veins, and they occur all along the Singhbhum shear zone. And these apatite magnetite, they were worked during World War II for phosphate by phosphate company, and majority of these deposits occur at Kanyaluka, Khadandungri, Khejurdari, Chirudi, Ramchandrapur, majority in the southeastern sector. And the sizable deposits or concentration occur in the easternmost sector. We can see that this is the apatite magnetite RE mineralization at Kanyaluka. We recently reopened this area. Here the host rock is sericite biotite quartzite, along with we get the apatite magnetite veins, and genotype occurs closely in association with this apatite magnetite veins. RE minerals here are mainly genotype, monazite, and allanite, where genotype is the dominant one. If we talk of geology, these veins occur at the boundary of sericite biotite quartzite and of the Chaibasa formation with metabasalt of Danjori group. And at Kanyaluka, it is exposed for about 150 meter and soil covered. So a part of this is soil covered. So nearly about 500 meter of strike extension we can expect at Kanyaluka. And the weathering of this apatite magnetite genotype veins has given rise to placer deposits of genotype, which I will show the photographs in the next few slides. You can see the grain size of this genotype, which we have recovered from the gravel. So genotype occur in very coarse euhedral tabular grains with apatite magnetite veins, and allanite and monazite are also associated. However, the weathering of these veins have resulted in liberation of genotype from the parent rock and enrichment to economic grades within the gravel zone of the area. Some work was done. It was, of course, known since the days of Dunn, but later on in 1980s, AMD started working here. And since 1980, 2005 onwards, we started working extensively for this genotype because yttrium was required for our superconductivity experiments that time. And since then, we are working in this area and some other areas of Chota Nagpur granite gneissic terrain. Here the major alteration is the martitization and goethitization, which we have observed there. This is how the photomicrographs, we can see the genotype. Genotype occurs in two types. One is the type 1 is a very coarse grain. The grain size goes up to 10 mm, sometimes even 2 centimeter. The type 2 are comparatively smaller and they are embedded within alanite or monazite grains. The liberation of type 1 genotype has given rise to concentration in the alluvial gravels. This is how we can see that genotype, alanite and monazite. We can see that the chondrite curve, genotype is mainly HRE mineral. However, alanite and monazite is LRE. If we see the percentage, genotype contains nearly 34% yttrium and near about 20% of HRE, that is gadolinium about 4%, dysprosium 5.5%, erbium 3.4%. So all these high value HRE minerals are available in genotype, which occurs all along Singhbhum shear zone associated with apatite magnetite veins. However, alanite and monazite, they are mainly light rare earths. This is how the BSc images, we can see the association of genotype with thorite, genotype with alanite, genotype with apatite, and all sorts of association in the thin section. This is just a historical map which I have prepared during my 1988 days. I just wanted to show that right from Singhpura to Rakha and Rakha to almost Ukri, Nilmohanpur. So these are some of the areas I got to know about all the surface anomalies of uranium, and all those anomalies were evaluated for genotype concentration. And in the next few slides, I will tell that how genotype is intimately associated with almost all the areas. Coming from south of Kanyaluka is a Purandungri. Purandungri, we have got a lot of apatite magnetite, and the concentration, the work was mainly penning of the gravel derived from these veins. So we have got about 0.039 to 4.58% of yttrium in the penned concentrate, and the genotype pure grains, they have analyzed up to 40%, 41% by 203, and almost 15 to 20% HRE. Next, in the next important area is Khadandungri. Khadandungri was vastly mined for apatite and magnetite. That's why the name Khadan. And here apatite magnetite veins, they are very thick, almost 1 meter thickness veins are available in the biotite quartz schist of Chaivasa formation. Of course, here monazite and genotype are the major RE minerals, with monazite is in major abundance than genotype. You can see the concentration of RE in the apatite as well as monazite of Khadandungri. Even in apatite also, we get nearly 4,500 ppm of RE. It may be substitution of RE for calcium, or there may be some micro inclusions of genotype or monazite within the RE. If we see the monazite, it contains nearly 45% of total RE. Next, further, Khejurdari, there also genotype occurs in the form of apatite magnetite veins. Of course, genotype is minimum there. If we go further north of Kanyaluka, Pathargora, Baliagora, Mainajeria sector, they all have a lot of apatite workings, and presence of genotype, we can see that penned concentrate, they indicated up to 4.5% genotype in association with monazite. And the penned concentrate analyzes up to 0.5% by 203. So these all indicate the presence of genotype in association with uranium. Coming to further Surda Rakha and Jadugoda Bhatin Narva Pahar, here also we can see that minor occurrences of genotype within gravel zone of Bhatin, Jadugoda, Nimdi, Narva Pahar, which are all established uranium mines, and association of yttrium and other REs are available with this. Coming further west to Ker Ramchandra Pahar, Bayanbil, and Kera during Makuldi, Datkedi, in these areas along with schist. We get genotime in quartzite also at Dhatgeti. Apatite magnetite occurrences are very sparse, but along with quartzite, we get this genotime, and genotime is less at Kerala. Still, it is available at Kerala, Dungri, Dhatgeti, and Mahuldi. So my only thing is to tell here, my young geoscientist here, that along with uranium and other critical elements, we can always look for RE. We should always analyze these elements, and as a byproduct, we can look for these areas. So with this, we have done some the recent work done by my young colleague Sujit. In fact, I see a young KLM in Sujit, not Sujit Das, but it is Sujit MS. So he has, in fact, I told him that I am handing over the baton to you. So he has done some work and did some genetic modeling, and here he can clearly see that magnetite, apatite, magnetite of apatite magnetite veins is from the clear-cut hydrothermal process. And this is one genetic model. One genetic model has been prepared. Like there was a oxidized iron RE-rich parent magma, which was subjected to silicate oxide immiscibility, which formed two liquids, one crystallized to form apatite magnetite and the other having diuretic composition, where silica poor and iron rich liquid formed is depolymerized, and that attracted phosphorus as well as HFSC elements like Re to concentrate. And this iron phosphorus Re rich liquid migrated upward and intruded into the foliation plane of various schistose rocks like sericite, biotite, quartzite, or quartzite, and major occurrence is found near Kanyaluka, and weathering of these veins have resulted in the formation of placer deposits of genotime. These are some of the other association. I said that in metabolitic rocks also we are getting, so we can see that genotime, monazite, allanite, basanesite, somewhere perisite, chinchesite, they have also been very recently identified in many of the rocks, as well as we also got these minerals in the serpentinized peridotite and quartzite, and total Re concentration is of course limited, 1000 to 1500 ppm, but this can be act as a potential source if it can be recovered as the co-product of uranium mining. We can see the association of these Re minerals, specific cyst of Kudada area. Then we see the monazite and genotime in Mahuldi quartzite. We can see the inclusion of genotime within applies in apatite in Mahuldi quartzite. So Rajda area, Kanyaluka area, everywhere these occurrence of Re minerals are available. In addition, there is one more area where we can see for genotime is the placers derived from this Chakradharpur granites. So Sanjay Nala is one locality towards western Singhbhum near Sini. So there placer deposits are formed along point bars and floodplains. Of course, the occurrences are minor as compared to Siri River and Dev River, but still these sediment samples, they contain good concentration of monazite and genotime. However, monazite is slightly higher as compared to genotime, and these rivers, they flow through soda granite, metabasics, and garnetiferous sericite cyst and quartzites. So this source is mostly garnetiferous mica cyst near Gopidi, and they have given nearly 0.4% yttrium and about 5.23% of cerium. So they can be a smaller source. So in three environments, apatite magnetite associated with all the uranium deposits, the serpentinized and metapelatic rocks, and the placer deposits. So all along STB, we get these genotime Re concentration. So I just want to conclude that SSZ, in addition to uranium and copper, also contain appreciable Re, and out of which Kanyaluka is the first order target, from where pure genotime could be collected by simple gravity technique. In fact, we have collected some 25 kg and supplied to BRC for superconductivity experiments in 1988 to 1990. In addition, the southern part, Khadandungri, Purandungri, Balyagora, and Mainaj area, from where we got good concentration in the gravel. So they can be the next target areas after Kanyaluka.
In addition, the tailings of Bagjata, Jadugoda, Bhatin, Mahuldi, all these areas, they should be looked for RE, because the classical papers on STP by N.K. Rao and others, they have said that the least liquor of Jadugoda that time, that contains nearly 2000 ppm of yttrium. So if the least liquor we analyze for RE, and by some means if we can collect, recover the RE, since the tonnage is quite high, we can to some extent get these yttrium as well as the higher RE, and small quantity that can be also taken from Sanjay Nala. Thank you. These are the time grains collected from the Kanyaluka area. So they have been packed in the. Thank you.
Any query? You have opened up a different subject. See, there the purification or separation is a hydrochloric acid based, and then the milling operation is that sulfuric acid based, and purification is the nitric acid based. So the moment you are matching these two, the milling as well as runner separation, then who will win? I do not know, hydrochloric acid or sulfuric acid.
It's a
So
challenge.
it is a
for
very
next generation.
complex problem. Anyway, if it's not
The
there, then
utility
thank you
of
very
these
much.
elements, it's a challenge open for metallurgists as well as next generation architects.
Thank you, sir, for enlightening the audience regarding the significance of RE in our Singhbhum domain. I request the session chair, Dr. Satpathy sir, to honor Shri K.L. Mundra sir with a memento. I request convener of this theme meeting, Shri S.K. Das sir, to honor our rapporteur, Shri M.K. Birwa sir, with a memento. Sir, please. I request Das sir to honor Dr. Satpathy sir with a memento. This brings us to the end of session 1. On behalf of the organizing committee, I extend heartfelt thanks to all our esteemed speakers for sharing their knowledge, and Dr. Santosh Kumar Satpathy sir for chairing this impactful session. We will move on to session 2. Please stay connected with us. Good afternoon, everyone. I hope you all are having a great time in this event today. My name is Priyam, and I'm honored to be your host for this session. Before we dive into this session, I would like to invite Shri Dheeraj Pandey, Director AMD, to chair this session, please. Next, I would like to introduce our rapporteur for the session, who will be capturing the key highlights and takeaways from today's presentations. Our rapporteur for this session is Shri N.R. Ikka, in charge Singum Shear Zone East Investigations, AMD, Jamshedpur. This session contains some valuable presentations from our invited guests from different organizations. So I welcome you all again in this session. We are now ready to start this session, and I'm sure you all are looking forward to the engaging discussion and insightful presentations that await us. So it is time to introduce our first speaker of this session, Shri Manoj Kumar sir, Director Technical, Uranium Corporation of India Limited.
Shri Manoj Kumar sir holds a BTech in mining engineering from IIT ISM Dhanbad in 1992. He began his professional journey with UCIL in 1992 as a graduate trainee engineer mining. Over the course of his distinguished career in UCIL, he has served in various key roles, including assistant manager, general manager mines across various key roles, including accomplishments he had, including various units. Among his many accomplishments, he played a pivotal role in the successful commissioning of third stage vertical shaft at Jadugoda mines and led the efforts to reopen the Jadugoda mines after its closure. Both of these are a very significant milestone in UCIL's operational history. Since August 2024, he has been serving as Director at Technical at UCIL, continuing to contribute his expertise and leadership to the organization. Shri Manoj Kumar sir will be presenting on the topic challenges in mining of uranium in uranium. Sir, now we all please welcome him with a warm round of applause. Welcome.
All the speakers, there are 5 speakers in this session. 15, you have 12 minutes each. Fine. May I say thank you, sir? Okay, I will start straight away. I have divided my presentation into 5 parts. I will be describing these challenges to some extent. The first one is public perception. Second, regulation and clearances. Third, ore body characteristics. Fourth, mining technology and mining of new deposits vis-a-vis lease area extension, tailings and waste management. Public perception, I don't think I need to cover much because this is known to everybody. Main theme is that everybody wants job. Because of the scarcity of job, these problems are there. We have seen that people are objecting our activities, but only for the job. Once you provide job, the problems are over. So I can't say that these are the actual problems. Problems is jobs only. So I'm skipping this. Another, this part is important, and this is holding us from obtaining new projects. I will just read it out. The activities required for commissioning a mining project is very lengthy and involves a lot of activities. In case of uranium mining, the process starts with discovery of ore body by Atomic Minerals Directorate. After this, the various steps involved are these one: demarcation of land by district state government, in principle approval from DAE, approval and grant of lease, environment clearance, forest clearance, land acquisition in line with R&R policy and RTFLR Act 2013, clearance from Pollution Control Board, ERB clearance, DGMS, and other clearances. I will explain this in the next slide. You can see the first activity whereby we get the ownership of the land or mining. That is the first step where UCL comes into picture. So we see AMD is discovering the ore body. They are informing to the DMG. After that, DMG is referring the ore body to the state government or district administration for preparing the land schedule and cadastral map. So what is happening? This preparation of land schedule and cadastral map, it is taking a lot of time. In case of Banadugri mines, we started this about 3 years back. Till now, the demarcation of land is not done. So that is a big hurdle. But before that, I will also say something about the demarcation of mining lease by UCIL. Actually, this activity is not to be done by UCIL, but this is important because UCIL and AMD have to work together, and it is known that only UCIL can do the mining activities. So if we modify the lease area to a workable size, then it will be helpful. I will explain it in further slides. So these are the main activities. In all, there are more than 70 activities. Grant of mining lease, MUF, environment clearance, forest clearance, ARV, State Pollution Control Board, land acquisition, others. So all these activities are taking at least 7 to 8 years, or maybe more also, after which only any activity on the site can be started. So this is the main thing which is not allowing us to do fast. This is, I will skip it. Just now we are discussing this part. This is the Jadura ore body. The red line is our lease boundary. This green part and the some part of the ore body is handed over to UCIL is outside the lease area. And at present we have been handed over only 15.69 million ton till now. But as sir has told, about 50 million ton reserve is there. I can calculate from the figures provided. So about 50 million ton is there. So this will be a very big deposit, and we have to do justice to this deposit also. So if the ore body is of the size of 50 million tons, then definitely we can have a mine with a capacity of more than 5,000 tons or 4,000 tons. But for that, what is required is that we amalgamate this ore body to the new discovery. Unless these two ore bodies are joined together and worked as a single mine, this will not be possible, because the new deposit what we are going to get is below 700 meter depth. The present lease is up to 700 meters depth, and beyond that we are getting about 50 million ton. So unless this infrastructure is used for the new ore body, it will not be possible to have a single mine for that, because in nowhere in the world any mine is worked with a depth of 700 meter and beyond. So this part is very important, and we need to have some changes in the law whereby we can be allowed to extend the project workings to the deeper horizons also. This is happening not only in this case, Jadura case, but also in the other mines. This is another picture of Jadura mine. This is longitudinal section, so I will not go by it. This is the case of Tumlapalli mines. This pointer is actually not working. Yeah, this portion, this yellow portion is the portion where we are working, and about 9 million tons is there till there from now. So it will be completed in maybe 10 years, and then the ore body handed over to us is this one, which we are planning to work as Tumlapalli deep mines. But same problem is here, what we have discussed for the case of Jadwa mines. And another problem is that this portion was not handed over along with this portion. Had it been handed over to this, then it would have been easier to mine it. So another issue is that recently this part, Tumlapalli 2, has been handed over to, not handed over, is reported to the state government. So if they will do it fast, then if this portion is lease is granted for this area, then it will be difficult to mine, because the strike length is very less. So it is better that both with UCIL and MD plan the lease area so that it is a workable lease area, and a good mine can be developed. So it will be better that the ore body handed over to us is like this, and up to maybe 4 to 5 kilometers, this length, this width. So I wanted to say that it is better, before going to the state government, we UCIL and AMD both sit together, have a discussion, and demarcate the ore body or hand over the ore body in such a fashion that it is good for UCIL and good for the country. This is a similar case for Narvapad also. I think everybody knows it. The ore body handed over. This is the Narvapad ore body, and this is the Banadugri ore body. We can see that it is very difficult to mine such a ore body which strike length is only 400 meters here. So again, it is better if the ore body or if this leach area is extended to this location. Then only it will be feasible as a single mine. Again, these points are nothing new. It is just I want to say that the ore body is narrow. Okay. Just I wanted to highlight this point. As per the extant law, there is no provision for extension of existing mining lease even in cases where the ore body is later found to expand beyond the leased area. In such case, a separate mining lease and other classes are required for deposit beyond the mining lease as a separate one, which may not be technically and economically feasible. So this is what we wanted to have. For deeper or additional ore bodies in these cases, there may not be a technical and financial feasibility to develop a such separate mine. Help and follow from DA is required. A separate provision may be introduced for strategic mineral as only UCIL is nominated for uranium mining. Grades, we know, our grades are very low. Here, the world, about 55% of the mining is done by in-situ leaching. And underground mining is only 20%. So, because of the low grade, difficult mining technologies, our costs are about 4 times higher than the international cost. So again, but nothing can be done, we have to do it. These are the resources available in India. 55% is in Andhra Pradesh, 24% in Jharkhand, 13% in other places, and 8% in Meghalaya. I think both these Andhra Pradesh and Jharkhand both will be expanding. At present, all the mines in existing resources have life of about 15 to 20 years, except Jadugoda and Bhagyata. So new development has to be done in all the mines. These are the proposed projects which we are going to have. Banadugri, Narva Deep, Karadi, Kannampalli, we are planning to have a mines with very big with a larger capacity, maybe to the tune of 10,000 tons per day. Other feasible projects are Rohil, which we have already started. But the challenges in the Rohil mines is that there are multiple ore bodies, about 8 to 9, and all are narrow, and parting is also less. So mining may be a bit difficult. So I will skip this. This is Gogi deposit. Problem is that there are so many ore bodies, and each one is very small. So providing ventilation, providing passage will be difficult. So again, this is one of the very difficult ore bodies. Another problem with the Gogi deposit is that it is lying below this national highway, below the lake, and in the highly populated area, this place. So acquiring leach will be almost, impossible type.
There are more than, sorry. There are more than 500 houses in this location, shops. So it will be very difficult to shift. But again, addition to the Gogi project, there are some deposit, Halkal and Kanchankai. They are feasible and they can be worked out. Another problem with Gogi deposit is that some part of the ore is acidic and some part is alkali. So recovery will also be a challenge. Other deposits, KPM, we know is already closed down. Chitral and Lambapur, Pedagodu in Telangana, the state government is not allowing us to do any activity. Jajawal is a very small deposit and in the elephant corridor and under reserve forest, so financially may not be viable. Other problem is regarding tailings pond. In every area we are struggling. All the tailings ponds have life of about 4 years only. And in Tumlapalli it is still less. So we are not finding we have to find out the new places for disposal. Like in Jadugala, a new place is required because if a big mine is going to come, a new tailing pond area is required to be acquired. Tumlapalli tailings pond, this is the status. It is almost filled up. Other challenges besides are procurement of new equipments, because all the mining equipments for underground use, they are mostly imported. And it is very difficult to procure any important equipment from the foreign countries. So we are facing problem here. Deep mining technology like shaft sinking expertise is now over. Earlier the mining activities are done through shaft, but now shaft sinking experts are not there, and we are having problem in this. Import of the material, this is also issue. Poor quality of equipments and the local issues as it is. Thank you, sir. Questions, if any, we can discuss over lunchtime. Save time.
Thank you, sir, for the insightful presentation and for briefing the technical, logistical, and socio-political issues that are involved in uranium mining in India. I would now like to request our respective session chair, Shri Dheeraj Pandey, sir, to kindly come forward to present memento to our esteemed speaker as a token of appreciation. Moving forward in our session, it is now time to hear from another esteemed expert whose work has contributed significantly to the field. I am delighted to introduce Shri J.P. Mahakul, sir, Research Director, GSI State Unit, Bhubaneswar. He holds a master's degree in geology and a PhD from Utkal University. With over 3 decades of experience as a professional geologist in GSI, Dr. Mahakul has extensively mapped the granite greenstone belt of the Dharwar and Singhbhum Craton, with a focus on their geological evolution and the economic potential of gold and iron ore mineralization. His work in collaboration with his team has led to the significant stratigraphic revisions in key geological domains, including the Dhanjori Basin, Bunai-Kindujar Belt, and Chitradurga Schist Belt, contributing valuable insights to the understanding of Precambrian geology in India. Shri Mahakul will be speaking on the topic Extension and Splays of Singum Shear Zone, New Target Areas for Hydrothermal System. Please join me in welcoming Shri Mahakul to the dais.
Chairman, sir, distinguished geoscientists and technologists in the audience. Yeah, this is the topic, and all of you know why Singhbhum Shear Zone is there. Singhbhum Shear Zone basically defines the zone of accretion between a old craton and a relatively younger Proterozoic mobile belt. Next one. Oh, okay. Yeah. So if you just Google now, you come across several regional geological map of Singhbhum craton. Most of it, if you see, they try to hide something. Like in many of the cases, the Singhbhum Shear Zone is hidden by some index. Could you see? So this is the beginning of our research. We thought we'll have a more precise map in which we'll be able to show the extension, because a lithospheric shear zone cannot just die out. It has to continue. It has to define the contact between, I mean, it has to encircle the craton all around. Or maybe there is another, like we have Sukinda thrust in the southern part of the craton. So this is the beginning of our research. What we have a big team. We started out during the COVID time. We had a lot of time to kill, so we started out with discontinuity mapping and trendline mapping, and which was followed by many of our collaborators in different sectors. So this is how it came out. We have a trendline map and a discontinuity map, which needs to be validated on ground. So what we did is we started with some of the easternmost part, like the southeastern continuation of the Singhbhum Shear Zone. So here again, yeah, this is our publication. So southeastern continuation of, you see, the most of the maps, they do not show where the Singhbhum Shear Zone goes beyond Baharagura. So south of Baharagura, we mapped it out, and for many of the things that we could recognize, yeah, this is the Dhanjari Basin. So just south of Dhanjari Basin, this is again a Proterozoic granite. We have another Proterozoic granite. These are all fallacic complexes. We have three distinct fallacic complexes, like you have Bhuasuni, you have Roma Pahari, you have Bangri-Pusi granite. So these granitoids are basically intrusive into both Dhanjari as well as the North Singhbhum mobile belt. These are the NSMB packages. So there are several field photographs, and what we find in this part, because the interface is near north-south with the NSMB, we have a westerly divergence and a thrust, I mean, top to west movement along the Singhbhum Shear Zone. So, yeah, these are some of the structural. You have the steep, steep down dip stretching lineation. And in addition to that, you have the kinking in kyanite, you have hornblende phase. These are all structural fabric through which we deciphered that there is a top to west movement in this particular sector of Singhbhum Shear Zone. And in you also have some brittle failure. There is a major fault called Kendua fault. So these are the features of Kendua fault. Yeah. These are the malintage quartzite, in which, again, in some places surrounding, this surrounds the Roma Pahari granite, where uranium mineralization has also been recorded. Okay. The next step was to see the Dhanjari Basin. So Dhanjari Basin is, yeah, it is just the northern continuation. And if you see almost all the copper mineralization, the rich copper mineralization, have close spatial proximity with the Dhanjari Basin. If you go away from the Dhanjari Basin, see, the Singhbhum Shear Zone just define the eastern contact of the Dhanjari Basin. If you go away from Dhanjari Basin, the intensity of copper mineralization decreases, which means the copper mineralization has something to do with the volcano-sedimentary pile of Dhanjari Basin. This was the presumption in which we started. However, the uranium mineralization continued much towards west. So this is something which was recorded much earlier by Mr. P.K. Banerjee in 1982. There are two major discontinuity inside the Dhanjari Basin. So we built upon that. In fact, we started with trend-held mapping, and subsequently, when we went through the literature, we found that P.K. Banerjee has already recorded. So which was again validated in the field. There are three kind of linears here. The black ones are IOG linears. These color are all Hanjori linears, and these are all what we say NSME linear. So this was further validated, and to our surprise, this is a discontinuity which was recorded by Dunn. In his memoir also you can find this has been recorded as a fault. So Dhanjuri basin is transected by two major shear zones which has been Bangri-Poshi West and Bangri-Poshi Shear Zone. So this has resulted, these are considered to be major splays of Singhbhum Shear Zone. So the stratigraphy of Dhanjuri basin is very simple. You have a arenite followed by volcanism. Right now, this arenite is, so Dhanjuri basin is primarily a craton margin basin with certain marine influences also, which we have recorded recently. So the basement cover relationship of Dhanjuri with the craton is only in this part, whereas this is a tectonic and these are also tectonic. So there is no Fulgari basin according to us. Now, if you relate this to your to uranium mineralization, I will come to that. So I will just show some of the lithological assemblages. These are the conglomerate horizon, the top stratification in the quartzite. These are the basaltic lava. You have this development of paleolithic foliation are restricted to those major splays of Singum Shear Zone. You go away from that, it is not. You don't have development foliation. So, and these are the C prime fabric in basalt, and then you have the folding of this foliation, which has a consistent convergence towards west. Yeah, you could see the near recumbency of those folds as well, which effectively means you have thrust planes. And of course, the basalt, amygdala basalt, and the mineralitic fabric on the basalt along the shear zones. So, and of course, there is a post-shearing kinking, which has led to a nearly steep westerly dipping planes development. So I won't get into detail of it. You can just have a look on the main fabric of shear foliation bedding as well as the C plane, C dash plane, yes. And then the post-shearing fabric, which is dipping towards west. Now, Dhanjuri basin has been intruded by a major intrusive mafic ultramafic event, right? So the evidence of which we also got it in some of our drilling that we made. And this is intrusive not only to the Dhanjuri, this is intrusive also to the North Singhbhum mobile belt. So, I think the chairman, sir, if you remember, you were discussing about one of the prospect in which uranium mineralization is in serpentinite. So these are the things which are during the accretion, in the initial phase of accretion, you have a major mafic ultramafic event which has been at many places in close proximity of the shear zone, has been completely mineralized. And of course, it is, you have serpentinization, hydrolysis. So that is the material which is having, at places it is having nickel mineralization also, at places it is having uranium mineralization also. So the source for nickel could be this, but the source of for nickel could be something else, which is basically cited in this kind of rock. No, that was again followed by a major felicic event, which would be a coherent event, as we have seen the Bangri-Poshi granite, the Romapahari granite, the Bhuasuni granite, and the Arkasani event, which is again a mesoproterozoic event. And these are the granitoids or felicic unit, which I think many have contributed, many have identified them to be having some genetic link with, particularly the Arkasani event has a genetic link with uranium according to many. In a similar way, the Bangri-Poshi granite has a genetic link with the beryllium mineralization that we have in just south of Dhanjuri basin. And of course, the Romapari granite may not have any genetic link with the copper mineralization that we see in the Romapari area in the Madanasai sector, but could have some genetic link with the uranium mineralization that is recorded. So uranium mineralization in Romapari granite is recorded both in Romapari granite as well as the NSMB rock to which it intrudes. So this is how we made a conceptual model. You have the oceanic crust of NSMB, then it gets subjected beneath the Thanjori basin as well as basically the craton. So you have during the process of accretion, you have the first a major mafic ultramafic event and followed by a felicic event. So if you now see, this is your map which has been borrowed from your brochure. So if you have a close look at the mineralization, these particularly ostocoily uranium mineralization, your all anomalies, no, they have close spatial proximity with this discontinuity. So there has to be a relook into their nature of mineralization. It could also be hydrothermal, unless we work on that. And we expect only this part we can have this is basically unconformity. So we can here also these are basalt sandstone only, basalt quartzite only, but they must have been, the mineralization could have been significantly modified with a hydrothermal imprint. Now, this cannot die down here. This has to go further west. So that was again, so this is basically what I discussed. So we thought we'll have a look how the Singhbhum Shear Zone goes beyond the Chakradharpur gneisses, which is basically a wedge of granite, wedge of Archean granite. It basically splays around the Chakradharpur granite gneiss. So see this is the Gangpur belt. The northern contact of Gangpur is again tectonic. So we believe that the Singhbhum Shear Zone splays and then occupy the northern margin of the Gangpur belt, and then the southern splays occupy what we call it as Biramitrapur thrust. Now, these are some of the, along the Biramitrapur thrust, you have tectonic wedges of granitoids within the Gangpur sediment. Now, we also have intense brecciation in quartzite indicating brittle failure. Now, then comes to the contact between Gangpur and the craton. So that also we have worked out, which will be publishing soon. So this is, according to us, the contact between granite within the Gangpur mobile belt and the Singhbhum craton is what we call the Bamra Chattam shear zone. And these are the evidence of those shear zones along the Chattam granite. And this is what the interface of Gangpur mobile belt and craton. As you could see, you have a lot of neoproterozoic granite where AMD has done good lot of work with regards to rare metal mineralization. These are these red one. Of course, you also have done work on the Kunjar, which is basically a post-IOG siliciclastic. Now, these are some of the things. I mean, in addition to what we discussed, we can have a relook into the Thanjori uranium mineralization, which could be, many of it, particularly ostocoily, could be hydrothermal related. And there is a need to relook into the post-iron ore group siliciclastic, which are Mahagiri, Mankarchua, Hadgad, and Kunjar, and even the Thanjori sediments, which are much away from the major Thanjori basin, because you have huge patch of Thanjori overlaying the iron ore group near Jasipur. So they also could be, and of course, Panigrahi have published something on Kolhan. So if it is unconformity related, definitely the central part of the Singhbhum granite complex is the source area. So if you have unconformity related mineralization in Thanjori, you also should have it in Kolhan, by that logic. So of course, we need to have a lot of work done on the siliciclastic, particularly with regards to their paleocurrent direction, so that we know where the major paleopressure is. Most of the time, we have confined ourselves to the periphery, so that may not give us a proper deposit. Thank you, sir.
able to finish on time.
Thank you, sir, for the enriching presentation. The recognition of place of SSZ in the southeastern part is a really great discovery, and it is now certainly going to emerge as a new exploration target for us. Now, I would request to present a token of appreciation from Shri Dheeraj Pandey, sir, to Shri Mahakul, sir. Thank you, sir. As we continue our journey through today's session, we are privileged to welcome another expert whose research adds a unique perspective to our discussion. I now introduce Shri Amit Devdekar, sir. He is Chief Exploration Manager at HCL, where he has been serving since 2014. He brings over 2 decades of experience in mineral exploration and resource development, with expertise spanning both the iron ore and copper sectors. He has begun his professional journey in 2004 as a management trainee with Vedanta Group, working in iron ore exploration and mining operations. Mr. Devdekar holds MSc in Geology from Goa University. His extensive field experience and deep technical knowledge have contributed significantly to the advancement of mineral exploration initiatives in India. Shri Devdekar will be presenting on the topic HCL's Excellence in Mineral Exploration and Mining, a Jharkhand Perspective. So please welcome Shri Devdekar to the dais.
The dice, ladies and gentlemen. Good afternoon, everybody, and Johar. I will stick to the time I will finish. My topic is HCL Excellence in Mineral Exploration and Mining in Jharkhand Perspectives. When we say Hindustan Copper, we are the copper miner to the nation. We have more than 5 decades of experience in copper mining and refined copper productions. We are the only company vertically integrated operations, right from the mining, ore beneficiation, smeltings, refinery, and downstream production. We are the only operating copper ore mining company in India. All the mining operating leases are with Hindustan Copper. We have a total reserves on in 1/4/2024. We have 755.31 million tons. In a present production of SCL group is 3.97, and we are focused. We have a target of achieving 12 million tons by the year 2029-30. These are the just pictorial representations where we have the unit MCP in Malanchkal, Ghatsila called ICC, and K3 called KCC. These are the 3 mining operations we have, and the reserves and resources is as here we have mentioned. It around, as I told you, 755.31 million. Out of that, if you see the ICC, the state of Jharkhand, we have, if we add this to this thing, we are more than 380, means almost 50% of the reserves of the SCLs are in the state of Jharkhand. So we have a good potential in the Jharkhand. Our mining leases, 3 mining leases, continuous mining leases we have. Turda, Kendadi, and Raka. And after this Raka, you have the Jadugoda mines this side. So now the main slide of the presentation is exploration. SCL is focused on enhancing the inventories, and it can show in this particular two charts. If you see this from almost 5 crore, have spent now 36 crore in last 23-24. As a result of this, you can see these are the budgets, and these are total expenditures. As a result of this exploration, the reserves are added from it has enhanced from 570 million to 755 million. This is the totality of SCL. I will brief you the ICC perspectives in a later stage. It's the same as these are the various leases we have, operating mines we have. Surda, Kindadi, Raka. These three are part of the ICC unit. You can see how we have the good potentials in ICC to enhance the production. Presently, in ICC, due to some statutory clearances and projects are under pipelines and obtaining some statutory requirements, as Manoj sir has told, what are the list of statutory they require. We are also facing the similar type of issues. We will hopefully these are the very advanced stage, and within 1 year we will be starting Raka, Kindadi, all mines. Now just how we have recently, this particular yellow color shows our mines are developed, underground development is shown in this. Then these are the old exploration was there before the closure of the 2000. Then in 2015-14 onwards, we have taken up the depth exploration activity across our leases and blocks. Some of, as you know, they are divided into some blocks like this. So we have from 13 level, we have gone to the 21 level in the Surda. 21 levels means almost 800 meters depth, vertical depth we have explored and established the reserves. Even Kindadi, just 4th, we have the development up to 5th level, but we have proved reserves up to 10 level, then 12 levels. So these are the Raka, we can see there is a virgin block this side. These are the virgin blocks, but we have the proved reserve up to the 16 level. So the overall expenditures and meterage, how we have drilled. So earlier slide, if you have seen, there are total 36 crore we have spent. Out of the 36, the chunk of this we have done in ICC, that is 35 crores, and almost 10,000 meter we are drilling. These are all surface drilling we have incorporated here. As a result of drilling, you can see how the reserves has been added to our KTs. From 250 millions, it has gone to 230 million, almost a 39 million enhancement. And from that, in 2023-24, it has reached to 381. So almost 60 million. That is total 130 million we have added. And in a base metal, so much reserves are hardly you get. There are some of the slides. build rigs, reservations of core boxes. See the core scanning we are doing now. Photography, as you know, most of the time you do the photography of the logs. Now core scanning, digital core scanning is done. So it is very useful for the futures. Retrieval of data is very easier for you. And as SCL has a vision of 12 million tons ore production from 2030. This slide, actually, I don't want to show it to you, but we have to present status of the ICC productions. We have planned for this to increase to 4.3 million by enhancing our Surda mines from 0.4 million to 0.9 million and reopening of the Rakha mine in Dadi from one point, it will add to the 1.9 million. And this is a totally a new project, Chapri or Chapri mines. It will 1.5 million tons. So total we will be adding in a plan 4.3 million. Next slide is the same of this thing, but it's showing how we will progress the years. So in 1930, we will be able to from 0.3 million to 1.6 million we will be society. Presently is 0.5 capacity is there. We'll go to the 4.65. That's it. Thank you.
Thank you for finishing right on time. Stay back.
Thank you, sir, for the presentation. As we have seen that dedicated work of HCL has added significant results to the existing reserves of the country. And we hope that HCL's work will continue to inspire us all. Now, to express our gratitude towards the commendable work you have done, I would request Session Chair to present a memento to Sri Devigar. Thank you, sir. Continuing with today's exciting lineup, it is now time to hear from another distinguished experts in the field. I am pleased to introduce in front of you Shri Manoranjan Mahali sir, DGM UCIL. Shri Mahali sir holds a BTech in mining engineering from IIT ISM Dhanbad and has completed a project management program from XLRI Jamshedpur. He began his career as a technical service engineer in the explosive industries before joining UCIL as a management trainee in 2002. Over the years, he has held key responsibilities across all major mining functions, including stowing, ventilation, production safety, and mine planning. Notably, he served as a mine manager of UCIL's flagship Narva Pahad mine for an exceptional tenure of nearly 11 years, the longest in the mine's history. He is also a nominee for the prestigious National Safety Award for the Ministry of Labor, DGMS. Mr. Mahali specializes in blasting technology and mine planning and is known for his proactive approach in adopting innovative mining techniques. He currently serves as Deputy General Manager and Head of Department in the statutory role of agent for the Jadugoda Group of Mines, which includes Narva Pahad, Bhatin, Jadugoda and Bagjata mines. Shri Mahali sir will be presenting on the topic stories written on the radiating rocks of Singhbhum Shear Zone. Therefore, without taking much time, I would now call upon the stage Shri Mahali sir.
I have 12 minutes time, Mahali sir.
Obviously, sir.
Please try to finish within it.
Not looking much of a fuss of a time. Very good afternoon to the chair, the dignitaries on the front line, and the entire house. The stories written on the radiating rocks of Singum Shear Zone. Most of the time we did have a very technical session with our geographical maps and this and that. For a taste change, this is just a story, and obviously stories have to be lamented. तो मैं जस्ट स्टोरी सुनाऊंगा। सिंघभूम शेयर जोन का है, तो ऑब्वियसली सिंघभूम शेयर जोन है तो ऑब्वियसली यूरेनियम, कॉपर एंड लॉट मेनी थिंग्स आर देयर। तो स्टोरीज में एक कंपैरिजन टाइप हो जाएगा। स्टोरीज इज नथिंग बट it is how uranium industry is tech savvy during those days, during the mid days and ahead, how it will be going ahead. तो obviously जब tech savvy की बात होती है तो थोड़ा सा comparison रहेगा with my big brother the copper out there. So it is nothing much of a competitive feeling or something like that. So moving ahead, Singhbhum Shear Zone as proclaimed by the researchers that it contains the oldest and the rocks. We know everything all about that, how it has been explored and how it has been found. Lot many geologists, my predecessors said about that. To produce uranium ore in the mining, UCIL has taken several initiatives from adopting different stoping methods. During the earlier days, like shrinkage stoping, heap leaching, and all those things were there. And ultimately, we have brought down to the horizontal cut and fill mining method. And right from the pre-1995 days, it just started with the commissioning of Jadugoda and a Bhatin mine after taking the baton from the AMD, and gradually it groomed up during the 1995 to 2020 days. We called those as the golden period. Like in the history, you have a Gupta one golden period. We did had a golden Gupta period out that time by mushrooming of Turamdi mine, Narwa Pahad mine, Bagjata, Banduring, Moldi, and down south at Tumlapalli. And probably much ahead, as the jumbo is moving ahead, our drilling machine guiding us, we will be coming up with the future projects as our DT sir has shown it earlier. After taking patent from the AMD, at that time, mining was not new in the Jadugoda area. Before Jadugoda, Hindustan Copper was flourishing out there, right from the 1926 onwards. So obviously the people in and around the area, they knew mining. But when UCIL came, and as a younger brother with the two mining projects at Jadugoda and Bhatin only, still we adopted the best of the technology available at that time. It's a real example like the Kope winding system and the Alimek scrimber, which was not there in the neighborhood. Moving ahead, although it was a track mining and still it is a track mining, maybe for the next 5 to 7 years, and with Tirukocha with 10 years, we will be moving. With track mining, with a combination of jumbo and electrical loaders, you just can imagine. आप सोच सकते हैं कि ट्रैक माइनिंग जहाँ पर शाफ्ट से लोग आना जाना कर रहे हैं, हम लोगों का जॉब के दौरान कुछ ट्रांसफर्स वगैरह होता है, और अगर हम लोग किसी मल्टी स्टोरेज बिल्डिंग में रहते हैं तो हार्डली शिफ्टिंग करने में 1-2 दिन लगता है, तो कितना टीडियस जॉब रहता है। आप अपना जो सिस्टम है लिफ्ट का शिफ्ट करने में मटेरियल्स वगैरह को, अभी भी वाइंडिंग सिस्टम जो हमारा जादूगुड़ा में है, इसी के थ्रू से ही हम लोग सारा सामान including the jumbo having a length of nearly 11 meter, the loaders having so and so locos वगैरह सारा उसी से शिफ्टिंग होता है। 2x2 का रेज है, उसके थ्रू से हम लोग शिफ्ट करते हैं। तो बोलने का मतलब ये है, मेरा तात्पर्य कि इन स्पाइट ऑफ जो मैकेनाइजेशन पॉसिबल जो स्कोप नहीं लग रहा था, शायद ही किसी शाफ्ट माइंस में होगा, अभी भी लोग मैनुअली फॉलो कर रहे हैं, लेकिन टेक से भी का जो हम लोग का जो ये अप्रोच था, उसके तहत हम लोग अभी भी जादूगुड़ा में जंबो ड्रिलिंग और ये सब इक्विपमेंट हम लोग कर रहे हैं। कुछ जगह में शाफ्ट के थ्रू से नो डाउट मैकेनाइजेशन है, बट उन लोगों का शाफ्ट डाया काफी बड़ा हुआ करता है डाउन साउथ इन साउथ अफ्रीका और ये सब वगैरह में है भी शाफ्ट के थ्रू करके। अदरवाइज जंबो और ये सब आपको नॉर्मली डिक्लाइन माइंस में ही आपको प्रैक्टिस करने को मिलेगा, शाफ्ट माइनिंग में नहीं मिलेगा। मूविंग अहेड, उसके बाद जादूगुड़ा भाटिन के बाद लीप जंप जो हम लोग लिए, तो ये इट वाज अ सॉल्टरी लीप वी कैन से, नो कॉम्पिटिटर्स वर देयर। सॉल्टरी लीप वेडिंग थ्रू द एडमिन एंड टेक्निकल चैलेंजेस। इसलिए मैं कहूंगा जब नरवा पहाड़ पहला डिक्लाइन माइंस हम लोग का जब चालू हुआ, प्रोबेबली थियोरेटिकली वी वर हैविंग नो हाउ about jumbo, ST, MT and other utility vehicles. In spite of that, no trained persons were there. Although हम लोग कोशिश किए थे कि ज़्यादा highly qualified operators वगैरह, diploma people were trained for jumbo drilling and all those things. तो उस समय लेट आरसी पुरी साहब का चैलेंज था और उन्होंने स्टेप बाय स्टेप पूरा टीम के साथ उसको आगे बढ़ाते हुए लेकर के गया, और बाद में हम लोग कॉपी पेस्ट सारे के सारा तुरामडी माइंस, फिर बाद में डाउन साउथ तुमलापल्ली माइंस, और जो छोटे स्केल में हमारा भाग जाता मोल्डी, ये सब माइंस में हम लोग करते हुए और आगे बढ़ते हुए चले गए। तो ये सारे इक्विपमेंट्स एज ऑन डेट हमारे सारे माइंस में चल रहे हैं। यू कैन सी with heavy mechanization, increasing the production, productivity and safety and so on and so forth. उसके बाद चैलेंजेस आया, इक्विपमेंट तो डिप्लॉय कर दिए, तो कई बार होता है कि इक्विपमेंट डिप्लॉय हो जाने के बाद हम लोग शांति से बैठ जाते हैं, ये सोच करके इक्विपमेंट डिप्लॉय हो गया, मैकेनाइजेशन हो गया, आगे और क्या। तो उसके आगे और क्या होता है, तो जनरली कोई भी डेवलपमेंट वर्क में, माइनिंग एक्टिविटी में आपका डेवलपमेंट मेजर रोल प्ले करता है। द स्मॉलेस्ट द डेवलपमेंट, जितना कम वेस्ट डेवलपमेंट रहेगा, आपको कॉस्ट बेनिफिट उतना ज्यादा एंटायर माइन का इकोनॉमी में वो फिट करेगा। उसके तहत जो रहा स्टेप बाय स्टेप, खुद मैं इस चीज का विटनेस हूँ। इनिशियली डेज में खुद नरवा पहाड़ में स्मॉलर रैम्प्स हुआ करता था इन बिटवीन द ओर बॉडी एंड ड्रिफ्ट। ग्रेजुअली उसको शिफ्ट ओवर किए हम लोग, रैम्प को ओर बॉडी में लेके गए ताकि जस्टेशन पीरियड कम रहे। फिर बिगर रैम्प्स बनाया, विलेटस टर्निंग, फिर उससे और बिगर रैम्प बनाया फुटबॉल साइड में, कॉमन रैम्प बनाया 2 ब्लॉक के बीच में, कॉमन ड्रिफ्ट बनाया जो अभी हाल में हम लोग क्योंकि आपका यहाँ से डीपर सीरीज का जैसे एक्सप्लोरेशन होकर के मिला हम लोग को, तो इसमें और उसके बाद में ग्रेजुअली नरवा पहाड़ स्टार्टेड विद 7 डिग्री डिक्लाइन, Turamdi with 8 degree decline and our Tumlapalli is with 9 degree decline। इस तरह से आप टोटली देखिएगा तो नियरली किलोमीटर्स एंड किलोमीटर्स में हम लोगों ने सेविंग किया है। और एज ऑन डेट आप जस्ट कैलकुलेट करिएगा, पर मीटर डेवलपमेंट टारगेट जो कॉस्टिंग है हम लोग का 1,35,000 के आसपास आता है, जो हमारा साइज ऑफ एक्सकवेशन है नॉर्मल ड्रिफ्ट का। और अगर एक माइंस में हम 4 से 5 किलोमीटर भी बचा दे रहे हैं तो इट्स अ ह्यूज सेविंग, जो जनरली अननोटिस्ड, अनडिक्लेयर्ड, अनमार्केटिंग चला जाता है। इसके बाद में फिर मैं खुद नरवा पहाड़ में जब स्टोइंग इंचार्ज हुआ करता था, तो इनिशियली ये सब कुछ स्टेप्स है जो हम लोग ने लिए हैं। तो ग्रेविटी स्टोइंग के बारे में जस्ट बताऊंगा कि कुछ पंपिंग के द्वारा ग्रेविटी स्टोइंग किया जाता है। तो उस समय नियरली वो जो था 10 to 12 टन पर आवर वही रेशियो में जाता था, और उसका इलेक्ट्रिक बिल तकरीबन 40 लाख रुपया पर ईयर आता था। उसको हटा करके जब हम लोगों ने किया तो एज ऑन डेट हमने एनहांस किया, स्टोइंग रेट भी बढ़ा, 40 टन पर आवर हुआ फ्रॉम 10 to 12 टन पर आवर विद 0 इलेक्ट्रिसिटी बिल। ये कुछ स्टेप्स है जो हम लोग टाइम टू टाइम अपना करते रहते हैं इन हाउस। ये जगह मैं दिखा रहा हूँ जहाँ पर वेल वाज, कुछ 3-4 एजिटेटर थे, पंप्स थे, उसको हटा करके हमने ग्रेविटी स्टोइंग को फिर उसको इनिशिएट किया था। ये नरवा पहाड़ का पिक्चर है स्टोइंग प्लांट का। और ये कुछ पिक्चर्स जो हम लोग ने खुद थ्रू आवर ओन इन हाउस एक्सपीरियंस करके इसको ग्रेविटी स्टोइंग में कन्वर्ट किया। नो पंप्स, नथिंग इज देयर, स्टोइंग रेट हैज इंक्रीज्ड और विद 0 एनर्जी कंजम्पशन एंड ऑल दोस थिंग्स। कुछ हिकअप्स ये थे, बट फेज 1 फेज 2 के बाद अभी जितने सारे ओर बॉडीज और ये सब मिला है हम लोग को, तो ये हमारे लिए चैलेंजेस है। Probably we have to look beyond the present mechanization system, present mining method or whatsoever it is. So it's time to change the gear. Presently we are lagging behind in implementation of complete scaled up mechanization. We are not, I cannot say that we are not mechanized, we are mechanized, but complete mechanization की तरफ शायद हम लोग को जाना पड़ेगा with the handling over of depth which is further going to add on, जो अभी भी exploration वगैरह MD द्वारा चल रहा है। Now time has come out to scale up the production of uranium to exploit the indigenous source required for implementation of the vision of DAE for Viksit Bharat and self-reliance in mineral production। उसी तहत में जो हमारे नए प्रोजेक्ट्स वगैरह आए हैं उनका जस्ट ये है, रोहिल का है, गोगी का है, और ये सबको देखते हुए हम लोग आगे बढ़ते जाएंगे। और जिस तरह से एसिड लीचिंग हमारे लिए तो बहुत ही इजी था, लेकिन एल्कली लीचिंग हमारे लिए बहुत बड़ा चैलेंज हुआ करता था, जिसको हम लोग एस्टेब्लिश कर चुके हैं। तो प्रोसेसिंग पार्ट में हमारे लिए कोई चैलेंजेस नहीं रहेगा, ऐसा मैं महसूस करता हूं। लेकिन जैसे अभी थोड़ी देर पहले डीटी साहब ने बताया कि हमारा गोगी एरिया में 2 छोटे डेपॉजिट से एक एसिड रहेगा, एल्कली रहेगा। लीचिंग तो हो जाएगा, लेकिन अगेन कॉस्ट बेनिफिट प्लांट हो सकता है हमको कि एल्कली लीचिंग वाला को तुमलापल्ली भेजना पड़े या वहीं करना पड़ेगा, बट प्रोसेसिंग पार्ट में हमारे लिए कोई टेक्निकल चैलेंजेस नहीं रहेगा। बाकी कॉस्ट बेनिफिट वाला पार्ट वो देखा जाएगा। अभी हाल फिलहाल में इस तरह से मैंने कहा कि टेक सेवी होने का जो कीड़ा है हम लोगों में, अभी हाल फिलहाल में डीटी साहब हम लोग को जेडल भेजे थे, वहाँ कुछ देख करके आए। तो वहाँ देखने के दौरान हम लोग को पता चला कि पेस्ट फिलिंग वहाँ एसके माइंस वगैरह में किया जा रहा है, बखूबी किया जा रहा है। इससे मेरा अपना विश्वास है, कुछ प्लानिंग वगैरह भी अभी हम लोग कर रहे हैं कि जो रिकवरी परसेंटेज है, खास करके लास्ट टाइम जो आपके साथ पांडे साहब के यहाँ हैदराबाद में जो प्रेजेंटेशन हुआ था, एमडीसी के चेयरमैन सब आए थे, उनका एक बात मेरे बड़ा दिल को छू लिया था। एमडी काफी कुछ एक्सप्लोरेशन करके देता है, मिलियंस एंड मिलियन टन्स ऑफ minerals, reserves, uranium, this and that. It depends कि mining वाला उसको कितना recover कर पा रहा है. हमारा recovery percent hardly 50%, 60% या 65 इस तरह से रहता है overall recovery. उसको अगर हम बेहतरीन तरीके से और रिकवरी कर पाए तो शायद वो सही ट्रिब्यूट रहेगा जो एएमडी के जितने डायरेक्टर्स, रीजनल डायरेक्टर्स ने बखूबी टेंट में धूप बारिश में बिता के इतना सारा एक्सप्लोरेशन करके दिया है. तो ये कैसे रिकवरी होगा उसको लेकर के एक छोटा सा ये है कि अरेंजमेंट है. तो मेरा अपना जस्ट एक थियोरेटिकल कैलकुलेशन था, अभी तक हम लोग एस्टैब्लिश नहीं कर पाए हैं. अभी का सिस्टम में हम लोग का रिकवरी परसेंटेज जो है 65 to 70% है, बाकी पिलर्स वगैरह में लॉसेस है. तो मेरा अपना मानना है कि वेस्ट फीलिंग अगर करेंगे तो हो सकता है रिकवरी परसेंटेज मेरा 80 to 85% चला जाएगा. अगेन इसमें भी कॉस्ट बेनिफिट एनालिसिस करने की जरूरत है जो हम कर रहे हैं. ये हमारा रेस बोरिंग टेक्निक को लेकर के था, कुछ पिक्चर्स वगैरह हम लोग साइट में गए थे. इसके कारण आप सेफर और क्विकर माइनिंग प्रैक्टिसेस हम लोग फॉलो कर सकते हैं. कुछ चीजें और ला रहे हैं हम लोग इन हाउस यूसीआईएल में, रादर एंटायर माइनिंग इंडस्ट्री में होने जा रही है. ये इलेक्ट्रॉनिक डिटोनेटर्स का एप्लीकेशंस, ये गवर्नमेंट की तरफ से इंस्ट्रक्शंस आ गया, हमें तो करनी ही पड़ेगी. बाकी छोटे पार्ट्स में उसको हाईलाइट नहीं किया है. खाली फ्रॉम एएमडी पॉइंट ऑफ व्यू जो मेजर चीज है, ड्यू टू नियरली कंट्रोल ब्लास्टिंग, काफी कंट्रोल ब्लास्टिंग किया जा सकता है इलेक्ट्रॉनिक डिटोनेटर में. एज ऑन डेट हम लोग नॉनेल यूज कर रहे हैं और बाकी इलेक्ट्रिक डिटोनेटर यूज कर रहे हैं. इलेक्ट्रिक डिटोनेटर भी बैन होने जा रही है, अगर बैन हो चुकी है. So due to nearly controlled blasting, less shattering and back breaks will be there, resulting in less dilution. और ज्यादा समय ना लेते हुए मेरा अपना मानना है, विश्वास है, अर्थ we have borrowed from our children, it's not ours, it is said so. लेकिन similarly it can be said for the minerals resources too. So we should work on methods from where the recovery should not be optimized, rather maximized. At UCIL, we have gone through the various changes from time to time for better recovery. जैसे मैंने बताया, श्रिंकेज स्टॉपिंग लेके, हीप लीचिंग लेकर के, हॉरिजॉन्टल कट एंड फिल माइनिंग मेथड को लेकर के, तो बेटर इकोनॉमी और बेटर सिस्टम के लिए. क्योंकि मेरा अपना मानना है, अभी जो जनरेशन है, अभी जो समाज है हम लोग को, तो हमारे लिए एक चैलेंज है. इसी के लिए एक छोटी सी शब्द है, लेट्स हैंड ओवर देम द अर्थ in which they can live and enjoy to the tunes of their own day with better mineral recovery. अभी रेयर अर्थ और ये सब बारी की बातें हो रही है, तो जितना ज्यादा हम लोग करेंगे, कारण यह है कि खाना तो हम दोबारा उगा सकते हैं. हो सकता है झारखंड में एक बार खेती हो रहा है, 2 बार खेती हो रहा है. न्यूअर टेक्नोलॉजी दिस दैट, बहुत सारा इरिगेशन सिस्टम वगैरह है, वर्टिकल इरिगेशन है, सब करके हो सकता है हम 4 बार भी खाना उपजा सकते हैं. लेकिन मिनरल्स वंस इट इज लॉस्ट फॉरएवर. तो ये जस्ट thanks to the AMDR on behalf of UCIL family and the people of Singhbhum for exploring the fuel of future India, which will be fueling our quest for mining in a mega scale and subsequently bring prosperity to the corporation family and the people of Singhbhum. Thank you, sir.
Thank you very much, sir, for the thoughtful presentation. At this moment, I now request Session Chair, Shri Dheeraj Pandey, sir, to please present memento to Shri Manoranjan Mahali, sir. Thank you very much, sir. We have now arrived at the final presentation of this session, and it is my honor to introduce our last speaker of the day, Shri Sushobhan Neugi, Senior Geologist, GSI. His pioneer work in detailed lithological and structural mapping of the Meghalaya Gneissic complex helped in resolving long-standing geological complexities in the region. He led the commissioning of SIMS facility in 2022 and successfully established internationally accepted analytical protocols with several stable isotope protocols under review. He is currently pursuing a PhD at ISM Dhanbad, focusing on fluid evolution related to gold mineralization in North Singhbhum mobile belt. Sir will be presenting on the topic Mesoproterozoic copper uranium mineralization in Singum Shear Zone, a SIMS stable isotope perspective. So let's give him a warm round of applause. So please.
Good afternoon, everyone. So this presentation is about looking the copper uranium mineralization, rather relooking the copper uranium mineralization of the Singhbhum Shear Zone from a stable isotope perspective, and be specifically a secondary ion mass spectrometer be stable
stable isotope analysis because it has some significance that I am going to discuss. So this is the photograph of the most advanced secondary ion mass spectrometer available right now in the world and which has been installed in the GSI. And these are the photographs of the mass peaks of sulfur and oxygen. Just put up for your reference. Okay, so the question is, can stable isotope revolutionize the mineral exploration? So this presentation is just going to take together whatever you people are all discussing from today's morning based on the field experiences, based on the exploration experiences. Let's think together whether we can rethink about the metallogeny in terms of ore genesis. So our ore genesis model typically lies between source to sink framework, right? So what is the source? So we need a source of metal first, then a hydrothermal fluid which carries the metal. So what it needs, needs a blinding ligand that dissolves the metal complexes in the hydrothermal fluid, then a transport mechanism, then a precipitation site where the physicochemical condition, changing physicochemical condition allows the metal to precipitate it as a ore deposit. So in this line, how the isotope data is going to be helpful, right? So to understand that, we need to understand the science behind the stable isotope fractionation. So there are two types of stable isotope fractionation usually. So one is the relic type of fractionation and one is the kinetic fractionation. So what relic type of fractionation tells about? So it tells about the equilibrium fractionation between the two medium where the fractionation is either way. So and the kinetic fractionation is a one-way fractionation where it controls the reaction rates. For example, the biological fractionation, for example, the silica secreting organisms, say radiolaria, fractionating silica from the seawater, it's a kinetically controlled, is a one way. Uh, uh, in contrast, the relic type of fractionation, it's a continuous process between the fluid and the solid phases. So these two processes, understanding these processes is important because getting a stable isotope data is not going to useful unless it is verified with other parameters that I'm going to discuss in the next. So there is a famous paper, applying stable isotope to mineral exploration, teaching an old dog to the new tricks. So this paper explicitly explain how we are going to change the concept of the ore metallurgy, or I rather say how we are going to understand the ore genesis model in a better way by using the stable isotope. So the left hand figure, it shows how the stable isotope fractionation graphically changing places. For example, while the rainwater precipitation took place, it precipitated the heavier oxygen isotope. So the seawater enriches with the daylighting O, while the evaporation, it just happened just oppositely. So with this concept, why seems to plays a major role in this analysis. The left hand picture is the cathodoluminescence images of a multiply zoned quartz grain, right? And the below is the image of multiply zoned sulfides. So the picture clearly says that the quartz and sulfide grains had multiple hydrothermal histories. So once the grain has been crushed and diluted and subjected for isotope analysis, you have multiple histories. It has gone. So you are getting a compromised data and you are ending up with interpreting the data with very wrong way or in other way. So SIMS has a capacity which has been designed to resolve the spatial resolution in a much better ways, where you can analyze the multiply zoned hydrothermal events step by step, zone by zone, to bring out the histories over multiple events. So what it did, so this is the world map with the SIMS isotope data where the scientists are extensively using the isotopes, rather in situ stable isotope data for targeting the orogenetic model. So it has the immense capacity to resolve the multiple hydrothermal overprints. And the below diagram you can see. So this diagram you can see the earlier the range of different orogenetic model for the stable isotope data was much larger and much overlapping zone. So which had so anyone can interpret it in either way, but with the advancement of the instrument and with the advancement of the SIMS, the data and the range are getting narrower and narrower. So with this concept, we targeted a Singhbhum Shear Zone. So this is the geological map of Singhbhum Shear Zone. So these are the mines from northwest to the southeast, and these are all possible published data of ages, fluid salinity, and existing isotope data we have compiled over the different mines. So we have targeted a Kendadi mine which previously had no data in terms of isotope or fluid salinity, and the concept was that let's think Singhbhum Shear Zone more holistically, rather than thinking that each mine has a different story. For uranium, there is a different story. There is a copper, there is a different story. Rather think how Kendadi is different from other mines in terms of its isotope fingerprinting, in terms of its fluid salinity, and in terms of orogenetic model. So this is the few of the field photographs representative from the Kendadi copper mines, where we observe that there is a distinct, highly intense myelinized zone outside the ore body that is basically made up of quartz biotite chloride schist with minor tourmaline and magnetite, and there are down plunging stretching lineation typically indicative of the transpacific shear zone. And this is the photograph below the Kendadi copper mines, where the ore shoots are parallel to the myelonitic foliation, and it's more like a tabular or sheet-like form. The myelonitic foliation here is steeply dipping, and the stretching lineation are steeply plunging. And in the wall rock, there are abundant hydrothermal alteration, which include the silicification, chloritization, biotization, and tourmalinization. And the main ore shoots, interestingly, now from this point, you observe a little important thing on each point. The main host rock is myelonitic or ductilely deformed, while the ore zone there is no evidence of ductile deformation. Rather, you can see the ore body, the copper chalcopyrite pyrite. These are distributed within the brecciated or fracture filling zones of the quartz grains, right? And these are filled up by chlorite also. So we addressed rather the geology of Kendadi in terms of host rock petrography and ore zone petrography. The host rock petrography, what we observed in the field, is exactly replicated in the petrographic photographs. Ductilely deformed quartz, chloride, biotite schist with subgrain formation, stretching quartz grains, and the magnetite that are enriched with the chromitite core. That means these are the magnetites of the host rock, not from hydrothermal magnetite, and the fracture fillings of the magnetite grains are filled up by lead chloride, which are and a close lookup of this quartz chloride schist photograph shows there is a fold of the chloride foliation zone where the chalcopyrite grains are following the foliation plane. You can see a better reflected light photographs where the chalcopyrite and pyrites are following the fold foliation. That means our primary interpretation from this data was the ore mineralization was there while the ductile deformation was going on, right? Now, while we address the petrography of the ore zone, while we saw a completely different story where the quartz grains are subgrain formation, the broken quartz grain, and the fracture fillings, sulfide deposits, along with the chloride, sulfide, and pyrite, chalcopyrite, covellite, everything is texturally equilibrated. That means they precipitated at the same time frame, and they were texturally equilibrium for a certain physicochemical condition. And there are some late stage alteration of chalcopyrite, which are very insignificant. So from these two slides, we can just clearly say there was a domain of ductile deformation where the host rock was getting deformed. There was a chalcopyrite mineralization of the rather sulfide mineralization, which is insignificant in terms of economic point of view. And there are major ore loads which is hosted within the quartz, seated quartz or the quartz veins that is parallel to the mineralitic foliation and which has no absolute ductile overprinting. That means we are possibly looking at two different depth zones. While the host rock is in the ductile domain, but the main major road lies in the brittle domain. With this concept, further, we did the fluid salinity analysis of the fluid inclusion data and the homogeneous temperature calculation, and we compiled all the data from the Singum Shear Zone existed at this point of view at time. So the salinity data earlier, you can see the Rakha mines and Moshaboni mines. It was only showing a very high salinity domain, while the Turamdi is also very high salinity fluid inclusion data. While most of the publications was not reporting the low salinity data is also present here, only few of them was reporting that. While we did the salinity analysis, so we found there are three types of fluid inclusion. Type 1 inclusion is mostly a fluid saline inclusion, and which has a homogeneous temperature between 180 to 332 degrees centigrade. Type 2 is the aqueous carbonic fluid inclusion, which has a greater homogenization temperature, maximum 335 degrees centigrade. And type 3 is the moderately saline, high saline, moderately temperature fluid. So from the fluid salinity data, you can see there is a high saline fluid and there is a high and low saline fluid unmixing. So we calculated the fugacity condition at the depositional condition of the sulfur fugacity and oxygen fugacity, and we found that there was a high sulfide fugacity and very low oxygen fugacity at the depositional condition. So with next slides, so we did the in situ stable isotope analysis of that exactly what you saw in the field and in the microscopic photograph, that texturally equilibrated chalcopyrite, pyrite, and quartz grain. And we did the isotope analysis for an entire range of the thin section to see the late hydrothermal overprinting or what are the other cases happened here. And you can see the spotted spots of the seams, which are very 8 to 10 micrometer depth, which is able to spatially resolve if the hydrothermal overprinting is there or not. And see the beauty of this analysis. The pyrite and chalcopyrite both is showing 11.7 plus minus 0.1, 11.7 plus minus 0.2. So such a narrow range of sulfur isotope data. With the quartz isotope, oxygen isotope data in the quartz is 6.9 plus minus 0.13. So from the isotope data, I can say with much confidence level, there is no hydrothermal overprinting, at least in the Kendadi copper mine. So with this isotope data, we did, so since the isotope fractionation between the isotope, between the crystallizing mineral phase and the hydrothermal fluid is temperature dependent, and rather it is inversely temperature dependent, we can easily calculate the isotope data of the hydrothermal fluid at the time of the deposition. So using that empirical equation and the maximum fluid inclusion temperature, we calculated the fractionation factor was around 5.6 per mil. So we recalculate the del 18 of the fluid at the time of deposition was 1.3 per mil, and the del 34 of S of the hydrothermal fluid was around 10.7 to 11.7 per mil. So we plotted the data over the global data sets available so far, and these are the data, entire data published so far from the Singum Shear Zone, where the Kendadi copper deposits, just 2-3 minutes more. So Kendadi copper deposits are showing very restricted data range, right? So similar for the oxygen isotope data. So now time to interpret the isotope data. So del 18 of the quartz is 6.9 per mil, which is the isotope data typically match with the quartz precipitating from a fluid coming from a magmatic water, right? But the del 18 of fluid at the time of precipitation was 1.3 per mil, which was lower than the magmatic value. So it indicates there was a mingling between magmatic water and meteoritic water. So, but it was not from the pure meteoritic water, because the meteoritic water, the oxygen isotope data is negative value. So it is more likely that it's a mixing between, or the fluid dilution, what we tells scientifically, between the magmatic water and meteoritic water was the most possible mechanism. And del 34S value is relatively high, which indicates the sulfur was in the form of SO2. So it was in more oxidized environment rather than more reduced environment. And the SO2 disproportionate reaction usually enriches the del 34S to up to this value. And the existing hydrogen isotope data from the Mosabuni copper mines, it was -32 to -44, is typical of magmatic water. And boron isotope data of the syntectonic tourmalines from the shear zone between +2.5 to 6.3, which all says that the hydrothermal fluid was derived from a magmatic water, and it is of no doubt. So the so we calculated the condition where now I am not thinking copper is a different entity, or sulfur uranium as a different entity, or the Re as a different entity over the Singhbhum shear zone. Let's think about the solubility of copper and uranium together in the source region in terms of salinity and redox condition of this magmatic condition. So the thermodynamic model calculated that says that the copper chloride complexes are stable over this region, while the uranium chloride complexes are stable over much oxygenated environment, while the copper chloride complexes are stable over the reducing condition. There is a mixed zone of salinity 15 weight%, and the oxygen fugacity between -17 to -19. This is the perfect zone where both the copper and uranium are soluble in a single hydrothermal fluid. By forming these copper chloride and uranium chloride ligands. And the del 34S value, the high del 34S value found from this Kendari copper deposit, perfectly satisfied what we required for a much oxidized environment for dissolving copper and uranium together. So now the question comes, what is the source of metal then? So copper, experimental studies says that copper can be hosted significantly in the biotite up to 5000 ppm, and in chloride, and also in forms of magmatic sulfides. Wherever uranium can host in the zircon, apatite, monazite, and elanite. Let's think about a remelting of a granite crust which saturates the metal at the top of the magma chamber by remelting these following minerals. So while saturated with this, due to the polymerization at the top of the magma chamber, it is saturated with the necessary metals, necessary ligands, and ready to go if it get a path. Perfect. So with this concept, so there was a magmatic source. Let's hypothetically imagine there was a magmatic source. There was a pathway. In this case, it was a Singhbhum shear zone, and there was a site where the copper and uranium mineralization deposited. So from the petrography, you can see there was a zone, the copper mineralization was going on in the Kendari in a ductile regime. There is a zone, major mineralization, where the copper mineralization actually happened in a bulk volume. So this is the path along which the meteoritic water from the shear zone was percolating below the ground level, and the hydrothermal fluid was coming against the gravity, and it's the dilution zone as evident from the isotope data. And there is a zone where there is a certain failure in the brittle failure from ductile to brittle. As we know, the Singhbhum shear zone is the terrain boundary between North Singhbhum mobile belt and the Singhbhum craton, and there is a transpression type of shearing, and the North Singhbhum mobile belt was thrusting over the Singhbhum craton in the south. So this This is the ideal place where the rock changed the depth suddenly from a ductile to brittle regime. So possibly the mineralization started in the ductile regime, but the major mineralization happened while it changed the ductile to brittle regime. Now what were the conditions which helped copper chloride and the uranium chloride to destabilize and get precipitated over this place? So these are, we calculated using the C-Space software from the mineral texture, the biotite along with the copper chloride and the water, and with the existing HS minus ligands, it stabilized chalcopyrite immediately due to the change of oxygen sulfur fugacity slightly, while uranium has a large range of stability within the redox within a wide redox range. So copper chloride and uranium chloride deposition completely dependent on the host rock petrography. So if you see the geological map of the Singhbhum Shear Zone, you can see, or you can differentiate, or you know better than me since you are doing the exploration over there, there is a change in the host rock petrography of the entire shear zone length. And based on that, you can identify there are certain places where there is a copper dominated deposit, there are certain places where the uranium dominated deposits. And all these things, what happened, the product of this reaction is H plus and Cl minus. And there is a, you know, there are places where there is acid metasomatism in the Singhbhum shear zone along which. So it perfectly explains why that acid metasomatism took place along the Singhbhum shear zone. So with this concept, I will just quickly say this thing. So we model how, sorry, yes, sir. Please, this is the last slide. So with this model, we concluded that how the fluid evolution model took place with the depth and how this mineralization took place along the Singhbhum shear zone, and with the oxygen isotope data and hydrogen isotope data, we modeled how the fluid evolution and mixing line took place. And for a more detail, you can go through the published paper, which explains in more detail. And now, just last slides. So this is the cross section of the what we see in the North Singhbhum mobile belt. If you cut it and you see the Dalma plume is just below the North Singhbhum mobile belt. So we hypothesized that the Dalma plume was the main culprit, while he remelted the lower crust of the North Singhbhum mobile belt, and this I-type granite it generated, and it saturated it with the metal and ligands required, and Singhbhum shear zone was already there, and it transported the metal over that. And these are the published geochronological ages so far from the Singhbhum shear zone. It shows the spikes from 1.8, 1.7, but the Singhbhum shear zone was dated 1.6 billion years by rhenium osmium dating of the molybdenite, and the age of the Dalma formation, Dalma plume is 1.63. So willing possibly the Dalma was the main reason for remelting and such a regional scale metallogeny over here. Thank you very much. So also we welcome all of you for future collaboration in stable isotope. We are ready to collaborate. Thank you.
Thank you very much, sir, for enlightening us with your presentation. I would again like to request Session Chair Shri Dheeraj Pandey, sir, to kindly present memento to our esteemed speaker. Thank you very much, sir. As we have come to the end of this enlightening session, it's time to express our gratitude to the rapporteur of the session, Shri NRR Ekka, sir, who has captured the key highlights of today's session. I kindly request Director AMD to please present the memento to Shri NRR Ekka, sir. I would like to thank Shri Dheeraj Pandey, sir, for honoring our speakers with your gracious gesture. We deeply appreciate the wisdom shared by each of our speakers today in this session. Thank you once again for all of our distinguished speakers for their insightful presentations. We'll now take a short break for lunch. I would like to kindly invite our esteemed guests, speakers, and participants from different organizations to enjoy the lunch. We will reconvene here at 3 o'clock sharp, and please make sure to be here on time as we have lined up some exciting presentations for our afternoon sessions. Thank you.
Good afternoon to all. I request everyone to be kindly seated. We are heading towards the session 3 of the team meeting. Respected dignitaries, esteemed speakers, and all those who have joined us today, a hearty welcome to session 3. In this session, we have some insightful presentations lined up covering topics from petromineralogy, mineral chemistry, metallogeny of uranium to mining, ore body geometry, and secondary resources of RAE. It is my honor to invite respected Additional Director OP2 PK Sharma sir onto the dais to chair the session. Sir, please. I also invite Dr. R.K. Mandal sir, in charge Chemistry Laboratory Eastern Region, to come on to the stage and be the reporter for the session. Without wasting much time, we'll begin with the first presentation. It is by our Regional Director, S.K. Das sir, on emerging geological understandings on metallogenesis in Singhbhum Shear Zone and future perspective for resource augmentation. Sir.
Good afternoon, ma'am. Director Sahab and all other dignitaries and friends. Topic very pertinent topic what I started in the morning. For the years as I know, as you all know, that we have been working in Singum Shear Zone with different concepts, but we are continuing to getting. So as long as we are getting, there is no problem. But why we are getting, where we get better, that is the challenge for us. So that is how my talk will be. And it's not by me, it is by the entire team of CMD. I will be talking exclusively on the observation part of the Singhbhum vulnerability. And finally, based on all the observations, what is the genetic model that best fits into it, and based on that, I am audible. I am audible. So, considering that most important is of want to understand to get our knowledge to improve upon our thinking and expression targets. So, this is my source of information. I will not go into it. I'll start with all observations very fast. Everybody knows all have worked in the Singum Shear Zone very fast. We are not discussing who is right. We are trying to discuss what is right. Next. So this is the Singum Shear Zone, as you all know. If you see the disposition of the various rocks, this is the Singhbhum pattern, the different age, different type of rocks. And in the North Singhbhum mobile belt, we are having a different type of suit of rocks. And within the shear zone, characteristic rock assemblage is there. Next please. As you see, these are the conglomerate beds of the Dhanjoris or the IOG basin, the older conglomerates. Udalkam, Lylom, and all other places. They are the outside the shear zones. These are also shear places, but they are due to different shearing process, pre-Singhbhum shear zone. They are something related to the older process. As we come towards the Singhbhum Shear Zone proper, we get a beautiful marker bed of conglomerate, known as conglomerate, which was the first discovery of our Singhbhum Shear Zone uranium mineralization. So this is the conglomerate which is best developed between Rajda and we can say Pathargoda. And some conglomerates are also present in the Singhbhum area. This conglomerate we are now interpreting it to be conglomerate. I am coming to that. Next. These are the location of this pyrophyllite. As you all know, there are specific occurrence of pyrophyllite within that. Why the pyrophyllite is occurring there? Many people believe that this pyrophyllite are the metamorphosed paleosol. It is not because it is occurring at different stratigraphic level within the feldspathic schist will be derived from soda granite. So this is something different. Next, we are talking about kyanite quartzite and the soda granite. They are also having a peculiar occurrence which is circumferencing the Singum Shear Zone. And there is no younger granite which is occurring within the this happening part. Younger in the sense we are getting the granites of the age of 1.8 or younger, 1.6 or 1.4 like that. But one Mahakur Sahib was telling that he has observed some younger granites within the Tanzori. I want to clarify with that, sir. I'll come to that, not I am discussing that. I want the clarification later. Next. Very quickly I'll go through. Is the conglomerates are very stressed, and these conglomerates are of different sizes. You can see the size of the conglomerate class 70 centimeters. Somewhere it is very pebble size or a bit finer. And somewhere it is glass supported, somewhere it is matrix supported. Most of the parts they are flattened and stressed along the minority follicle. Next, these are the common observations at different places. I will not read again. Next, and these are the different places conglomerate, different types. Now coming to the field of shear fabric. This shear fabric we are getting only within the shear zone, obviously. And it is not present north of the shear zone, not present south of the shear zone. Within that, we are getting different shear lenses, sigmoidal foliations, and all south verging asymmetrical folds we are getting with longer northern limb and shorter southern limb. All south verging. CC fabric, SC fabric are very common. It is all known. Everybody has seen this. This delta structure, sigmoidal structure, shear fabric. Next, just observation I am showing. There are different types of lineation getting, pebble stretching lineation, mineral stretching lineation, striping lineation. These are the very common observations along the shear zone. And post shearing, there is some compressional forces happen some places. We are getting recline fold, we are getting several folds. There are different pockets developed due to this stimulation and all, king folds, recombinant fold, and different types of folds of superposition, like F2 and F3. Means this is type 2 interference pattern or type 3 interference pattern. Next. These are some more photographs to show how complex the core body means the host rock is in some part of the shear zone. Next. Now, in totality, if you see, this is the part of the Singhbhum pattern which is relatively less deformed, not having the younger shoot of rocks. In the northern part, we are having a more or less compressional regime, and there is part of shear zone which is 1 kilometer to 5 kilometer with about 200 kilometer length long zone of ductile deformation having the shear fabric. And these shear fabric are in different parallel zones. That means it is not one single shear fabric. There is one shear, parallel to another shear like that. There are several shears. Some are 5 planes you are getting, some are 3 planes like that. You can count those things. Next. And these are some of the more photographs showing the type of shear fabric that we get in the outcrop and in the core microscope. These are very common things, nothing to show more. And in this, there are some syntectonic minerals that are formed. We are getting some garnets which are fractured, some garnets which are not fractured. They are telling that it is having different genesis. And we are getting some inclusions. Uraninite is occurring as inclusion with many minerals. Biotite, chloride, turmaline, apatite, even sulfide, magnetite. You name any mineral, you will find inclusion of some mineral. So this should not be ignored. Next. Here we are getting the magnetite, uraninite inclusion within the garnet. Here it is within hornblende and apatite. Hornblende is having the inclusion of uraninite within the shear system. And these hornblendes are occurring within SCQS or CSQS, like the host rock of mineralization is chloride, ferricite, quartz, suppose. Within that we are getting hornblende. How? And even within the quartz, late generation quartz, released quartz, within that also getting the uraninite inclusions. And there are some zoning also is present. That uraninite is occurring in talonite. So within any mineral, uraninite having coexistence in the form of impregnation. Next. And as we come to mode of occurrence of the uraninite in the Singum Shear Zone, typically 4 types we say along the myelonetic foliation, following the foliation planes, or with apatite magnetite veins, or within the inclusions within different minerals. Another is close association with sulfides or the lateral quartz veins like that. So this sulfide, this multiple episodes of hydrothermal activity also you can clearly see from the slides. This allanite is encircled by epidote, which is again encircled by linogelcite. Here we are saying allanite is encircled by epidote. Here we are saying epidote is reverse zonic. Epidot is encircled by alanite. Here we are getting this uraninite within the alanite. And here the terms of two generations of biotite within the, you have different. I am showing very rapidly because my younger colleagues will show in more detail. And we have also different generations of chloride within the system. Next. And there are different types of uraninite. Somewhere it is neutral, somewhere it is wave-shape, somewhere it is nearly neutral to prismatic, and these are within the magnetite it is getting, within the hematite it is absorbed. So many host of occurrence, and most important mode of occurrence of uraninite along the milotic foliation in most part of the Singum Shear Zone is anhedral. So how it is anhedral in most of the cases. And here the uraninite association with the sulfide. You can see the close association showing there closely associated. But there are some photographs to show that this chalcopyrite is occurring as inclusion within uraninite. Or vice versa. There are some chalcopyrite containing inclusion of uraninite. So that type of common observance we have seen within the system. Next. And you can see the beautiful zoning of the uraninite. See, we have got different types of zoning. Here, this three types of zoning has been observed. Of course, it is not my slide because we cannot do this high-end research of the Indian. This is taken from a reference, and I have given the due reference to this also. And thorite is circled by alanite. Apatite is consumed by thorite, and here it is a zone turmaline grain with different generations of turmalines. Now, little going away from the shear zone. I am now moving little away from the shear zone towards north. Next. The shear zone rock are highly deformed, highly mineralized, showing this beautiful acid fabric, and they are regionally metamorphosed in the form of green sea species metamorphosis. As you go towards north, suppose I am going towards Dalma, there what I find, they mostly it is phyllite, or they are arenite, or heterolithic rock, containing beautiful primary sedimentary structures. So how in a regionally metamorphosed sequence, the primary sedimentary structures are written? And in this, the wave ripples are there, cross lamina are there. Next. Beautiful, most important thing is that you can see the pillow structures. These are the liquefaction structures. This shows either it is peri-contemporaneous deformation or post-deposition liquefaction due to seismic activity. So these are the two alternatives that can be form the pillows, and you can see beautiful pillows. And these are the observations from our this year's field work by our young officers, and they are beautiful flame structures, convolute weddings, water sheet structures. Next. I am only showing all the field photographs to factual data. Next. Same thing. You can see that sectional view, plan view, how it is occurring, sectional view, how it is occurring. Just like a volcanic agglomerate or some sort of thing, we are also getting a heterolithic log. You go to Singhbhum airport, you will get that beautiful heterolithic log in which climbing ripples are seen in one part of the ball, and in another you will get plain cross bedding. How is it possible? Next. So these are all indicative that some volcanic activity took place during the post-sedimentation time. These are the beautiful pillow structures. All are beautiful. Many places I have shown. So they are documentary evidences only. My observations all are on fact on next week. Now coming to Dalma, I am going to be looking further. Many people have different idea about Dalma, but the recent data this is taken from the ESI-2019, it shows that based on trace element geochemistry, it is having island tectonic activity. And if anybody has happened to see Dalma, it is showing lower amphibolite species metamorphism. That means I am starting my area from Singum Shear Zone, green sea species metamorphism. As I proceed further, it is a very low grade metamorphic rock containing the sedimentary structures. As I am going further, it is some sort of a island setup having high grade of metamorphism. And I am crossing this this particular setup of Dalma, it is Chandil formation, which is again showing primary sedimentary structures. So based on all these things, and there are some typical high pressure to high temperature mineral association within the SSA. As you all know, we are having pyrophyllite, we are having a kyanite zone, fluoridates are present, domatite are very common at many places. There are some of the minerals, mullite, lazulite, pigeonite. Pigeonite is a very high temperature mineral. Mullite is a high, this lazulite, mullite, they are all high pressure minerals. We are having beautiful association of cassiterite, phyllite, perovskite. There is a place, so we have got the presence of perovskite. How can perovskite occur in this particular setup? Eugenite is present, niobium, titanium, uranium complex is present, bergasite is present. Serpentine talc is very common in the footwall side of our uranium loop. So how, what is the role of the serpentine, or what is the meaning of this talc? So these are the various observations that I am noting down. Next. Just publication data, if you see, as a compilation of data in the cathodic part, everything is older than 2.2 billion years. Everything is older than 2.2 billion. I am coming to the Taivasa sediments. After the tectonic contact, I don't know what is the age of the Taivasa, but based on the intrusive granite into it, it is definitely older than 1.8. And we have the different types of rocks, and the Dalma, as you say, that is having 1.65 to 1.6 billion years, something like that. Different people have measured differently. Around 1.6, maximum older age of Dalma is 1.6, younger age of Dalma is 1.45. Many people have that publication. So that is the sort of variation of age rocks that we find across this year, not all of them, across this year. Next. We have the same compilation of uranium minerals or sulfide minerals. We are having the older date. I will, Sushovan has presented a very nice talk, but I would like to know how can you explain the presence of the 1.8, 1.9 billion year these episodes with Dalma. Dalma is 1.6. So how can you explain this 1.8? And as you know, based on the published data, the age of our sulfide mineralization within the Usavani Raka sector is mostly 1.7, 1.76. So how can you explain that? Okay, that's several points to be shown. I am coming to all the points. Again, I am telling, I am not discussing who is right. Let us discuss what could be right. Okay, so the different types. One major observation I have also seen from this boron delta 11, that this is a paper from Sarita Patel et al. 2021. They have interpreted based on this boron data that it could be due to some subduction process. And based on the age of allanite and other things, this is 1.88. This is another younger dates are also there. But I am asking about the presence of these dates, how to be explained to Dalma fluid. Next. So I compile all the data that we have got from our internal source of stabilized data from our Hyderabad laboratory. It is mainly twofold. Two populations. One population broadly having a del 34 value sulfurized data in the range of 1.5 to 2 per mil, and another around 8 to 9. So one at the lower range is indicated that it is a high temperature hydrothermal source produced from mafic magma that has created this particular del 34 value. And then lateral activities, there are some several release silica along with sulfide is also coming. Those sulfide, if you analyze, that is showing a hydrothermal system, which is again an elevated temperature, but that does not show a magmatic source. It is high temperature hydrothermal, but the lower one is high temperature hydrothermal source related to mafic source. So these are the common interpretation from the sulfur isotope data. Next. And these are the values of boron isotope data that I compiled from different sources that all indicate that the presence of these turmalines and this boron data is due to some subduction process. In the next. Now, if I show what I have told you so far, this is the cationic part, this part is cationic, this is the crescent shape, our Singum Shear Zone. And as I go towards the NSMB, so this is the Dalbum, this is the Dalma, this is the Tanban. And if you see the structure along this, it is ductile regime. Once you go away from it, it is compressional regime. If you see Dalma, it is highly metamorphosed, deformed, but Dalbums and channels, they are not deformed. How it could be? So what type of system can be? If you imagine to this, there could be, this is an island type of setup is evident from the geochemical data for Dalma. So if there is something which is subducting, this can happen. Just could be. Next. So you imagine that, as you all know, even Mahakul Sahib also told correctly that there are some mafic, ultramafic rocks which have intruded into the cationic part, into the Dhanjari, into the IOG. In some younger mafic, ultramafic sequence is present post Dhanjari. It is a very correct observation. But sir, you have mistakenly quoted from Rajendra Sahab that it is intruding into the Taivasa. That is your own interpretation, sir. Sir never told that. So it is. We have seen many sections. It is not intruding into the Taivasa. It is Yes, yes, sir. Yes, that is explaining the mineralization, but it is not including. It is explaining in fact. Okay. So shall I stop, sir? So here, Aju sir, next. Next, sir. Jaldi karo. Next. Jaldi 15 minute हो गया. Next, please. Next. Next, please. Next. कौन है सर? कौन कौन? ये एनिमेशन चला दो. तो अच्छा लगे तो 5 मिनट दे दीजिए. ये सब का सुनाने में था. ये चला दीजिए. Through this animation, I will try to explain what I have told you so far. So there is Singhbhum granite, overlain by IOG, overlain by Dhanduri. They have deformed, and there is some intrusive mafic, ultramafic body which is subducting due to some reason beneath the Taivasa sediment. That means initially they are not together. This is Dhanduri, IOG are not in contact with Taivasa. They became in contact with Taivasa because of the tectonic contact. These are the debris flows type of mineral deposits that we see as conglomerates. These are the conglomerates. They are because of the subduction. We are getting some granitic magma going along the shear zone, some across it. So these are the type of, as you go deeper and deeper, subduction is going deeper and deeper. We are getting this sort of diaperic activity, Pluton's activity, and away from the shear zone it is compressional regime. Within the shear zone it is all ductile shear, and we are getting the bottom longer northern limbs, shorter southern limbs. That sort of all sort of explanation can be given there. And as the subduction is going more and more deeper, this it is going up to asthenospheric state, then it is completely melting, and the plume is getting generated at around 1.6 billion years. So this is what is happening for Dalma, and as it is going, as the body is going downward and forward, means it is trying to subduct. Two forces are acting. It is trying to move downward and going forward, and the counter force is acting against it. The buoyant force is upward, and the counter force resisting this movement, forward movement, is backward. That is why we are getting the compressional regime there, and as the forces are acting parallel to the body along the shear zone, we are getting a shear regime. So here everything is ductile, here everything is compressional, and if you go towards north of Karnataka river, there you will find that all the beds are mostly dipping towards south. Here everything is dipping towards northeast. There they are all dipping towards south. Or both the things are there, and the Dalma is also getting compressed and coming towards because of this forward movement. The opposing force is countering it, and it is bringing this. And at some point of time, that has come in tectonic contact with one another. And after erosion, what we see now is this one. So what we see is ductile regime. Here it is a compressional regime with number of granites within this shear zone, across the shear zone, and Dalma. So this explains almost everything that we see. But this has not. This will tell us about the paired metamorphic belt. Along the trench, we are having this kyanite, pyrophyllite, high pressure, high temperature minerals at some places. And as you go away, it is regionally metamorphosed. So that paired metamorphic belt, classical paired metamorphic belt we are getting here, only absence is the absence of the blue sea species. Glauconite, lawsonite, we are not getting. And literature says that more than 750 million years of glauconite has so far not reported anywhere in the world. And I am talking of exactly 1 billion years ahead of that. Because lawsonite and glaucophane are very unstable minerals. They cannot, they become unstable and change to some other mineral. That could be the reason. Next, I come. So this explains the structural part. It explains the granitic activity, granitic activity. But the recent discovery of the Udada, and very fast. It is in serpentinous rock below our nodes of Urambi. And we have also not seen in Udada alone, in Bandhan South. Very quickly, pass to the slide. Next. And on surface also, many places we see, beautiful pillow lavas are there in the Chirudi section, Karnapani sector. And accessory waves we have seen in the Bodolpur in Moguldi and also in the Purnapani area. They are the pillow asars, calcosis. So they are in the footwall side of our footwall loan. Next. And when we have drilled in Surda area, away from the mining lease area of the HCL, after our ore loads, immediately below the pay horizon of the biotite persist, we are getting this serpentinized talcose pistol rocks. And they are also having mineralized. This is the type of, I will not go into more discussion. And this we have not seen in one borrow, we have seen in all the borrow. Next. And they are also mineralized. like we are getting magnetite, bromide, cobaltite, nickeline, pyrite, molybdenite, magnetite, uraninite is also there. And beautiful, there are different types of hornblende, fargasite, serpentine talc are very common. Next. So now what has happened? Along this subduction, concomitant serpentinization of this mafic ultramafic rock has happened. And next. Please. I will go only 2-3 slides. Here what is happening? Because of the serpentinization, this the iron content within the olivine and pyroxene, it is getting, hydrolysis is happening, and this oxidation of iron plus 2 ferrous iron is giving us magnetite, nickel ferrous alloy, lucite, silicates like isotyl, lysadite, antimonite, these are all serpentine group of minerals, talc, fluoride, released silica, released alumina, you released nematolatic, topaz, everything, and we are also getting presence of emerald. And this system is highly exothermic. Highly exothermic in the sense from 200 centigrade it gives 600 centigrade temperature. Highly reducing because this hydrogen gas is released and it is molecular gas, it escapes. Otherwise, had it not escaped, now we would have got white hydrogen in our system. Means hydrogen could have been also there. And the system is highly alkaline because of the presence of these free radicals of hydroxyl ion. And this boron, halogens, H2, CH4 gas has been. Very typical thing within the serpentinized peridotite, we are getting carbonaceous matter or graphite. How can you explain that? So these are the serpentinization process which is giving rise to so much of hydroxyl ion and the system becoming high temperature, highly reducing, highly alkaline. So that's what it does. Shear zone is occurring from process, it is dragging everything to the top, and whatever gases are released or ligands along with the hydrothermal solution, it is taking its pathway along the shear zone, and whatever country that it comes in contact, it is scavenging that uranium, thorium, molybdenum, whatever is there, and it is getting concentrated at the lower depth. That's what we see now today. So these are the fluid mobile elements which get mobilized during the system. I some other time will explain. Please explain. Next, please. In our system, why we are getting so much of pyrophyllite? Why so much of kyanite, prometite? That explains everything. Because in the next slide, please. In highly alkaline, next slide. In the highly alkaline system, just previous. No, not this one. This okay. I will explain the presence of apparent magnetite. Where from this phosphorus has come? Due to serpentinization process, it is the largest geochemical mobilizer after the primary differentiation of the earth. Serpentinization in the petrogeologic time is the largest geochemical recycler of elements after primary differentiation of the earth. And at the high alkaline conditions above more than 9 pH condition, if whatever phosphorus is present, it is in the form of trivalent phosphorus or high phosphite ion, not phosphate what you see in the oxidizing body. Next, that explains, and at high alkaline conditions, this quartz gets dissolved, we all know, and it is coming out of the system and we are getting released silica. Most of the places we get released silica quartz bands, and along with the quartz bands, we also get sulfides. And alumina also is unstable at high alkaline temperature, and it is mobilized in the form of aluminum hydroxyl ion, negative anion. And depending upon the P condition, if the P condition is very high, it is giving rise to kyanite. If boron is present in the system, it is giving metallite. If it is moderate pressure, it is giving pyrophyllite. So that is what we are seeing in different boron depths. And how that explains why platinum is present, why precious metals like gold and silver are present, and why this uranium, thorium, and Re and sulfide, they are mobilized together because the system contains boron and halogen. So that is the reason. Next. And this is the explanation that Sushavan was trying to give. It is a plot between the physicality of sulfur and oxygen. So how this different stability fields, how it can occur. So this is another model which explains the association of this in low oxidizing condition, presence of this pyrrhotite, chalcopyrite, and petalite. As you go towards the high oxidation condition, the same sulfur, same physicality of sulfur, the mineralogy is different. So different pathways is followed anyway. Next. Next, just skip it. So finally, it is
Finally, last. So finally, for this reason, we are concentrating along this. But the geophysics say that along this margin also, this sort of high gravity body is also present in this concept. So this could be only in the below convened, but also we can expect in this southeastern part of the Singum Shear Zone, we are getting the presence of this same type of mineralization. Along this, we are getting this could be the future tiger. Thank you.
Presentation which will surely improve our understanding on the metallogeny along SSR. Now I humbly request Session Chair P.K. Sharma sir to present a memento to S.K. Das sir. The next talk is by Sri B. Vishwajit Panigrai sir, in charge SSR West investigation, and the topic will be ore body geometry of uranium ore deposits of SSR, time to reclassify in the light of AMCR 2016.
Namaskar. Respected Chairman, reporter sir, dignitaries, this event, dear friends. So far we have listened to two great soul-touching genetic concepts in Singhbhum Shear Zone. So there will be a change in gear from ore body genesis to, we will switch over to ore body geometry. Here I won't discuss about genesis. Even a very little bit of geology I will talk about, but more focus will be on the geometry of the ore bodies observed in different sectors. Sorry. So this is the generalized regional picture of Singhbhum Shear Zone, geological picture, in which we see different operational mines. There are 6 underground and 1 open cast, and there are major deposits. Now this is the scene, Google image scene, in which different deposits are shown. As our directors have presented in the morning session, is Bagla Saimachwa, the largest deposit so far. And we are hopeful that this cluster may emerge into one of the giant uranium deposits, though of course of low grade. That much we have the confidence here. And I will be discussing some of these deposits, ore reserve estimation, re-estimation rather. We have done some processes that we will be discussing, and we will see the ore body geometry in some of these deposits, then we will discuss. Now this is the Singhbhum Shear Zone, evolution of the Singhbhum Shear Zone. As you can see, this is Singhbhum craton, and this is North Singhbhum fold belt. At the interface, there is Singhbhum Shear Zone. This Singhbhum Shear Zone is a result of interaction of at least 300 million years of protracted progressive ductile deformation. This is SSZ. And this, because of this progressive shearing and the protracted period of shearing over a very, very long period, these cystosity, even bedding, cystosity, and all the structural features, they are transposed and got aligned along one plane, that is myelonitic plane. So in mineralization, as far as mineralization is concerned, so we see mineralization focused along certain planes in this shear zone, which is 500 meters to 2 kilometers of plan width. And we have seen a range of fold structures, and everything gets aligned along these shear planes, along which our mineralization also occurs. Now coming to first deposit, that is Banadungri Singdudungri, it lies west of Norwapar deposit. It's a deposit over 10,000 tons, say, of low grade. And there are 5 loads, and major load is contributed by Hangwal load to band 1. This fellow. one. Here we have done resource re-estimation. We'll see some of its sections. Just see the geometry of the ore body, sir. Consistent, almost tabular to semi-tabular, flat. Hardly any deformation it has undergone. Now this is the metal accumulation contour. You see how the grade varies over this deposit. Most of the deposits, they have long, short strike length and a larger deep extension, as you seen here. And this is a distribution of thickness, and this is grade into thickness. You can see a clear-cut tabular sort of feature going like this. This is the trend of enrichment. If we neglect the nugget factor, this will become almost uniform. Now, this is the three-dimensional configuration of this Banadungri-Singri-Dungri deposit. We can see this is hangwall load to band 1, 92% contribution. And see how the bore body is flat. This indicates tabular to semi-tabular nature of the ore body. Now, coming to resource re-estimation, what we have done in the first exercise, we have considered all the section lines, all the transverse section lines. There were 8 sections and 81 boreholes, and we considered the reserve as R1. Now, in the second exercise, what we did, we skipped one transverse section line, took the another one, then missed the third one, then took the fourth one. So in this process, we considered 4 sections, and there were 41 boreholes. Reserve we took as R2. Then in the third exercise, we skipped the transverse section lines taken earlier, and we considered the remaining. So there were 40 boreholes, 4 sections, and reserve was R3. Now let us compare the different exercise resources. In the first exercise, what we have got the figure say about 10,000 tons. In the second, we got just a variation of 1.5%. And in the third exercise, we got a variation of near about 7%. So this indicates there is not much variation in the resource, even though we skip this, even though we increase the grid spacing. Now coming to second deposit, this is the second largest deposit of India, Baglasai Machua. Now here, there are 2 loads. Hangwall load is over 2.5 kilometer and footwall load over 1.4 kilometer. This is hangwall load, which is continuous and consistent. This is open towards west also. Here, this is Bhatin deeper block we are dealing now. This is footwall load. Now let us see what is happening to the ore body morphology. There are 2 loads, very regular, consistent, going parallel to each other. Except along this faulted section, there is hardly any disturbance in the term of folding or something like that. So it is absolutely semi-tabular to tabular in nature. Now see the vertical longitudinal section. There are certain projections involved in it. That's why it looks curved. Otherwise, this side it is flat. So this indicates flat nature of the ore body. Now coming to the 3D model. Slow. You can clearly see 2 loads. Highly flattened ore body. And both are very much parallel to each other. So again, I emphasize the term tabular and to semi-tabular in this regard. So that is the nature of Baglasai Machua Jaduguda North ore body. Now coming to resource exercise. Now initially we have considered all the boreholes, 82 numbers, and there are 14 sections. We took the resource reserve as R1. Then as done in the previous block, the same method we adopted. Second exercise, we took the spacing 400 meter and along the deep 200 meter. Only strike variation was there in terms of spacing. Borehole 41 and section 7, reserve is R2. And in the third exercise, we took alternate section lines. Strike spacing is same, but section lines are different. So reserve is R3. Now coming to the comparison of footwall. If we consider the footwall load in the first exercise, if it is 10,000 tons, in the second exercise, just 6.7% variation. and here nearly 6% or so variation. However, in the hangwall lode, if we see, there is a variation goes up to 19%. That is again within the confidence limit, less than 20%. So summary is that there is not significant variation even though we increase the strike spacing in certain sectors of Singhbhum Shear Zone. Now coming to another block, Garadi block, we will see the just geometry. Sir. This Garadi is located west of Banadungri, Singhbhum here. Now you can see the section line, absolutely tabular and flat. Now see the longitudinal section is as flat as a table. Here the grade and thickness variation is not much, so very consistent ore body, though it is very thin. Now GT, grade and tonnage accumulation contour, if we see almost similar pattern going like this. The body is opening in the down deep direction in the northeast. Now Rajda block, it is east of Norwapa deposit. In Rajda main block, we will see how the ore body behaves. The loads are very parallel to each other. There are 3 loads, some are 2, some are 3, but all are tabular in nature. Now this is a metal accumulation contour of Rajda block. We can see if we remove this nugget, so entire thing is very much uniform, consistent, and going in the down deep direction. Body is open in the down deep direction. Now coming to Pathargoda Surda area, which is close to SCL's copper mine. Now in Surda, if we see the ore body, this blue is 01 cutoff, 100 ppm cutoff, and red is 200 ppm cutoff. So if we see 01 cutoff, the tabularity is well maintained, and in O2 band gets splitted, but still that tabularity and subtabularity is maintained. Now this is the longitudinal section. There are certain sections in which pinch and swell is there, but it is not so prominent. Now this is the GT contour of Surda block. The body opens in the northeasterly direction. Now in the Konyaluka block, we have the similar observation. Now if we see the sections, there is hardly any undulation in the ore body in the deep sections. Now this is the longitudinal section. There is some break which may be due to its proximity to Gohala fault. Certain dislocation might have happened, but otherwise on either side there is tabularity. We'll see how one big load of Konyaluka ore body appears. They have almost 800 meter strike length, and the body is nearly tabular in nature. The main loads in all the deposits, it has tabular to subtabular in habit. Now coming back to summary part, sir. What we have observed in one zone between this Kudada se Turamdi up to Mohuldi sector, this is the part of the Singhbhum Shear Zone, which is a highly deformed in terms of cross folding and superposed folding. Whereas while you move towards east, the tabularity of the ore body is very well maintained. Only in this Turamdi ore body, say Bandurang and Nandup ore bodies, say up to Mohuldi ore bodies, deformation is very much relevant. Now, for that, there is one explanation. This is Banerjee 1962. So, what he suggested when he mapped the area in detail south of Tatanagar, he located certain culminations and depressions. There were third generation of folding, where the force came from north, and there were west-northwest, east-southeast axis. So, we get series of culminations and depression. As a result of this, the ore bodies here in this part, they are highly crumpled. They look like this. This is what we get at Bandurang and also in Turamdi deposits. So this says that this sector is highly disturbed. So where we have been doing very close space drilling of the order of 60 meter by 60 meter. Now in this context, I want to inform the gathering and the dignitaries that We have AMCR Atomic Mineral Concession Rules 2016, under which the deposit has to be handed over in G2 stage to the mining agency or UCIL, in which if the deposit is bedded or stratiform in nature, the grid has to be 800 into 400 at G3. This is the example of Tumalpalli. And to convert to G2, it has to be done to 400 into 200 meter. Similarly, for lenticular uranium bodies or vein type bodies like Singhbhum Shear Zone, for G3, we should do at 400 into 200, but at G2, we should do at this. But the exercises what we have done, we are getting similar result at this grid. So going in this grid, it will lead to a lot of time involvement and a lot of resource, and of course, financial implications will be also high. And at this point, I want to emphasize that if we consider at this grid, our pace of exploration will be faster. And we can, if we hand over this to UCIL at this grid, in case of developmental activities, we can do some detailed drilling at certain key locations wherever they desire. However, the deposit can be handed over at grids, this grid spacing where the bodies are tabular. So in summary, the grid of 200 meter to 200 meter or this much may be considered. In suitable locations, this close spacing may be taken. Otherwise, we can go 200 into 200 or 400 into 200 for G3 resource even can be considered while handing over the resource to the mining agency UCIL. So this will lead to a decrease in our lead time, and we know more is the lead time, our social, environmental, legal, all these implications and complications arise in due course. So that is my humble submission through this presentation. Thank you. There is only single overload. Almost. That is a general trend in Karadi. Almost same, almost. Same, yeah. I have shown you that GT contour. Na? Just remove the nugget, you get a flat accumulation contour. Not much variation.
Thank you, sir. I request PK Sharma, sir, to hand over a memento to Pani Grace, sir. The next talk is by Sri Abhishek Verma, Superintending Geologist, UCIL. It is on the topic dilution control in Indian uranium mining, enhancing economic viability. I will read a brief biodata of him. He completed his Masters in Geology from Banaras Hindu University of Varanasi in 2007. Following his post-graduation, he joined India Resources Limited, an Australian-based company involved in the underground copper mining operations in India, where he gained hands-on experience in exploration, grade control, and resource estimation. In 2010, he joined UCIL, where he currently holds the position of Superintending Geologist and serves as the geology in charge of Bandurang open cast mine. With over 14 years of experience in mining geology, his expertise includes solid geological modeling, maintaining and validating geological databases, ore body delineation, grade estimation, and short-term as well as long-term mine planning. Sir, please.
Thank you, Sujit. Okay, sir. So good afternoon to all of you. Without taking time, I will start my presentation. My presentation topic is dilution control in Indian uranium mining industry, enhancing economic viability. Dilution is a very important and critical and crucial important factor which control the mining industry. If dilution is uncontrolled, then it works like a silent killer for the mining industry. Before going to the main topic, let us discuss about the UCIL. UCIL established in 1967, and UCIL started with one mine, one process plant, that is Yadugura, and main responsibility of UCIL is the uranium mining and processing. Presently, we have 7 mines and 2 processing plant in Jharkhand, and one mines and 1 processing plant in Andhra Pradesh, and several projects in the pipeline, like in Jharkhand, Andhra Pradesh, Rajasthan, Karnataka, Telangana, and Chhattisgarh. Uranium mining method in the world. Approximately 45% of production uranium comes from the in situ leaching, and 26% uranium production comes by underground mining, 20% uranium production comes by open cast mining, and 7% byproduct, and 2% by the heap leaching. In India, approximately 38% production comes from the Bandung open cast mine, and rest of the production comes from the 7 underground mines. Now comes the main topic, what is the dilution? Dilution depletion is given by a different time to different researchers and scientists time to time, but most favorable difference is that deterioration of ore grade due to the mixing of waste in ore is called dilution. Dilution generally increase the waste tonnage in ore, and it increase the processing cost and decrease the profit loss. Then dilution calculation formula is total waste milled divided by tons of ore plus waste milled into 100. Why is ore dilution important? Ore dilution directly impacts the quality and economic viability of mining operation. It reduces the recovered grade, higher processing cost just because of we process the waste material in ore. That's why we increase the processing cost. Then the operational cost. If increase the tonnage, then our wear and tear of the mine machines and plant machines also get badly hampered. And finally, impact the mine life. Generally, we have if increased dilution, then mine life will increase, and effect of that, our NPV and IRR both are get lowered, and finally impact on our business. Now, conceptual overview of dilution in mining operations. Here we have taken the 5 stages where the chances of dilution occur mostly. First stage is suppose the deposit in G1 and G2 category. After the getting deposit, then start the fix the cutoff grade and cutoff grade. When we fix the cutoff grade and cutoff grade, then some ore loss and some more diluted. Then in third stage, we design the mining method. When design mining method, suitable mining method, so that we can extract the minimum ore at the minimum dilution, maximum ore at the minimum dilution. And during this time, again dilution occur and ore loss is susceptible. In underground case, 75% ore recovered and 25% ore loss in the safety pillar. In fourth stage, we have overbreak of the hangwall and footwall contact of outer, then again occur the dilution. And fifth stage, there is a muck goes to the feed, and that time again dilution due to the backfill. जब हमारा backfilling करता है तो फिर एक बार फिर अगर से dilution होता है. Now comes to the what is the plant dilution and plant dilution. Plant dilution is also called the intentional waste inclusion. Account for the mine design, ensure the exclusive stability to full recovery of near boundaries, and generally it is the plant part, and it is safe excavation, include the hang wall and footwall material, integrated ore reserve estimate. Suppose this is the ore body, there is a zigzag portion, this is the plant dilution, and this one is the unplanned dilution. Now type of dilution mining block. Dilution is only 2 types, internal dilution and external dilution. When waste patches occur inside the ore body, it's called internal dilution. When waste patches occur outside the ore body, it's called external dilution. And overbreak of the waste material increase the waste volume in ore feed. Now the case study. Here the impact of dilution on mill feed. When we change the dilution, what affect the mill feed grade and revenue and profit? Suppose here we have taken the 5 cases. First cases we have 0% dilution. In this case, our profit will be 3,000 and our grade after dilution is H plant. But at the 10% dilution, our grade will decrease up to the 0.73%. Our profit also goes down. In fifth case, if the dilution is 25%, then our grade will be 0.65% and our profit will just become the half. That's why uncontrolled dilution is called the silent killer for the mining industry. This is the graph showing the relationship between dilution and grade after dilution. Both are inversely proportional to each other. If dilution increases, then grade after dilution will decreases. This is the financial impact of dilution. Suppose that we have done the 0% dilution, then profit loss will be the 0%, At the 10% dilution, profit loss will be 22.7%. At the 15% dilution, profit loss will be 32.61%. And 20% dilution, profit loss will be 41.7%. And 25% dilution, 25 dilution, profit loss will be the 50%. As dilution increased from 0 to 25%, profit dropped dramatically. At 25%, profit is reduced by the half. Now, where we control the dilution, there are 5 stages. First is the exploration stage, second is the ore reserve estimation stage, third one is the exploratory mining, fourth is the mine development, and fifth is the regular ore production. Dilution control during mineral exploration. First is the structural mapping. During the structural identification and accurately mark on the plan, that is geological structure like fault, fold, shear zones, that because of these all geological structures directly impact on the ore geometry. Suppose the ore geometry is more complex, the dilution chances is also very high. In filling drilling, as per UFC classification, as per UFC classification, there is a 3 axis, geologic axis and economic axis and feasibility axis. In geological axis, there are 4 categories, G1, G2, G3, 4. If deposit in G1, G2, then dilution chances is very less compared to G3 and G4, just because of our confidence is very high in G1, G2. After now come to the third point, that is detailed modeling. After the completion of the exploration, we have get the ample of data. Now time to modeling. UCIL have done the modeling in the Surpex software. We have generated the 4 type of data. That is the color table, that is the color table, survey table, geology table, assay table. Color table and assay table is a very mandatory table, but geology assay table is very important just because of the dilution, just because the point of dilution, and each and every data should be accurately entered. When we get the prepared geological database, then import in the Surpex and make this is the solid model of Bandhanur. Now change the solid model into Bandhanur. This is the solid model of the Bandhanur open cast mines. Now solid model change the block model. Here the block size, sub block size is very important in terms of the grade control. क्या होता है जब भी हम ब्लॉक साइज को डिफाइन करते हैं उसमें डिपेंड करता है जो हमारा एक्सप्लोशन करते हैं जो स्ट्राइक का कंटिन्यूटी होता है, डीप का कंटिन्यूटी होता है, जस्ट 1/4 ब्लॉक का डायमेंशन होता है. सपोज दैट वी हैव द 60 मीटर along the strike and 40 meter along the deep, then our block size will be the 15x10 and height will be dependent on which कौन सा माइनिंग कर रहे हैं, ओपन कास्ट माइनिंग कर रहे हैं या अंडरग्राउंड. इफ इन केस ऑफ ओपन कास्ट माइनिंग then our bench height, and in case of underground there is the room size. Final block size will be the for the open cast 15x10 into 6, in underground case 15x10 into 2.5, and sub block is just half the block size. But outer side, but Bandhanur ore body is outer geometry is very irregular, and in our case sub block size is the 1/4 of the block size. Now dilution control in ore reserve estimation. Ore reserve estimation. Correlation of ore reserve ensure the accurate connection between the mineralized zones, and strictly follow the cut-off grade and cut-off width, and follow the norms like NFC and AMCR. Continuity assessment, verify mineralization continuity between sample points. Now dilution control during the exploratory mining. Size of opening up ore drive is very important because it mainly depends on the ore body width as well as geotechnical parameters, and or what is our dimension of the mine fleet size. Every development phase shall be scanned by the shielded port from footwall to hang wall and right angle the foliation plane, and accordingly mark the hang wall and footwall conduct. Now the question, how to follow the trend of the ore body. The thumb rule is that first mark the hang wall and first mark the footwall contact and hang wall contact. ये footwall contact hang wall contact मार्क करने के बाद एक करता है. There is one sideline. After one sideline होने के बाद 4 या 4.5 मीटर next sideline लेते हैं. That is our development phase, and this process repeat after blast. इससे ये करने से क्या कि we cannot deviate the ore body. ore body को deviate नहीं करेंगे, ore body को पकड़ के चलेंगे, जिससे कि अगर ore body का weight बहुत चौड़ा होता है, that time dilution होने के chances बहुत ज़्यादा है. That time this follow this rule. Now here taken the 2 cases. Suppose one borehole, that is BS01. In this borehole there is a 5.6 meter 02 grade, and considering this as an internal waste. जब हम ये consider कर रहे हैं कि ये 0.2% आ रहा है, तब हमारा बोरोन में 18% डाइल्यूशन हो रहा है। लेकिन जब ये माइनिंग हम करने जा रहे हैं तब यहाँ पे यही डाइल्यूशन जो है 18% कन्वर्ट हो जा रहा है 33% में, जस्ट बिकॉज ऑफ दिस इंटरनल वेस्ट। एंड ये ओर को लेने के लिए इसको हमको लेने के ये हमारा डाइल्यूशन बढ़ जा रहा है। लेकिन इन केस 2 में क्या हो जा रहा है कि लेकिन इसको छोड़ने के पहले भी है ये और छोड़ने से पहले we have done the lot of exercise. First see the what is the strike at deep continuity of this low grade ore and main ore body का grade क्या है, higher है कि lower? अगर higher है then we have take this one. अगर higher है तो we have take this one. Now see the 18% dilution change into 5% dilution. Dilution control during mine development. Suitable mining, we have selected suitable mining meter so that we can extract the maximum at the minimum dilution. Assay plan, prepare the detailed assay plan. Appropriate equipment, good supervision during mucking, avoid the backfilling material. Dilution control by assay plan. In assay plan is very important plan prepared using channel assay and short hole data. Channel assay are carried out at 3 meter interval and short hole done the 5 to 10 meter interval. The assay plan helps the during stopping operation. जनरली हमको चैनल एनालिसिस पता चल जाता है कि इंटरनल और एक्सटर्नल डाइल्यूशन कहाँ हो रहा है इन एडवांस में, तो ताकि हम उसको डाइल्यूशन को अवॉइड कर सकते हैं। डाइल्यूशन कंट्रोल ड्यूरिंग रेगुलर ओवर प्रोडक्शन, एफिशिएंट प्रोडक्शन प्लानिंग, create clear detail plan that consider change in the ore body and area where waste might mix in. This help minimize unnecessary dilution right from the start. In disciplinary coordination, ensure the strong communication between geologist and mining engineer. Continuous exposure, keep exposure even during production. Fast exposure method help identify change in the ore body. Early show plan can be updated quickly to reduce dilution. Conclusion and future outlook. Dilution significantly impact the profitability and sustainability of uranium mining. Minimize dilution require accurate geological modeling, proper drive alignment, strict supervision throughout the mining process. Using assay plan, maintaining continuous exploration during production, help in the early detection of variation, ensuring timely corrective action. Integration of smart technology like automation, AI, better teamwork between geologists and engineers. Thank you.
Thank you, sir. Thank you for such an informative presentation on the intricacies of dilution. I request P.K. Sharma, sir, to present a memento to Abhishek, sir. Next presentation will be on virtual mode. It will be by Sri Sudhagar Chandragupta, SOF from Southern Region, Bangalore. The topic will be uranium mine and mill waste from Jadagoda uranium deposits, Singum Shear Zone, India as a secondary resource for RE and some other critical minerals.
साकर सुन पा रहे हैं? साकर Sudhakar, are you hearing? अनम्यूट करिए अपने को। सुधाकर अनम्यूट करिए।
सर आ रहा है आवाज सर?
सुधाकर सुन पा रहे हैं?
सर आपको सुन पा रहे सर?
गुड गुड गुड।
ओके ओके ओके।
Now we are able to hear you also.
Yes sir, yes sir. Sir okay, shall I start sir?
Sudhakar, please try to finish in 8 minutes.
Okay.
You
sir,
put
okay.
if one question is there from an. Okay. Right.
Okay sir. Sir, respected director sir, additional director sirs, present galaxies of scientists out there. I am Sudhakar Gupta, good afternoon, everyone. And on behalf of AMD Southern Region Bangalore, I extend a warm welcome to you all, sir. Sir, सुन पा रहे हैं ना everybody? Hello. Okay. Okay. अभी अभी आ रहा है?
नहीं आ रहा, presentation is not there.
हेलो, यहाँ से तो दे रहे हैं, सेटिंग तो है ऑलरेडी.
हम यहाँ से दिखा दें यार.
ठीक है, ठीक है सर, प्लीज.
Sir, आप are you able to see it?
Yes, sir. Yes, sir. Yes, sir. दिख रहा है, sir.
Okay. Now you start.
Okay, sir. Okay. Thank you, Chairman, sir. Once again, I bid my good afternoon to all and everybody there. So, sir, this is about uranium mine and mill wastes from Jadugoda uranium deposit, Singhbhum Shear Zone, India, as a secondary resource for RE and some other critical minerals, sir. Sir, it is written. What are the other authors along with me? Next, please. Next slide. Yes, sir. Throughout the day today, we have heard about many aspects about Singhbhum Shear Zone, and just in this session, Das sir, respected RD there at MD Jamshedpur, he detailed about the geology. Then after him, Panigrai sir, he detailed about the ore body morphology. Now, sir, I am coming to the mineralization and economical aspects of the mineralization, and moreover the future perspective. That is, till now we are dealing with the ore body which are being mined, but my theme is focused on the secondary resource for RE and other critical minerals which are there in the Jadugoda tailing pond. Sir, what happened? We, as a exploration geologist, we are doing our regular resource calculation and handing over to UCIL. But after that, is there any possibility? So my talk is on that, sir. Sir, the theme or the crux of my topic is that in Jadugoda tailing pond, a speculative resource of about 6,500 ton of LREs elements are there. In that, neodymium and praseodymium, which is the most sought after critical element nowadays for energy sector, it is present there. Hello, sir. It is present out there. Apart from this, substantial concentration of some other critical metals are also there. Like, hello, sir. Sir, सुनाई दे रहा है, sir?
हाँ, सुनाई दे रहा है. Continue.
Yes. Sir, apart from that, in tailing pond, what we identified that copper, nickel, vanadium, and chromium, barium, all are there, means having economic viability of those things. Next, please. Yes, just coming to this Singhbhum Shear Zone area, sir. This is Singhbhum Shear Zone, and next, please. And this is my study area, that is the Jadugoda tailing pond. Next, please. Sir, as it is there are 7 uranium mines of copper and uranium, and apart from that, earlier history of hepatite mines are also there, sir. From this belt, even today, copper and uranium are being taken out as a primary products from there. And apart from that, we are having history and we having information that nickel, gold, molybdenum, silver, tellurium, and other metals are being harnessed as a byproduct from Singhbhum Shear Zones. Next, please. Yes, sir. This is the area of Jadugoda and Bhatin area, sir. in this part, the eastern side, one geological map is there, which has been prepared by us during our stay there. And this Jadugola area and Bhatin area, these are dissected by Tirukocha Lord, also Tirukocha fault. And in the western part, Telling Pond is there, sir. And we all know that metamorphic type of uranium mineralization is there, and uraninite is the primary mineral in the Singhbhum Shear Zone and particularly in Jadugola, and it is occurred in dissemination, sir. Sir, these are different other minerals are also there that are of uranium, Re, yttrium, copper, molybdenum, nickel, and this is all written there. That pitchblende, allanite, millerite, melite is all nickel, molybdenum, and all other minerals, sir. Next, please. Sir, this is a general section. Means if you stand over this Singhbhum group of rock in our boreholes, about 700 meter of Singhbhum group rock we cut through, and in that, sir, about 20 meter of uranium ore bodies are there, and within O2 cutoff, some 3 or 4 band we can get there, but basically we have handed over the reserve for only this 2 loads also, only. Next, please. Sir, this is the morphology of uranium ore there. Broad warping is the major morphology, and apart from that, morphology also has been dealt by Sir Panigrai, sir. Next, please. This is the chromogram test of one borehole core, and this whatever the disseminated uraninite can be seen as a brown color patches in this photograph. Next, please. And uranium ore body is the major body for uranium mineralization, with uraninite as major mineral of low grade, and copper sulfides are common there. Next, please. Now, sir, coming to the crux of this thing, that we have done detailed geochemical mapping of different ore bodies there, and we have divided since our study there, we have divided host rock conglomerate and host rock sericite, biotite, chlorite, quartzite, and in all those ore body which are uranium rich, means more than O2, and uranium poor means less than O2. In all those things, next please. Yes, vanadium, chromium, cobalt, nickel, copper, and cerium. We found that these are above the crustal average. That is like vanadium. You can say in the left side table that in the host rock conglomerate, 71 samples of U38, which are 71 samples of ore which are less than O2, shows the higher presence of vanadium, chromium, copper, cobalt, nickel, copper, and apart from this, invariably everywhere we are getting this higher presence of this and cerium also, sir. So this propelled us to see means if we are giving we are identifying this metal with a good concentration of substantial concentration in ore body, then it be harnessed. So we took an exercise that if it can be harnessable, or what is the deposit criteria there. So we planned for sampling of uranium tailings, sir, because once this ore body being crushed and beneficiated in uranium mill at their Jadugola, then after uranium, all minerals are there stored in tailing ponds, sir. Next, please. So what till now, what we have learned that we in our regular course of exploration geology there, we identified the greater or substantial presence of other critical mineral apart from uranium. So we decided to look for whether Jadugola tailing pond, where all the leftover materials goes, these are there or not. If it is there, at what value these are there, sir. So next, please. We took the we started sampling there in for Jadugola tailing pond, sir. During our presently about 50 hectares of land is being devoted for two telling points there in Jadugoda, and we collected from those two telling points. We collected about 36 samples for their geochemical abundance of different metals or minerals. Next, please. So this table shows that anomalous presence of neodymium, prismium, that is about 200 ppm joining together, and LRE about 1000 ppm we found in our samples. And apart from this, this copper, nickel, cobalt, chromium, molybdenum, all are having anomalous presence there. So next, please. We After seeing this, we did a resource calculation in a speculative level, and we took this tailing ponds area as about lesser than 50 hectare, and we found that about in these two tailings ponds, LRE presence is more than 6,500, with the neodymium, praseodymium with 1,000, more than 1,500, and apart from this, copper, nickel, cobalt, chromium, these all are there in economical scale, sir. So next, please. So our work identifies this as a secondary resource, present Jadugoda tailing pond as the secondary resource for these critical minerals. So this volume of the ore processing residues which are there in tailing pond can be used for the further determination of economic potential, because this is an speculative identification. Sir, metallurgical process, if the deposit, the secondary resources coming to be economical, then metallurgical process for recovery of these critical minerals had to be developed, sir. And our study shows that ore processing residues from other mines and mills in India can also be assessed for multi-metal possibilities. Next, please. Sir, the requirement for such secondary resources there because of very low presence or non-presence of these metals in India, sir. Like this LRE, presently we are having beach sand, molybdenum, some molybdenum, some mineable reserves are there only in Harur of Tamil Nadu. Cobalt we are not having. Nickel we are having very little, like this thing. In light of and in view of all these things, secondary resource of Jadugoda tailing pond stands good, and such secondary resource for other mines and can be also harnessed, sir. With this, next, please. I complete my presentation, sir. Thank you, sir.
Thank you, sir. The next talk will be by...
Any questions, sir? Okay.
Thank you, sir. The next
Okay,
talk
sir.
will
Thank
be...
you.
Next talk will be by Chanda Maji ma'am on the topic characterization of host rocks and mode of... Okay, sir. The next talk will be by Swati Pant ma'am. It will be on virtual mode. It is on the topic possibility of geochemical control on uranium mineralization in Banadungri, Jadugoda sector, central part of SSR, Eastern India.
Swati, are you able to hear us?
Yeah, very good afternoon, sir. Yes, I am. I'm sharing my screen, sir. Sir, is my screen visible to you?
It is visible. You start and please try to complete in 8 minutes.
Hello. Very good afternoon to everybody. Yes, sir. Sir, am I audible?
Yes, please start.
Okay.
Are
sir.
you able to?
Very good. Very good afternoon, everybody. So today, my talk basically deals on the controls of uranium mineralization in Banadungri, Jadugoda sector, central part of the Singhbhum Shear Zone, eastern India, with a possibility to find out if there is any geochemical control or so. So let's start. As we can very well see, this is the Singhbhum Crustal Province. We have Singhbhum Craton in the south and the Singhbhum Mobile Belt in the north. And in between the two, there is this curvilinear 200-kilometer long belt of the Singhbhum Shear Zone, where we are presently working. So the study area, it lies in the central part of the Singhbhum Shear Zone, which has many uranium mines, like we have Narva Pahad mine, we have Bhatan mine, we have Jadugoda mine. So this stretch, it extends for about 11 kilometers and covers an area of about 55 square kilometers. This is the geological map of the Banadungri Jadugoda area, as you can very well see. So in the south are exposed the Singhbhum granites, which are further overlain by the metavolcanics and the metasedimentaries of the Dhanchori group. And this is further overlain by the metasedimentary rocks of the Singhbhum group. So this is the entire stratigraphy of the area. If we look into the section, we can very clearly see over here that in the south, we have the Singhbhum granites overlain by the metasedimentaries and the metavolcanics of Dhanchori group, which include, we have a basal unit of grit over here, followed by phyllites. Then we have fuchsitic quartzite, we have sheared basic rocks. So this comprises the gamut of the Dhanchori group of rocks, which is further overlain by Singhbhum group, in which the basal unit includes the chlorite quartz cyst, which has intercalations of this sheared conglomerate band. So we have about 4 bands of these conglomerates, which are the intraformational conglomerate in between the quartz chlorite cyst. This is further overlain by the unit of quartzite, followed by chlorite sericite quartz cyst, and finally the garnetiferous quartz chlorite sericite cyst. So in this entire section, the entire radioactivity, when we talk about Banadungri, Singri-Dungri till Jadugoda area, is confined within this quartz chlorite cyst unit with bands of conglomerate. So the main host rock for uranium mineralization in the area is quartz chlorite cyst. Now, before going into any kind of control, let's have a look about what is the basic mineralogy when we talk about the host rock of this uranium mineralization. So the major minerals in the area are, we have quartz, we have chlorite, we have muscovite, we have biotite. Main uranium minerals are uraninite. So when we talk about the metamorphic assemblage, we have 2 basic assemblages in this area. We have quartz, chlorite, muscovite, and plagioclase. And the second assemblage is in which quartz, chlorite, muscovite, and plagioclase is also along with biotite. So this assemblage clearly shows that the rock has been subjected to the green cyst species of metamorphism, and in the host rock there is complete absence of garnet also. Now I am continuously saying that in this entire stretch of 11 kilometers from Banadungri in the west to Jadugoda in the east, the entire mineralization is confined to this unit of sericite chlorite quartz cyst. If we look this borehole column, so is it possible that there could be a lithological control when the entire mineralization is hosted by almost a similar rock type? So that is not the case, because we very well know that if we go to the west in Toramdi area, even quartzite hosts the rock. And if we go to the east in the area, in Jublatola, even the quartz chlorite biotite cyst becomes the host of the mineralization. So lithological control, though it appears in this 11 kilometer zone, is actually not the story. So we have to remove the lithological control for uranium mineralization in this particular sector. So now let's see if there is any possibility of geochemical control or not. So before that, let's have a brief about the geochemistry of the host rock. So sir, this is the major oxide plot, which is normalized from UCIL. So we have both major oxide and the trace elements here. So here we can very clearly see that our host rock is enriched when compared with UCC. It is enriched in titanium, it is enriched in iron and magnesium. Now, when we talk about the trace elements, we have distinct enrichment where coming to cobalt. The rock is enriched in chromium, it is enriched in cobalt, nickel, copper. And all these trace elements, they have a basic affinity. But at the same time, the rock is also enriched in yttrium, it is enriched in niobium, it is enriched in cerium, thorium, and uranium as well. So the trace element data suggests that the enrichment of two distinct affinities of elements. So this clearly shows that a rock with trace elements enriched of felsic affinity must be derived from a felsic rock, which could definitely be Singhbhum granite. But then why we are getting such high concentration of chromium over here? We have analyzed about 350 ppm of chromium also. And if a rock is simply derived from the felsic source, we cannot expect a chromium as high as 350 ppm. So definitely, this is a mixed provenance where some sediments have also been derived from the basic rock of the. Now, if we talk about the RE concentration, we can very clearly see this is the RE plot for the host rocks. So we have a depleting LRE and almost a flat LRE pattern with a very strong europium anomaly. And when we compare this data with the published data of Singhbhum granite as well as bonite granite, we can see that this RE pattern is very similar to that of the Singhbhum granite phase 3. So this also confirms that Singhbhum granite phase 2 must be a major contributor, a major provenance major provenance for the sediments of Singhbhum group of rock, but that definitely some sediments have also been derived from the basic rock of Thanjoris. Now, coming to what could be the protolith for the host rock, because in my time over there, since we are getting such high concentration of chromium, copper, cobalt, nickel, there was always a debate that is it a possibility that they could be instead of meta sedimentaries, could they be a meta basic rocks? So this is Clarence and McKenzie diagram, and here very clearly we are seeing that the majority of the samples, they are falling in the sedimentary field. So the quartz chloride cyst which is the host rock for uranium mineralization in the area, must be of sedimentary origin. And this data is also supported by the published work of Majumdar et al. Also. Coming to what could be the protolith. So this is the Heron's diagram. So the majority of the samples fall in the shale. So shale must be the protolith rock of the area. Now, this was about the geochemistry of the host rock. Now coming, how to identify the geochemical control, because we already know this is an open system. The rocks have been subjected to metasomatism also, they have been subjected to hydrothermal alteration also. So what we did is, we systematically sampled radioactive rocks as well as the top and the bottom of the non-radioactive host rock of the area. And the sampling was done systematically along the dip also and along the stripe also. So this is the data. If I summarize it, no distinct variation has been identified in the major oxide data as well as in the trace element data. Just a slight enrichment of calcium, sodium, and P2O5, a very slight enrichment, and a slight enrichment of nickel, strontium, and yttrium has been identified. But this is nothing striking that we can say that there is some distinct variation in the geochemistry of the mineralized host rock and the non-mineralized host rock. Now, this is the correlation coefficient matrices. Here also we can see these are all the major oxides, that uranium does not show any strong correlation with any major oxide. Just we are having a very moderate correlation with P2O5 and calcium, which could be because of the presence of apatite, and that too is very moderate. Otherwise, we are not having any strong correlation with any of the major oxides. Now coming to the trace elements, the similar story is with trace elements also. We have analyzed so many trace elements in the area, but uranium is not showing any strong correlation with any of the trace elements we have analyzed over here, except lead. And why is it showing the correlation with lead? We all know, because this must be of the radiogenic origin. Now, the next step, what we did is, there is a Cox diagram for correlation coefficient pattern. So as per Cox and Clifford, what they have done is, if we plot the correlation coefficient patterns for all the elements, and there is some similarity between the correlation coefficient patterns of some elements in a single rock type, they could be, they have associated them to be genetically correlatable. So what we did is we made the coefficient patterns for all the trace elements we have analyzed, and we found that we got two groups. We got a group for cobalt, nickel, copper, which shows similar coefficient pattern. And then we got another group for yttrium, cerium, and barium, which also show similar coefficient pattern. But the coefficient pattern of this cobalt copper does not match with yttrium, cerium, barium, and which is, we know that geochemically it should not match also. But when we come to uranium, the correlation coefficient pattern for uranium is completely different, both from the cobalt, nickel, copper, as well as from the yttrium, cerium, barium. So this shows that, the present study shows that at least the whole rock geochemistry, it reveals that there is no significant genetically, we are not getting any trace element or any mineral with which uranium is associated with. So this shows that even the geochemical control for uranium mineralization in the area is very limited. There must be some, but again, it is very limited. It is not very prominent. So then what could be the control for uranium mineralization in the area? I'll just give you a case study from the Jadugoda North area. We all know, as Panigrahi sir has also told, that the entire ore body geometry in Singhbhum Shear Zone is like a flat body. It is a tabular body, and the dip of the ore body is parallel to the S2 foliation in the area. But we all know, we have all mapped the area, and we know that even the S2 foliation is asymmetrically folded in the area. So why these asymmetrical folds are not visible in this tabular ore body? I have my a little model which we have prepared at that time. I would like to show that. So this is the borehole location plan of the Jadugoda North area. This is the Jadugoda lode. This is mine from
Dr. Swati.
This is the Tirukocha Fault, east.
Dr. Swati.
Yes, sir.
Please.
Yes, sir.
Within 2 minutes. Yes, within 2 minutes, you finish.
2 minutes. 2 minutes, I'll finish.
10 minutes, more than 10 minutes.
I'll finish in 2 minutes, sir. So this Tirukocha fault has truncated this Jadugoda lode. This is the Jadugoda lode. So now if we see over here, just see, these are the sections of the Jadugoda lode, and the general dip of the ore body as well as the quartzite is around 55 to 60 degree. But when we move towards the western part, there is suddenly the dip of the ore body as well as the quartzite has reduced to 30 degree. So how we modeled it is, we know from the geological mapping that there are these asymmetrical folds in the area. We have measured all these folds, and we found that these non-cylindrical folds asymmetrically, they are shallow plunged of 20 degree towards 100 degree. So this is the S2 foliation which have folded. So we prepared a similar model for Tirukocha lode and just tested if it fits or not. So we have folded the Tirukocha lode into this asymmetric fold, and what we have found is, when we drilled the first series and second series of boreholes, the dip was absolutely fine of 55 degree because all the boreholes were in the limb of the ore body. But as we drilled the third series, what happened is, since the series is along 120 degree and the plunge of the ore body is 100 degrees, as we are moving towards west part, we are more towards the hinge portion, and that's why the dip of the ore body has become shallower over here. This is further supported by the borehole core data, where we got very perpendicular crenulation cleavages developed in JDN 16 for a very wide zone, which were completely absent in JDN 17, 13, 14, and 15. So this is the asymmetrical fold. What happens in small scale, the ore body as well as the rock types are asymmetrically folded. But since our borehole spacing is 200 meter by 200 meter, when later we join them, it feels like that the body is a straight line, but actually it is asymmetrically folded in the area, but the folds are very tight. So this shows that this was the finding that the ore body has definitely folded into an asymmetrical fold, plunging about 15 to 20 degrees towards north 100 degree. So finally, the conclusion that obviously the control is lithic and lithic control is definitely not there. Geochemical control very limited, and the main control of uranium mineralization in the Banadungri Jadugoda sector is the structural control. Thank you, sir.
Thank you, Dr. Swati.
Thank you, sir.
Thank you, ma'am. Thank you, ma'am. Ma'am, your memento will be sent through post. We will move to the presentation by Sri Dibaga Ghosh, SOE. He is on the general texture and mineral chemistry of allanite from central and eastern sectors of SSR. Chanda ma'am's PPT will be presented afterwards.
Very good afternoon, sir. Very good afternoon to everyone. I am now discussing about the general texture and mineral chemistry of the allanite, what we are finding in the Singhbhum Shear Zone. I am directly coming to my topic. So this is the Singhbhum Shear Zone, what we have shown here in many times, and we got our uranium mineralization in the sheared part and mostly defined by the rocks of chloride quartz schist and mostly chloride rich part. And in western part, some mineralized quartzites are also radioactive, and in eastern part, the biotite rich rocks is also radioactive. And not only uranium, we also know that several copper mines are also occurring within the shear zone. And out of these uranium and copper mines, whatever the host rock we are looking for, if we are study that, not only the uranium and copper, we can see heavy enrichment of Re elements are also present within this shear zone radioactive rock. Actually, if you can say see the LRE content of our rock is around 1000 ppm. So the total budget of this RE contribution of this rock is mostly contributed by the budget of allanite content. Heavy allanite, the content of allanite is very high in our radioactive rock. We can see in this petrography photographs that in the schistose rock, like in the phyllosilicates, in biotite, chlorite, we can see allanites as association with the radioactive phase of uraninite. Like here, you can see allanite disseminated. Here, allanite having a inclusions of magnetite and pyrite. Here, disseminated allanite with association with tourmaline, magnetite. Here, and one allanite photograph is there with an inclusion of magnetite, and several others like tourmaline, apatite. And this kind of associations are very common in our radioactive rock. So in this allanite population, if we can characterize by size, there is two population. One is very disseminated, finer one, and one is very large grains, which are having a grain size of around 500 to 600 micron. And within this larger grain size, if we can consider this, some of the larger grains we are having, we can see that wrapping of cystosity around these allanite grains. We can see that wrapping of cystosity. And some of the larger grains are also having abating cystosity. This population is very less, but still we are getting there. So from this texture, we can say that these allanites are prior or seen to some kind of tectonics in our case is a shearing in origin. And this kind of allanites where the cystosity is mostly abating, those are mostly seen to post-tectonic in origin. But if we see the finer grained one, the finer grains are mostly aligned to the cystosity. Here you can see these clusters of allanite grains. Those are mostly parallel to the cystosity. This one is larger one, which is also parallel to the cystosity. And the finer grains does not having any wrapping of cystosity over there. So most of the finer grains are seen to post-tectonic in origin. So by seeing the texture and their grain size, their population is two. One is larger grain and smaller grain. And larger grains are having pre to syntectonic in origin, and smaller grains are mostly seen to post-tectonic in origin. Now coming to the geochemical factors of this grain. If you see this grain under BSE image, we can see a clear zoning pattern within the grain. In petrography also, if you closely look, these allanites are also having, rim is having a different pleochroism scheme and core is having a different pleochroism scheme. And which is very prominent in our BSE image. All the allanites we are getting in the core, we are getting a brighter core and very darker rim. Here also is brighter core and darker rim, brighter core and darker rim. In all those areas like Bagjada, Pathargoda, and Jadugoda, this feature is very prominent. And this brightness of this BSE images itself indicate that the content of heavy elements is higher at the core and content of heavy element is very low at the rim portions, which giving the brightness of the grain. Here is some of the photographs from Jadugoda area also. Here we can also see this along the fractures, along the boundary, the shade is darker, and in the core portion, the shade is brighter. Here is also very prominent, the similar feature is present here. So now coming to the compositional variation of this individual allanite grains, we can see that there is a variation of allanite, calcium, iron, Re and silica content here. And if we consider this Re content from core to rim, the variation is very high, 6 to 25% around. And categorically, if we can characterize the core portion and the rim portion, we can see that where the Re content is high, the calcium content is very low. And where in the rim portion Re content is very low, and that portion calcium content is very high. It is very obvious that is Re leaching has been happened from the rim portion or the available naked portion where calcium enrichment has been happened. This Re plot of allanite grains with the chondrite normalized Re again. Here you can clearly see that the brighter zone having a higher LRE content in all the area like Jadugoda, Pathargoda and Bagjada, and the rim portion, the darker area, is having a lower LRE content. So if we plot this total Re value with the calcium value after calculating their APFU by considering oxygen 11 and calculating our alkali and M site and other cations, we can see very well negative correlation with the Re total content with the calcium. This is very prominent feature and also well known feature that Re has been replaced by calcium. But there the catch is the charge of Re is 3+ and charge of calcium is 2+. So there might be certain other replacement scheme might happen there to maintain the charge balance. So we have plotted certain other diagrams with Re total APFU content of this allanite grain. We can see that this alumina and iron total is also having a negative correlation with the Re. That means along with the Re leaching, certain amount of alumina and iron 3+ have been also leached out from the grain. But Re is having a very positive correlation with the iron 2+ and magnesium. That means with Re, iron and magnesium also goes out from the system. So if we plot calcium, alumina 3+ and iron 3+ with Re total, iron 2+ and magnesium 2+, we can see a very strong negative correlation with this plot. So from this plot, we can interpret that there is a couple substitution scheme happen for these grains, like with Re, iron and magnesium also goes out from the grains, from the available grains or the fracture boundaries, and calcium and alumina came into the system to maintain the charge balance. And in this plot, the Re total versus alumina plot, if we plot all the grains, all the data we have, so we can see that the core areas, the grains are, the plots are mostly falling in the zones of allanite. But in the rim portion, the grains are mostly falling in the zone of epidote to clinogeosite, what is very evident from our petrography study also. In petrography also, we can identify this core allanite portion and rim is forming of epidote and clinogeosite. Other very thing is, these contours are basically depicting iron 3+ by iron total values. So we can see in the core portion, this iron 3+ by iron total value ratio is around 0.3 to 0.5. But at the rim portion, these values ranges from 0.9 to 0.6. That's very well depicts that our rim portion of the allanite grains are very oxidized in nature. And that might be possible that a oxidizing fluid is responsible for this Re leaching from the allanite grains. So from all these observations and these very well prominent features in our Singum Shear Zone, we can say that this abundant allanite and high Re content in our metapelites is very well says that significant Re enrichment during the pre to Pleistocene tectonic shearing events of hydrothermal event in Singum Shear Zone. Their textural and chemical features like pleochroism, their core to rim differentiation, their BSE contrast also depicting the multiple hydrothermal overprints. Their compositional variation within grains depicting this coupled substitution like Re, iron and magnesium goes out and calcium, aluminum, iron comes in. And evidence of Re leaching and reprecipitation indicate that multiple fluid flow event after the initial mineralization. And these all observations are very consistent with the polymetallic mineralization process of SSZ, which involves a repeated hydrothermal fluid activity. Thank you, sir.
Thank you, sir. I request P.K. Sharma, sir, to present the memento. Now I welcome Chanda ma'am for the presentation.
Good afternoon, sirs. Sir, I will be presenting characterization of host rock and mode of occurrences of uranium, RE and sulfide mineralization in different sectors of Singhbhum Shear Zone, a petromineralogical perspective. Next. So I will be covering that host rock and grade of metamorphism, how it is varying from west to east in our exploration area. Then feldspathic schist is a host rock and how it differs from the sheared granite, a petromineralogical understanding. Then the ultramafic unit, which is occurring at the contact between Singhbhum and Dhanjari group of rock, and how its behavior. Then mode of occurrences of uraninite in Singhbhum Shear Zone, then the RE mineralization in Singhbhum Shear Zone, an association of uraninite with oxide and sulfide phases. I'll be talking about these things. So if we will see the geological map of this area, if we will consider our exploration areas in the western part, at the central part, and in the eastern sector, I'll be talking about 3 areas. Yes, so if you will see that this is the western sector where the host rock is sericite chloride quartz schist and quartz-feldspathic schist. These both 2 are host rock. And if you will go to the next part, it will continue here. If you will come to this Rajda area, then also it's a sericite chloride quartz schist as a host rock, and quartz-feldspathic schist also appear along with that. If you will come to the Baglasai, Mechua and Jadugoda area, then our host rock become a metaconglomerate, where these are the cluster of conglomerate and surrounded by the matrix. This matrix is mainly, it's a chloride biotite quartz schist, which is main host and containing uranium mineralization. These are the uraninite within these chloritic and biotite matrix. If you will see, this is the chloride, sericite chloride quartz schist in Kumari area, where the mineralization is mostly confined into that chloritized zone. Then there will be a uraninite, apatite, magnetite, allanite. These are the uranium, these are the associated minerals will also be present. Next, please. So if you will see in the previous that chlorite and biotite into that system, when we will come to the further eastern of this exploration area, once we will come from west to the central part, in the Jadugoda sector, biotite will be appearing in the host rock. So from the chloride zone, we will gradually appearing into the chlorite, biotite, quartz schist. And if you will come to the eastern sector, particularly in Pathorgoda, Bagjata, Kanyaluka, Bhalki, and Khadandugri, Khejudari area, that biotite will come into the system. Then our host rock become chlorite, biotite, quartz schist. In case of Bagjata also, in case of Kanyaluka, that biotite dominance will be more. Once we will come to the further south of the Kanyaluka area, that known as Bhalki area, then the garnet will appear into the system in a host rock. And if we will go to the Khejudari and Khadandungri, then there will be a staurolite and kyanite into the biotite quartz schist. So if we will see the grade of metamorphism in the host rock, then there will be a gradual change from the west into the chloride, then biotite, and then staurolite, kyanite. Like that, we are getting into our host rock. Next, please. And then another host rock is a quartzo-feldspathic schist, which is also mineralized in our western sector. So that one is always there is a confusion between the feldspathic schist and the granite. At what point in term of exploration we will call it a sheared granite, and when we will call it a feldspathic schist? There is a matter of debate. So I have tried to find out that what are the difference between feldspathic schist and sheared granite. If you will see here, if you will next. If you will see, this is the sheared granite part. This is the feldspathic part. So in this feldspathic schist, when the chlorite and biotite will be appear, then it's become feldspathic schist. In case these are all these feldspathic schist core, where alternate layers, when the chlorite biotite will appear into the system, there will be the prominent alternate bands of quartzo-feldspathic layer and chloride biotite layer. That will appear as a prominent band, and that will be known as feldspathic schist in our exploration term. When there will be a less chloride or biotite, then we are calling it a shear granite. In case of shear granite, there will be a lens which are very prominent. If you will see the petromineralogical study into the feldspathic schist, there will be these are the quartz-feldspathic layer, these are the sericite layer. Within this sericite layer, chlorite will be also there. But these sericite layers are very straight, and these are the quartzo-feldspathic layer. If you will see here, these are the, so because of that alternate layers, they are very prominent. In case of shear granite, that shear lenses are there, and the coarsening of the grain, if you will see at places relict, that magmatic texture, that is igneous texture, will be written at places. So these will be the photomicrograph of shear granite, where the that sericite content will be also less, and that sericite layers will be wrapping the quartzo-feldspathic domain. So these are the basic difference between shear granite and feldspathic schist. If we will talk about how the sericite come into the system, then there is a that feldspar. If you will see here in this part, that feldspar is getting altered to sericite, and chloride also coming into the system. When that chloritization will be very much more, then there is a appearance of mineralization. But it is not necessarily that all the chloritization part will have the mineralization. At places there will be mineralization. So next. So this is one of the variety which are also we are getting. This is also feldspathic schist, but here these feldspar grades are having numerous inclusions of surrounding fabrics. So there is a possibility to these feldspar might be the younger than these quartzo-feldspathic schist or shear granite. Next, please. So another host rock in the Singum Shear Zone, we are getting ultramafic rock. In the Kudada, already it is a serpentinized peridotite, well known, and that is hosting uranium mineralization. Apart from that, ultramafic rock we have encountered by subsurface exploration in Rajda, Surda, Purnapani, Pathargoda area at the contact between Singhbhum group of rock and the Dhanguri group of rock. If you will talk about that Purnapani area, in that host rock is a serpentine talc schist, and within that talc serpentine schist, we are getting uranium mineralization. If you will talk about, these are the from that Pathargoda and Surda area, that these are the talc serpentine schist. At places we are getting talc tremolite, actinolite schist, and amphibolite. And if you will see the ore mineral presence, then we will get chromite, then magnetite, cobaltite, nickeline, all these minerals which are mostly associated in the Kudada. Similar features we are also getting in this area. Next, please. So that mode of occurrences of uraninite in SSZ, if you will see that how the mineralization is behaving in the Singhbhum Shear Zone, there will be a schist that alternate quartz layer and phyllosilicates layer. Within the phyllosilicates layer, there will be uraninite, magnetite, apatite, tourmaline, and all they will be allied. So this is the dissemination, which is the most dominant type of uranium mineralization present in the Singhbhum Shear Zone. Apart from one type is that as an inclusion within the tourmaline or magnetite, apatite, we will get as inclusion. Apart from that, one more is along the foliation plane, there will be at apatite magnetite vein, which is also containing uraninite. So if you will see that we have done chromogram test, which is showing the leachable uranium in this core photograph. And if you will show the petromineralogical study, this is the uraninite, this is the apatite, this is the magnetite. So these are the association. Next, please. And RE bearing minerals in Singhbhum Shear Zone. Singhbhum Shear Zone is very well known for multiple RE minerals. Most abundant RE mineral is allanite. Then the other traces are xenotime, monazite, bastonesite, exenite. So recently we have seen that exenite present in the Singhbhum Shear Zone. This is the exenite. And if you will see the allanite, variety of allanite we are encountering, some of they are metamict, some of the non-metamict, some of the metamict allanite is rimmed by epidot, some of the epidot is rimmed by allanite. So when we have done the mineral chemistry of this metamict allanite and rimmed by that epidot, there is we have seen that this is the RE rich core rimmed by RE pore zone. If you will see here, epidot rimmed by allanite, when we have done the mineral chemistry, you can see here, this is the RE pore zone that indicates that this is a epidote, and when it will be rimmed by alanite. So this is again that RED zone. So these two features we are getting in the same host rock. Then the question arises that how it can be possible. So we have to think in further that how it can be possible. Next, that presence of thorite all along that chlorite sericide zone, where will be the magnetite, apatite, all along the mineralization there will be appearance of thorite. Based on the mineral chemistry, we have identified 3 types of thorite. There will be one is thorite, where will be the up to 74% of thorite present. At places we have got uranothorite, but petromineralogically, thorite and uranothorite cannot be differentiated. Only mineral chemistry can tell that they are different. Apart from that, one more variety we have encountered. Next, please. So this is one more variety is thorite, where that we can see that this is zone of PBO. PBO will be more, and if you will see in this zone, PBO will be less. So there is a lead loss in the system, which will be more elaborately discussed by Pushkala. Apart from that, we have seen the genotype. That genotype is also containing as inclusion uraninite and along the fractures. This is thorite rimmed by alanite. This is again the thorite which will be rimmed by alanite. So these are the features we are getting in the Singhbhum shear zone. Next, please. So association of uraninite with oxide sulfides in Singhbhum shear zone. As we know that our uranium mineralization is closely associated with oxides such as magnetite, ilmenite, and sulfides like pyrite, chalcopyrite, cobalt, bornite. So what we have observed that the major 2 broad aspects. One is association of uraninite with oxides. We can see that uraninite and ilmenite association. This is uraninite rimmed, enclosed within the magnetite. This is the uraninite, ilmenite occurring as a myrmecatic texture. And this is the another aspect where we can see that uraninite and sulfides, magnet and oxides get together. So what we have observed in the Singhbhum shear zone, if we will see from west to east, these variety are very common. But this association is mostly seen in the eastern sector. Next, please. Thank you, sir.
Thank you, ma'am. I request P.K. Sharma sir to present the memento. Now we are moving to the final presentation of the session by Pushkala ma'am on the topic mineral chemical characterization of thorites along SST.
Good evening to one and all. First, I'll explain the objective behind the topic. I am Pushkala, and I have attempted mineral chemical characterization of thorites. Sir, I have tried to give everybody's contribution some effect. Actually, the main aspect of Singum Shear Zone is we have all heard right from morning about the geology, about the structural aspect, about what all mineralization we are getting. So right now we are all enriched with knowledge, and all of our seniors have also given us some kind of understanding into a genetic model of tectonism which has occurred within the Singum Shear Zone. But what I find is lacking in published as well as non-published data is that we know that Singum Shear Zone is not only a structurally important zone, it is a mineral potential zone, not just in terms of a particular element, but in terms of polymetallic significance. So as we have already understood, SSZ is enriched in uranium, copper, nickel, chromium, as well as apatite, magnetite, minerals like apatite, magnetite, and all of these co-occur along with RE. So when I bring such a complex system, which also Swati ma'am had touched upon, that there are some kind of felsic affinity elements co-occurring with the mafic affinity elements. So what kind of a genetic model or an ore genetic model would we propose in order to understand the polymetallic mineralization of SSZ? So as a worker in this particular zone, it is my humble effort to touch upon or make an effort to understand a very small aspect within the shear zone, which is the thorium metallogeny. So I would like to say that the thorium metallogeny in Singum Shear Zone has been reported by AMD for the first time in published literature in 2022. And it was done by Sinha et al. In this particular map they had given, and as you can see, the map shows locations of the blue color are locations wherein we get thorium mineralization along with uranium mineralization either co-occurring or slightly above or below. Over here, my work has added few more areas wherein I have added Kumari, Chirugora, and Kendadi areas to our knowledge base that these are also the areas wherein there is occurrence of thorium. So these are the photomicrographs. One takeaway point from this is that I'm not here to teach how thorite looks, but any common geologist can understand that it looks very hazy, right? What would be the reason for the haziness? It's not how a mineral would originally crystallize. This indicates that the original crystallization signature is not maintained, which means that the thorite has undergone metamictization. Therefore, there are parts within the thorite which have undergone elemental losses or gains. This shows the different BAC images of different areas within Singhbhum Shear Zone, which also tells us about the mineral affinity. That is, it co-occurs with minerals like apatite, magnetite, sometimes with uraninite or uranothorite, especially with magnetite, and at times with ilmenite, magnetite, and xenotime. One basic thing that I would like to convey is that thorite has a general structural formula of AbO4, which is given over here. And any mineral chemical analysis would basically start with understanding or computing a mineral chemical formula, structural formula. So I have categorized the structural formula based on areas, and I have tried to understand what are the difference in elemental compositions all throughout the Singhbhum Shear Zone. In A site, we have elements like sodium, potassium, calcium, titanium, manganese, iron, yttrium, Re, lead, thorium, and uranium. Whereas in the B site, we have elements like alumina, silicon, and phosphorus. So this is in the southeastern sector of Singhbhum Shear Zone. Talking about the mineral chemical characterization, as I told, thorite crystallizes with a structural formula of AbO4. Which other mineral crystallizes with the same general formula? There is a higher possibility that it would have a solid substitution, that is solid solution with that particular mineral. That is, there will be elemental substitution. So as we can see from this particular plot, one of the ends is Y plus Re, which indicates xenotime. The other end is zircon plus hafnium, which indicates zircon. And this end is uranium plus thorium. So with this particular general structural formula, our thorites fall within a solid solution of xenotime and thorite. That is, the fluid which crystallized the thorites had a role to play with the Re and yttrium in the system, whereas not the zircon and the hafnium. And when we talk about the substitution within the A site and the B site, it can be seen that this is from western end to the eastern end of Singhbhum Shear Zone. And you can see that when we compare the A and B sites, 1:1 ratio has to be maintained, which is maintained within the central sector, but it gets disrupted as we go from the western sector and the eastern sector. The same can also be seen in the A site and B site. As we go from areas like Gura, Kumari, and in the eastern part, we go to Kendadi, Bagjata, and Pathargora. The elements have some kind of intermingling between the Re and yttrium in comparison to those areas wherein thorite has crystallized in the central sector. chemical age has been attempted for these thorites, and we have got ages right from 1100 to near about 12 to 15 million years, which is quite low. But some kind of statistical analysis has been subjected to this particular data set, and I have come up with 3 groups, 3 clusters based on cluster analysis. So this cluster analysis tells us that this clustering is not made by me. I have subjected it to some kind of statistical analysis, and the best groupism has been found, which based on statistics tells me that the data set can be grouped into, best fit into 3 clusters, which also corresponds to our pre-existing knowledge of 3 phase of hydrothermal flux, or is any mineral we take, let that be tourmaline or uraninite, we get 3 generations. Like Chandamam had already said, we get 3 generations of uraninite, which is also published by several authors earlier. So this particular 3 age range also corresponds to our thorite. Whereas the first age range gives us the maximum age data, and the cluster center occurs around 869. A total of nearly 103 point analysis have been taken into consideration. Highest chemical ages have been found in the central as well as in the eastern sectors. In the data range which I told, that the first cluster, which gives me the highest age range, in that I have tried to see whether there is some kind of later fluid imprint, hydrothermal imprint on my thorites, or are these thorites, do these thorites have any kind of representation for earlier crystallization? So based on that, based on the plot of uranium plus thorium versus lead, it is seen that though not good, but R-square value is nearly 0.6, which indicates that the age range that we have got is more or less, or at least nearby to the crystallization age of the thorites. So the first cluster that I have found can be indicative of the crystallization age of the original thorites. Also, based on these thorite data and based on the 3 clusters, it is found that in the first cluster, which is the actual crystallization age of thorite, we have major contributions only from uranium and thorium, whereas Re, yttrium and potassium are very, phosphorus are very less. Whereas as we go to second cluster and the third cluster, that is as we go with decreasing age, we see that there is some kind of hydrothermal imprint wherein the uranium thorium remains constant, but there is an influx of Re plus Y plus potassium. And this indicates that the second and the third cluster have a hydrothermal imprint wherein the fluid was more evolved in Re, yttrium and phosphorus. So this indicates the Re influx. Also, there are some kind of textural evidences found from our petromineralogical studies as well as BAC images, which tell us that there is topotactic alteration of the second and the third cluster, which says that the Re-rich hydrothermal fluids came and they have made the thorite to undergo topotactic alteration, which is also indicative over here. The fluid evolution along the shear zone is such that this is Re plus yttrium, which shows that the eastern and the western sectors are had fluids more evolved in Re and yttrium, whereas the central sectors, which also host our major uranium deposits, have more of uranium and thorium. As you can see over here also, this is for phosphorus. This fluid evolution, I'm proposing a couple substitution over here for the fluid which would have been responsible for precipitation of thorite as well as the alteration caused within the thorite. Over here, I'm proposing a substitution in which there is this Re plus Y plus phosphorus-rich fluid came into and caused an alteration, creating an elemental substitution. This third kind of second and the third clusters are indicative of this plot is indicative of the couple substitution that I've proposed, wherein I'm proposing that a later younger generation Re, yttrium and phosphorus-rich fluid came into the system and thereby replaced the elements present within thorite. And this is the categories based on age. So the recent ages have more Re and yttrium content when compared to the older ages. Also, we know that the third generation of uraninite, more or less, the clusters around 1,000 million years, which is also corroborating with the first generation of thorite. So the fluid which evolved into the, which we say as the youngest generation of uraninite, might have had a fluid which was less thorium rich and as in more less uranium and more thorium, and which also led to the precipitation of thorite. So with age, we have precipitation of uraninite, then thorite, and also thereby later introduced by Re. Thank you. Actually, this is a group effort, so whoever was involved in data collection or sample generation, I've tried to give everyone's name in it. And I thank everyone for their contribution. Thank you so much.
Thank you, ma'am. I request Sharma sir. I also request Sharma sir to kindly present a memento to R.K. Mandal sir as a token of appreciation for his role as the rapporteur. We'll be taking a short break of 10 minutes. Tea is kept outside, and I request everyone to reassemble at 5:35.
A very good evening to everyone. I extend a very warm welcome to all of you. My name is Neelam Bhagat, and it's an honor to be hosting this fourth session of this technical program for all of you. The session chair for this session will be Shri K.L. Mundra sir, and the rapporteur will be Subhas Ram sir. I request Mundra sir and Subhas Ram sir to please come to the stage. In this session, all the presentation will be given by officers of AMD Eastern Region only, and the presentations try to focus on, try to address the knowledge gap in Singhbhum Shear Zone area. For the very first presentation, I would like to invite Shri A. Vamsi Krishnan sir to present his presentation on the topic delineation of structural fabrics for identification of potential area for uranium mineralization around Jagpokoria, Kesarpur, Dobutina tract, eastern part of South Singhbhum Shear Zone area is Singhbhum district, Melbourne and Melbourne district. Sir?
My request to all the presenters to please finish in 8 minutes so that we can finish in time.
Good evening, sir. Now I am going to discuss the highlights of our previous study area, which is located at the southeastern part of the Singum Shear Zone along Jadpukriya, Kesarpur, Dumudia tract. Mainly the Singum Shear Zone is extending over 200 kilometers from Dwarapuram in the west to up to the Behraguda in the southeast. Mainly at the central portion, Singhbhum granite is exposed, and at the southern portion, IOG group of rocks and younger granite, mainly Roma Pahadi granite, is exposed. So, if we see the Singhbhum Shear Zone, it is cross-cutted by the number of faults, mainly the Tirkocha fault, east-west fault at the Jhaduguda, and the north-south fault at Surda, and another north-south fault at Gohala, near Kanyaluka and Baghjata deposits. So in order to know the continuation of this shear trend towards southeastern side and to identify if there are any cross-cutting faults, the magnetic method of investigation has been applied. So this is the detailed geological map of the Behraguda area. The map clearly shows a north-south fault at the west of the Jadpukriya. It is identified as a deformed and silicified quartz reef, which is is also called the Kendwa fault. Now coming to the magnetic signature, we have identified the north-south high magnetic lineaments and northwest-southeast direction and northeast-southwest direction and east-northeast west-southwest at some places. So mainly at the western portion, if we observe the magnetic signature, we have identified 3 magnetic parallel polinear lineaments forming the synclinal fold pattern are clearly delineated. These synclinal fold pattern are the continuation of the sheared planes coming from the northern direction. And at the eastern portion, the magnetic signature is mainly due to the basics or meta basics intruded into the younger granite. So at the easternmost portion, we have identified the broader wavelength of anomalies, which is clearly indicating that there is a chance of fault trending from Paniposi in the north to Nodana in the south. So this fault is exactly sympathetic to the Kendwa fault. And based on the magnetic signature, we have also delineated the contact between meta sediments of Singhbhum group and younger granite. So in order to know the nature of this contact, we have done the model. So from the model, generally the high magnetic signature in the meta sediments is due to the magnetite bearing quartzites or schist. And the high magnetic signatures within the younger granite is due to the intrusion of basic rocks within the granitic terrain. And the nature of the contact between the meta sediments and the granite is faulted contact. So mainly from the magnetic signature, we have identified one north-south fault, that is Nodana fault, and a faulted contact between the meta sediments and younger granite, and one more Kendwa fault. So to know the relation between the interpreted shears at the southeastern portion and the known shear trends which are coming from the north, where the well-known uranium deposits are existed, we have prepared the combined image and analyzed. So from the combined image, the shear planes coming from the north are exactly visualized in the southeastern portion. So both shear planes are same, and in between there is no geophysical data. And if we observe in the northern block, the sheared zones are shifted towards north because of Gohala fault. Whereas in case in the southern side, the scenario is different. The sheared planes are slightly shifted towards south because of this Kendwa fault. At the northern block, the shear planes are well continuing up to Bahutia village. This is because of magnetite bearing quartzite or schist, and the high magnetic body, a 3D body trending in east-west, is due to the signature of the meta basics intruded into the granite. So beyond this, there is no geophysical data, and the high gamma counts at the eastern and western portion are mainly due to the signature of granites. So mainly at this portion, granite is exposed and there is a less chance of meta sediments, which are the main host for uranium mineralization in the Singum Shear Zone. So from the magnetic signature, we have clearly identified a synclinal fold pattern, and at the western portion, we have identified a north-south fault, which is sympathetic to the Kendwa fault. And the interpreted shear planes are attributed to the magnetite bearing quartzites. And based on the combined analysis of ground magnetic and elibone magnetic data, we have clearly identified that the movement of shear planes is towards south side because of Kendwa fault. Whether in case of Gohala and Patragoda faults, the scenario is different. The sheared planes are shifted towards north. This analysis will help for the planning of the boreholes. So based on the 2D model of the magnetic data, we have clearly interpreted that the eastern block of Kendwa fault is down thrown and the eastern block of Nodana fault is down thrown. So based on the magnetic data, we have precisely delineated the sheared planes, which are the probable chance for mineralization point of view for further exploration. Thank you, sir.
Thank you, Vamshi, for finishing in time. Since he has finished in time, any one question if They are ground.
Not, sir. Thank you, sir.
Thank you, sir. Now I would request Shri K. Mundra sir to give a memento to our presenter. Moving forward, I would like to invite Sri Parvez Alam sir on stage to deliver his presentation on soda granite in Singhbhum Shear Zone, its characteristics and evolution, insights from petrology, geochemistry, and experimental petrology.
Always stick to time limit. You
Yes,
can
sir.
skip some of the general slides.
Sir, I will try. So, very good evening to the one and all. I am Parvez Alam. I am here to present my topic on soda granite. So, I am basically here to present what AMD has done on soda granite. So, AMD has taken a significant strides in research on soda granite, as it is one of the important litho units in Singum Shear Zone, and it occurs in close vicinity of uranium mineralization. So now moving on. Globally, this term was first proposed by Lewis Firmer in 1935 for biotite, azurite, and earth-wet bearing gneiss in the then Pakistan area. So in this geological map, as you can see, with the widening of shear zone in the western direction, this body has become wider. And from here onwards, this village is Ukri. From here onwards, Arcasani granophyre. So megascopically, soda granite occurs in three forms. The dominant one of them is which displays well-developed schistosity defined by plagioclase quartz and chloride biotite rich domain. Faulted plagioclase grains are very common in this outcrop. Radioactivity is mostly recorded in chloride-rich. Next form is soda granite. It preserves igneous texture and sheared grain of plagioclase are present in it. This here is the fine grained variety of soda granite where it is almost impossible to discriminate between quartz and plagioclase. Interestingly, a chloride, magnetite, and plagioclase bearing rock within sheared soda granite has recorded high radioactivity of 0.1%, 30 centimeter value. Thirdly, it occurs in the form of Lipperley injection within pegmatite looking rock. So these are the three forms of occurrence of soda granite megascopically. Under microscope, it contains plagioclase, quartz, microcline, sericite, biotite, and opaque in descending order of their composition. Faulted plagioclase grains are seen in microscope as well. Myrmecatic texture is seen, and under microscope, chlorite and biotite and opaque seems to have a relation where opaques are present on the periphery of biotite. So biotite to opaque conversion is seen. Two distinct feldspars in the form of plagioclase and microcline are present, which defines subsolvus texture. So this is all about granitoid looking variety. Next comes feldspathically schist. Lot has been discussed by Chanda ma'am. I will only discuss that this feldspathically schist is common uranium bearing rocks in Singhbhum Shear Zone, and uraninite here occurs in the form of disseminated grains within phyllosilicate domain, and it is associated with uraninite, pyrite, and magnetite. So based on petrological studies, 4 variants of soda granite have been classified. First, one of them is extremely malonitized fine grained variant, which is where it is impossible to discriminate between quartz and plagioclase without the help of supporting geochemistry. Second variant is a coarser grained schistose variant, where microlithons are defined by quartz and plagioclase, and cleavage domains are defined by sericite, chloride, and biotite. Third variant is a granitoid variety, which shows hypidiomorphic granular texture. And the fourth variant is a monomineralic variant, which contains mostly albite. These are the 4 variants. Now moving to geochemistry, Na2O content in soda granite varies from 3 to 10 weight percentage with an average value of 6 weight percentage. Na2O is greater than K2O and CO combined. This is the summary of their geochemistry. It is worth noting here that Singhbhum granite average uranium concentration in Singhbhum granite is 7 ppm, while it is 56 ppm in soda granite. On classification diagram, it falls under granite, trondhjemite to granodiorite field. Further, it displays mostly peraluminous to metaluminous characteristics. On tectonic setting discrimination diagram, it is falling under within plate granite field. On this ferron magnesium classification diagram, S-type signature is shown, which is further supplemented by higher SiO2, chromium and nickel, and lower calcium and strontium, and abundant muscovite and biotite under microscope. I would now move to RE geochemistry. This table here lists RE concentration of feldspathic schist and soda granite separately. From here, it is evident that feldspathic schist is more enriched in RE as compared to soda granite. On this chondrite normalized RE diagram, RE pattern of Singhbhum granite, arcasonic granophyre, and soda granite, they have been plotted. So here it is observed that soda granite is more enriched as compared to Singhbhum granite, and arcasonic granophyre is further enriched as compared to soda granite. And feldspathic schist is most enriched amongst all of them. It is more enriched. So it is inferred that this feldspathic schist variant is formed through generation of late differentiates from soda granite itself. Now moving to mineral chemistry, the structural formula of plagioclase has been calculated, and its composition has been bracketed between albite and oligoclase, which rarely transits into andesine. I would now like to take your attention to experimental petrology. So AMD has done experiments at Baliganj Science College, University of Calcutta. So soda granite sample granitoid variant was taken for experimental petrology. Samples were melted in this furnace. Temperature was made to increase till it reached the predefined temperature. Molten material was taken out and it was quenched in cold water, and it was powdered and studied under microscope. So these are the temperatures at which the samples were melted: 600, 800, increasing to 1350 degrees centigrade. Different temperatures, at different temperatures it was melted, and run products were studied under microscope. At 600 degrees centigrade, it was found that plagioclase, biotite, quartz, glass, opaque and muscovite, they are present in descending order of their composition. At 800 degrees centigrade, the proportion of quartz decreases while those of glass increases. At 1000 degrees centigrade, quartz melts out completely and disappears. The proportion of glass increases while those of biotite decreases. At 1200 and 1350 degrees centigrade, the proportion of glass keeps on increasing, but those of plagioclase and biotite decreases. Similar experiments were conducted on soda granites from Moholdi area, and the results are quite similar. I would now be discussing what insights we have gained from experimental run products. So first, coming to feldspar, this is the plot of orthoclase. 600 degrees centigrade run product of orthoclase is same as starting material, but it starts to show transition from cyanidine to anorthoclase at 1000 degrees centigrade. Coming to albite, 600 degrees centigrade remains same as starting material, but at 1000 degrees centigrade, it is showing some change. So this is low albite to high albite transition. And at 1000 degrees centigrade, it is also observed that sodic feldspar albite breaks down to sodic pyroxene and quartz. And those sodic pyroxene have been characterized as azerine augite. Now coming to amphibole, 1350 degree centigrade run product, it contains both FeMg Mn amphibole and calcic amphibole. While 1000 degree centigrade run product, it contains only FeMg Mn amphibole in the form of jadeite and grunerite. And this BSE image here shows X solution lamellae between calcium and FeMg Mn amphibole at 1350 degrees centigrade. So from this data, it is suggested that calcic amphibole breaks down to cummingtonite, non-quad clinopyroxene, quartz and S2O at 1000 degrees centigrade. Now moving to biotite, on this anide, siderophyllite, easternite and phlegmopite classification diagram, biotite remains unchanged at all temperatures. while muscovite, it displays overlapping pattern to fangite. As discussed earlier, feldspathic schist is more common uranium host as compared to soda granite, and here mineral chemistry of uraninite has been attempted. Uraninite contains high uranium by thorium ratio, total Re is greater than 1 weight percentage, and yttrium is also high. On this total Re versus uranium by thorium ratio diagram, it is observed that temperature of uraninite formation varies from 350 to 450 degrees centigrade. Based on lattice strain theory and Henrian behavior, thermodynamic modeling has been attempted. This equation here describes equilibrium exchange of uranium between crystal and between plagioclase crystal and melt. This du is the partition coefficient of uranium, which is a function of Gibbs free energy associated with albite melting. When uranium substitutes for sodium, it puts strain on the crystal lattice. This is the energy associated with this phenomena. This is the Gibbs free energy associated with sodium-calcium exchange. So all these parameters have been taken into account. Young's modulus, Avogadro's number. R0 is the optimal radius of lattice site, which is a function of molar anorthite content. This is the famous Bryce equation. From here, it is observed that as the composition shifts toward albite, the radius of lattice site increases, which provides more room for accommodation of uranium in lattice. So we have arrived at this equation, which has been used to calculate partition coefficient along the different outcrops of soda granite in Singhbhum shear zone. And from here, it is observed that RT, ln du and X anorthite, it is a linear function, and it is increasing from west to east along Singhbhum shear zone. This brings us to the end of my presentation. To conclude, there are 4 variants. And the granitoid variant, it is from multiple evidences. It has been observed that granitoid variant is magmatic in origin, and it is showing S-type signature. Also, it is formed under increasing water pressure condition, which shifted the melt composition toward albite. As the water pressure increases, eutectic minima shifts toward albite, and the liquid directly crystallizes into 2 feldspar, albite and K feldspar. From experimental petrology, it has been confirmed that sodic feldspar and sodic pyroxene are present in the rock. Partition coefficient, as described earlier, can be used in principle as pathfinder to locate uranium enriched zones in Singhbhum shear zone. However, this remains a subjective reality till tangible evidences are produced. Thank you.
Thank you, sir, for briefing us about soda granite. Now I request Shri K.L. Mundra, sir, to give a memento to our presenter. Now I invite Ms. Priyam Garg ma'am on stage to deliver her presentation on the topic characterization of biotite in uranium host rock in southeastern part of Singhbhum shear zone.
Thank you, Neelam. Good evening, everybody. I'll be presenting on characterization of biotite in uranium. So I would not waste the time in telling the location, as we have heard from various speakers. My area will be southeast shear zone. In Patragoda Bagjata area, what we have observed that the contact of Chaibasa and Dhanjori group is a sheared contact along which soda granite has been intruded. And on both the side of this soda granite, development of biotite is observed. So these are the more detailed maps of both the areas. And this is soda granite. This is biotitized feldspathic schist, and this is biotite quartz schist, which we have observed in Bagjata area. And similar thing is observed in Pathargoda area, and also the biotite is developed in contact of soda granite and metabasic in this area. So my sampling locations will be biotite quartz schist, biotitized feldspathic schist, and hornblende biotite schist, that is altered metabasalt. So in petrology, when we observed these samples, we have identified 4 different modes of biotite. They named them as BT1, BT2, BT3, and BT4. When we look closer, BT1 is this biotite, which is reddish brown in color, well-developed cleavage aligned along the foliation planes, showing pleochroism, prominent pleochroism. Biotite 2 has the same properties, but it cross-cuts the BT1. Biotite 3, which is occurring in anhedral shape, greenish brown color, which lacks any cleavage and is faintly pleochroic. So based on these properties, we have differentiated them. Again, in another sample, what we have observed that this is biotite 1, which has a prominent one-set cleavage, but here the color of biotite 1 is obliterate. It becomes greenish brown from reddish brown. And also along the edges of this biotite, we have seen formation of another biotite. So this is a clear indication of overprinting of BT3 over BT1. Next, when we see other pictures also, in this one, we have seen that BT1 is forming the BT1 is developing the cystosity and BT3 is being formed between the cystosity plane formed by BT3 is formed between the cystosity plane formed by BT1, and uraninite is closely associated with BT3, along with other hydrothermal minerals like allanite, turmaline, etc. In the next samples, we have observed two different planes along which the biotite is aligned. This plane is the one in which biotite 1 is aligned and has been cross-cutted by another plane along which BT3 is present. So we can clearly demarcate two different planes along which these biotites are aligned. Moving on to the fourth type of biotite, which is from a different samples, but we have taken this into consideration because it was suspected that this has also formed with the same process as that of BT3 and BT1 and BT2. So if we see BT4, it has a similar optical properties as that of BT3, and the uraninite is associated along the cleavage planes of these schistose rock and associated with BT4. So when during chemical analysis, we have done EPMS studies and the structural formula has been attempted to calculate, and it is observed that BT1 and BT2 has similar structural formula, whereas BT3 has more magnesium in octavalent site and less iron in octavalent site as compared to BT1 and BT2. And similar thing is observed in BT4, but BT4 is having more magnesium because of the host rock, because of the difference in the host rock. Also, titanium thermometry has been conducted on these biotite, and the range of temperature is above 480 degrees Celsius for all the biotites. Next, when we plotted these biotites on the genetical, to know the genetical characteristic, the biotite 3 only falls in hydrothermal field, rest are falling in re-equilibrated field, which confirms that BT3 is definitely hydrothermal in origin, but still BT4 and BT1 and BT2 still needs to be confirmed for its origin point of view. So Linbin in 2019 has told that if Mg by Fe ratio is more than 1.5, then it will be hydrothermal. So this criteria has been satisfied by BT3 and BT4. Now the question is, what is the original origin of BT1 and BT2? They are re-equilibrated for today's time, but what were the origin of them before re-equilibration, whether they were magmatic or metamorphic? So few in 1981 told if for magmatic biotite Al2O3 should be less than 15% and TiO2 should be greater than 3%. And none of our samples showed this value. Additionally, Samadhi et al. Told that if a biotite is metasedimentary in origin, then it will fall in re-equilibrated field, and if it is meta-igneous, then it will still fall in primary biotite because titanium remains unchanged. So these two evidence suggest that BT1 and BT2 are of metamorphic origin, whereas BT3 and BT4 are of hydrothermal origin. Now, grade of metamorphism, as we know that for Singum Shear Zone is upper Greensill species, so I'm not wasting time in describing that. Now for source rock characterization, what could be the source of these biotite? So when we plotted the data in MgO, FeO, EL2O3 diagram, all the biotite fell in per-aluminous suite type setting, whereas the biotite 4, which is in metabasic, fell in calc-alkaline setting. This is because of the different rock. It is in metabasic, so it will definitely fall in calc-alkaline suite. Also, for source rock characterization, Linmin in 2019 has told if this ratio is closer to 0 for base, then the biotite will be derived from basic rock, and if it is closer to 1, it will be of felsic source. So our data is suggesting them to be between 0.55 to 0.77. That means it suggests a mixed source of origin for biotite, all the types of biotite. This is the comparison. I'm not wasting time on this. Then mode of occurrence of uranite. We have 3 modes of occurrence of uranite. One which occurs along the foliation planes of BT1 and BT2. Second which occur as inclusion within magnetite. And third which is associated with BT3 and BT4 and other hydrothermal minerals. So when we plotted these into the Frimmel diagram, all these are suggesting a high temperature hydrothermal origin, which are also confirming with the origin of biotite, hydrothermal biotite. So this suggests that this uraninite might have came with the same fluid as that of biotite 3 and biotite 4. Now, lastly, I would tell what is the role of biotite structure in precipitation of uraninite. So Idemitsu et al. In 1995 has conducted one experience on biotite. He washed the biotite with acid and created a cavity and then dipped it in uranyl hydroxide solution. And then he again washed that biotite flake and conducted a study for the concentration of uranite in that flake. And he has found that even after washing it, still the concentration of uranium in that biotite is up to 3 to 4 ppm. So he concluded that this could also only be possible if the uraninite has been introduced into the crystal structure of biotite. So he proposed this schematic diagram that how it could be possible. So biotite has an ideal structure of hexagonally linked silicon oxygen tetrahedra, where one silica can be replaced by aluminum 3+ and potassium is introduced along the interlayer side to balance the charge. If a cavity and these hexagonally linked tetrahedral chain are joined together by octahedrally coordinated cations in which Mg2+, Fe2+ can be present. So when a cavity is created and uranium 6+ came in contact with Fe2+, it reduces uranium +6 to uranium +4 and facilitate the precipitation of uranite within the biotite structure. However, there is one more site for the precipitation of uranite, that is the interlayer site, because this is the open space. But we do not get many inclusion along the cleavage plane as compared to the within the crystal structure. Why is this? Because he told that the interlayer site spacing for biotite is 1 nanometer, whereas the hydroxyl ion, uranium hydroxyl ion, has a size of 1.5 angstrom, that is 15 angstrom, that is 1.5 nanometer. So that is greater than this interlayer site. That is why we do not get much inclusion along the cleavage plane, but we get inclusion within the flake itself in biotite. But we sometimes get the inclusion of uranite along the cleavage plane of biotite. So it can only be possible if the biotite flakes were present before the formation or precipitation of uranite and pre-shearing, which has disrupted the interlayer spacing of biotite and in turn increased the spacing, and where the later hydrothermal fluids with which BT3 has came facilitated the precipitation of river two distinct Thank you, sir.
Thank you, Priyam. Enlightening us on various biotites, B3 and BT4, which you have said, which is important.
Okay, thank you, ma'am. I request sir to give a memento to a. Now I invite Shri Sujit MS sir on stage to deliver his presentation on spatial and temporal association of sulfides and uranium mineralization along Singhbhum Shear Zone.
Good evening to all. My topic will be spatial and temporal association of sulfide and uranium mineralization along SSZ and appraisal. The study area which I have chosen is Baghdata, Kanyaluka and Surda Patragora, which are located toward the eastern side of SSZ. So the most important thing is that in all these three areas, there is a close association of sulfide minerals with uranium minerals. And this association can be utilized to gain critical insights into geochemical conditions and the metallogenic processes of uranium. So the main objective of our study, unravel the spatial and temporal relationship between sulfide and uranium mineralization, and also utilize that understanding of forming process for guiding future exploration strategies. Now, the first and foremost thing is that these are photographs of core samples from all the three areas. And firstly, I would say that in all the three areas, copper content is higher in uranium host rock zones. So the different morphology includes the highest concentration of sulfides. They often occur as coarse chunks in quartz veins, and they also occur as continuous and discontinuous veins within biotite quartz schist and feldspathic schist, which are the host rock for uranium mineralization in all the three areas. And also they occur as fine disseminations. Now, coming to the petrography, the first three photographs on the top shows the close association between sulfides and uraninite. Here we can see chalcopyrite and uraninite coexisting. Here also the same thing. Here we can see pyrite and pyrrhotite along with chalcopyrite. So this close association with uraninite possibly indicate to a cogenetic relationship between these minerals. And here in these three photographs, we can see the inclusions of chalcopyrite and uraninite within each other. Here we are having uraninite inclusion, while in these photos we are having inclusions of chalcopyrite. So these observations also suggest or support a cogenetic relationship between the two. Now the other sulfides which we obtain along SSZ include molybdenite, then bornite, and all these different sulfides, they also exhibit cogenetic textural relationships with pyrite and chalcopyrite. Now coming to the chemical analysis, these three box plots are of Kanyaluka, Patragora and Baghdata area. And here we can see that in all the three areas, the copper content is higher in radioactive samples than in non-radioactive samples. This is of Kanyaluka, where it is much higher than non-radioactive samples. In Patragora, it is higher. And in Baghdata, in both thoriferous and uraniferous zone, the copper content is higher than non-radioactive zones. This also supports the spatial co-occurrence of uranium and copper in addition to macroscopic observations. Now coming to the copper-nickel plot, the pyrite points fall within the fields of 1 and 2, which indicates to its formation from a magmatic hydrothermal fluid, high temperature magmatic hydrothermal fluid. Now coming to the stable isotope and mineral chemical analysis, uraninite grains from all the three areas were subjected to mineral chemical analysis, and they were plotted on Frimel's diagram. And you can see that the clustering is happening in the magmatic region, and the temperature of this region is above 450 degrees Celsius. So the inferences are the formation temperature of uraninite is above 450 degrees Celsius, plus they are formed from a high temperature magmatic hydrothermal fluid. Now, again, Stable isotope studies were carried out from sulfide samples collected from Kanyaluka, Baghdad, and Patragora. And the data was used to find a formation temperature of sulfides. So using the pyrite chalcopyrite thermometer, and a temperature of 529 degrees was established, and this temperature also points out to a possible magmatic hydrothermal fluid. Additionally, the delta 34S values are similar to the values of sulfur derived from a mafic igneous source. Now, comparing the geochronology of uranium and copper mineralization. Now, the ages of uraninite from different areas of SSR are being shown here. Narva, Bhatin, Surda, and Rakhamine shows 1600. Jadugoda also shows 1600. Banadungri also shows 1616. Now, the age of copper mineralization. The initial copper mineralization episode along SSR happened from 2 to 1.8 GA. But the later deformation, metamorphism, and hydrothermal activity mobilized and reconcentrated copper at 1.6 GA. Now, coming to the final takeaways. So the main key words in my topic were spatial and temporal. So for the spatial part, macroscopically, we are getting higher content of copper veins and dissemination within host rocks of uranium, specifically biotite, quartz schist, and feldspathic schist in all the three areas. This observation is again supported by the elevated copper concentration in uraniferous samples from Baghdad, Kanyaluka, and Patragora. Now coming to the temporal part, the petrographic studies indicate that two modes of sulfide mineralization occurs. One in close association with uraninite, and the other is having an isolated occurrence with no apparent association. So from here, it is inferred that at least there is one phase of mineralization which is co-genetic with uranium mineralization along SSR. Now the source of the fluid, the copper nickel values indicate that mineralization is related to a magmatic hydrothermal process. Now, the mineral chemistry of uraninite indicated a formation temperature of 450 degree for uraninite from a high temperature magmatic fluid. And also the stable isotope geothermometry also gave a temperature of 529 degrees Celsius, which also point out to a similar high temperature magmatic fluid. Now, from the comparison of geochronological data, it is inferred that the copper and uranium mineralization occurred within a broadly similar time frame. Now, the final takeaway will be these observations suggest a possible phase of coir formation of copper and uranium and imply a shared stage of mineralization event during the hydrothermal activity along SSR.
Done with his presentation. If there is any doubt, we can take one question. Can thank once again Mr. Sujit.
Thank you, sir. Now I request Sri K.L. Mudra sir to give a payment to our presenter. Next presentation will be given by Sri Abhishek Kumar Yadav sir. And the topic of his presentation is Mineral Chemistry of Uranites of Singhbhum Shear Zone, Implications for Ore Genesis.
Good evening to all. The topic of my presentation is Mineral Chemistry of Uraninites of Singhbhum Shear Zone and its implication for ore genesis. This is the spatial distribution of various uranium deposits, out of which the uraninite mineral chemistry of uraninites was mainly studied from the Moldi, Kutada, and Jadugoda area located in the central part of the shear zone, and as well as Pathargor and Baghdad situated in the eastern parts of the shear zone. This is a geological map of Singhbhum Shear Zone, in which the westernmost deposit, which is Moldy deposit, consisting of host rock of mainly quartzite and SC-Quest. So this is the banded magnetite bearing quartzite of Moldy area. And further east, this is the serpentinite, which is the main host rock for Kodada area. And these are the radioactive core of serpentinite from Kodada area. And Jadugoda area consists of mainly two host rocks, which is conglomerate and biotite chloride quartz schist. As shown in this figure, the left one shows the class supported conglomerate containing magnetite and chloride rich matrix. And this one is the gritty chloride biotite schist. And both these are radioactive samples. And further east, the Pathargora consists of biotite quartz schist and felspathic schist. And this is the core photograph of felspathic schist containing intermittent patches of sericite chloride quartz schist along with apatite and magnetite rich veins along with uraninite. The easternmost is the Bagjata, which consists of mainly biotite quartz schist. And this is the core photograph of biotite quartz schist. These are some micro photographs of uraninites. Mainly uraninite we get in subhedral to anhedral form, and it occurs mainly as intergranular spaces as well as inclusions. As shown in this photograph, these are the uraninite from Bagjata area. And this one is from Moldy area, showing the intergranular uraninite mineral. And this is the in the Jadugoda area, the uranite is present in the form of inclusions. These are some BSc images of uranite, along which shows the association with other minerals as well, like magnetite, rutile, and ilmenite, as well as tourmaline. So these all shows the various associated minerals along with the uraninite. So if we look at the mineral chemistry of uraninites, so almost all the samples from all the deposits consist of around 75 to 80% of UO2, and it all shows consistently high amount of UO2. But if we look at the THO2 concentration, it varies with as a function of deposit. As we know that thorium is usually immobile under oxidizing condition, and at high temperature it gets fractionated along with the UO2. So higher concentration in the Pathargora and Bagjata deposit indicates that there is an influence of magmatic as well as metasomatic influence in the Bagjata and Pathargora area, while in Jadugoda and Kodada area shows negligible amount of THO, and it suggests that there is purely hydrothermal condition of uraninite. These are some major and trace element analysis of uraninites. If we look at the CO concentration, most of the uraninites show low CO content, but Y2O3 concentration in all the uraninites is very high. And Y2O3 concentration, yttrium concentration also behaves in the similar way like thorium concentration, as it is also immobile under oxidizing condition, and at higher temperature condition it gets fractionated along with the thorium and can replace the uranium in the crystallographic structure. And if we look at the MgO percentage, there is a high MgO enrichment in the Kodada uranite, which indicates the uranite has got altered after the crystallization. And the main, if you look at the PbO concentration, the lead concentration mainly varies with the time. So whatever lead we get in the uranite, it is basically radiogenic lead which accumulates with time. So we get a variation from 10 to 15% in all the uranite samples. So if we look at the chemical substitution and alteration in uraninites, the left one shows the THO2 and yttrium concentration, and it shows that the red color circle demarcates that Pathargora and Bagjata uranite contains high thorium and yttrium oxide concentration, and which indicates the high temperature of formation. And the most of the other uraninites contains less amount of thorium and yttrium. And the right hand figure shows the alteration in which the SiO2, iron and calcium oxide was plotted versus lead oxide, and it shows that most of the sample shows the negative relation between the lead and silica, iron and calcium. But the Kudada and Bagjata shows high scatter from this. So it is not only because of alteration. The calcium is, it is not necessary that calcium will be incorporated during alteration. It is also possible that during crystallization also the calcium can be incorporated within the uraninite. That's why we get scattered data in the Kudada samples. If we look at the orogenesis of the uraninite grains, the most of the uraninite falls in the high temperature regime. And if we look at the total RE versus uranium by thorium ratio, the uraninite is further get differentiated into magmatic and high temperature hydrothermal regime. And it shows that the Pagjata and Patargora uraninites lies in the magmatic regime, while others lies in the most of the samples lies in the high temperature hydrothermal, but few samples also lies in the magmatic regime. So this is the radioactive decay of uranium lead. Whatever lead we are getting, it is due to the radiogenic lead, and it shows that there is these are the distribution of the lead concentration in the uraninite, and it shows that there is no significant lead loss in the Kudada and Jadugoda uraninites, but Pathargora and Bagjata uraninites shows high amount of scattered due to lead loss. And in the Kudada area, we get consistent lead concentration in all the uraninite samples. And an attempt has also been made for chemical age, and two distinct age brackets has been identified for moldy Kudada and Jadugoda uraninites, and they are falling in 1200 to 1400 million years, as well as 1500 to 1700 million year age bracket. So the final conclusion is the most of the uraninite consists of high UO2, ranging from 76 to. Yes, sir. So most of the samples basically shows the high thorium concentration, indicating the magmatic to hydrothermal regime. While if we look at the Kudada, Moldy, and Jadugoda uranites, they suggest that they are formed from the hydrothermal fluids. And these are the two age brackets as I already discussed. Thank you.
Most of your data are based on EPMA results.
Yes, sir. EPMA results.
Thank you, sir. I request KL Mundra sir to give a memento to our presenter. The next presentation will be given by Ms. Shreya Mishra ma'am, and the topic of our presentation is magmatic and hydrothermal imprints in tourmaline from a deformed felsic system, a case study from Moholdi area, Singum Shear Zone.
Good evening, everyone. My topic is magmatic and hydrothermal imprints in tourmaline from a deformed felsic system. As we all know that tourmaline has widely occurred throughout the shear zones in many domains and in several rock types. Here I am mainly focusing on the felsic rocks, or mainly focusing on the felspathic schist. So my study area is Moholdi. As you all know that it is very complex terrain, and it is majorly located in the central part of the Singum Shear Zone. And in this area, we have got lot of intrusion of felspathic schist, where tourmaline occurrence is very commonly found. So there are some minerals which act as a geothermobarometer, and they record a specific pressure temperature conditions, a specific geological environment based on their structural compositional characteristics. So I have chosen tourmaline because it is showing refractory character during host rock alteration, and also during the mechanical transport, and it is very resistant to diffusion. It is formed, when it is formed, then after the formation, no chemical diffusion has been taken place of the trace elements within the tourmaline structure, and no incorporation of any elements from outside of the system after the tourmaline formation has been noticed so far. And it has negligible diffusion, as I have already mentioned. And the last is the most important, accommodate trace element of wide varying ionic radii and charge. Due to its specific crystal structure, it has ability to incorporate so many trace elements which are indicative of particular environment. But because of the technology constraint, I have not used LAICP data, so I am not talking about this trace element. Although I give all the indirect evidences of the fluid evaluation and the geological environments. So this is the outcrop photographs of this feldspathic cyst present within the Moholdi area. So I am talking about the occurrences. As you can see here, that this is feldspathic cyst, and tourmaline occur as a porphyroblast. And it is concentrated within a zone and making cluster of clusters of tourmaline. Second is, it also occurs as vein form along the shear planes, as well as I have already discussed as porphyroclasts. And also we got that tourmalinite rocks where concentration of tourmaline is so high. So we assume that in this area, this boron influx is too high in these rocks. But we won't get. This is the photomicrograph of the feldspathic cyst, which is enriched in tourmaline. As you can see here, this it looks like that tourmaline influx has been come and affect the rock. So from where this tourmaline has come, there can be many sources of this boron. But from seeing this picture, we can easily assume that there is lot of boron concentrated within the fluid, which is responsible for the tourmaline crystallization. So getting the next. If we take a close view of this tourmalinite, we can see that tourmaline is slightly zoned. If you can focusly see this rock, then you can see that some zoning pattern we can see here. And also the uraninite grain associated with this tourmaline, we can also decipher from here. So we have taken this sample, and the mineral chemical study, sorry sir, and the mineral chemical studies, this zoning pattern I have already told. You can see here the dark zones, brown zones, and the gray zones. These brown zones are high Fe content. I am telling this based on the EPMA data, and the light gray zones are high Mg content. If you see in this crystal, you can see a core which is slightly brown colored, then this light gray colored, then again brown colored, then this light gray colored. So alternation of this zoning of brown and light gray zones we can see here clearly. And also the mineral chemistry of that in the under the EPMA studies, we have also see that the tourmaline zoning has also shown in the tourmaline, which is because of the compositional variation of the tourmaline grain. And when we analyze the point analysis of this tourmaline has been done, then it is found that mainly the darker portions are showing high MgAO, Al2O3, CO, and SiO2, whereas the light gray zones are showing high FeO with low MgO content, whereas the outermost rim portions are showing high FeO with high TiO2 content. So the structural formula of the tourmaline has been calculated like this, and I am showing that key chemical indicators. Since tourmaline is a refractory phase, and based on their structural, crystallographic, and compositional aspects, this and their chemical composition, this FeMg variation and Al total content, X site occupancy has showing so many indications of the fluid evaluation and the host rock composition. As FeMg showing the oxidation state, Al total content showing that there may be aluminous phase present there, and that can be due to the fluid interaction with the metaphyletic rocks present in the nearby areas. And X site occupancy indicates that there should be alkaline condition, aluminous conditions, and what is the fluid salinity. Fluid salinity we can directly tell from the fluid inclusion studies, but here from the X site occupancy I can indirectly tell the nature of the fluid. I will be discussing in the next slide. And how the fluid is evolved, it is more evolved or undifferentiated, and based on the texture and zoning pattern we can tell about the hydrothermal crystallization and how the zonation has been formed. So next is this X site occupancy. If we see the samples, the majority of the samples are fall in this alkali group and mostly dominated by Na+, and soda content here is 1.4 to 1.86%, whereas MgO content is showing a wide range of the variation, 1.63 to 8.14, and cores are showing up to 8.14%, which is showing high Mg concentration within the core and less Mg and high FeO content within the rim portions, and high alumina content throughout. We are getting high alumina content through. This FeMg variation is showing that mostly the data fall in Skoll and Davidic series. So this from this we can decipher that the alternation of Skoll and Davidic composition is present in the zoned tourmaline from both of the data. And also CaO is slightly present within the area, which can also decipher that a minor Ca bearing fluid is also present in the area. And also TiO2 content, which is which we mainly get in the rim part of the tourmaline, is indicating of high temperature hydrothermal fluid. So now next, this ternary diagram, I have plotted the data. Then we get that mostly the data is falling in these two zones, in which one is showing that the lithium poor granitic rocks, which may be the parallelitous granites, are the source for the fluid, and another is metabolitic and metasamite rocks, which are coexisting with the aluminum saturated phase, which may be the pellitic cyst of the Chaivasha formation. From core to rim variation, we have seen the Davidic to Skoll formation, Davidic, Skoll, Davidic, and then FATI rich rim. So again, I am discussing the formation condition. If Skoll is formed, then it should be more. First, I will discuss about the Davidic formation, because in core we getting Mg rich. So here Fe and FeMg concentration is very less. FeMg ratio is less than 1, and MgO concentration is high in 8.14. So this data is total range of all the samples. This Na2O content, consistent Na content with APO 0.49 to 0.6 APFO, it gives that moderate salinity, moderate salinity hydrothermal fluid is present, and which is indicating of partially open system in this area. And then fairly Mn2 plus content is generally high in this tourmaline, which suggests that the input from the low grade metamorphic rocks from the nearby areas can be there. So and the temperature of formation is also different from these two fluids. As you can see here, the temperature of formation of Davidic core is 300 to 500, whereas this rim portion is 600 to 750 degrees Celsius. So, and next I will be discussing about the late fluids, which is mainly concentrated with the rim part. So, overgrowth of this FeO TiO2 rich rims is due to high temperature hydrothermal fluids, which may be the more evolved, fluid, which may be formed with the more evolved fluid, and this can be due to the mixing with oxidized metamorphic brines. So next, from here till now, we have seen that the tourmaline zoning is showing that there is sharp compositional zoning present in our tourmaline, and there is lack of diffusional smoothing. If our fluid is, if our tourmaline is formed from a single fluid, then there may be, there should be gradational zoning of the tourmaline. But here we have seen that chemically as well as petrologically, we have the zoning, which is showing the different chemical compositions, and both of the fluids are contrasting in nature. And next is this suggests the episodic fluid infiltration, that in particular zones we get the tourmaline rich zones. This may be because of episodic fluid infiltration, where during the tectonic pulses shear zone open and seal repeatedly, due to which each pulse come into the system and form and their rapid nucleation and growth of the tourmaline happens, and then again shear zone close, then again it opens, then clusterization of this tourmaline formed due to this episodic fluid infiltration. So that led to discrete mineral growths, and we get node diffusive homogenization that support the episodic influx and tectonically active settings due to the repeatedly open and closing of this shear zone and channelization of the fluid. So these are the conclusions, that more than one fluid is present during the tourmaline formation, and this is all happened during the active tectonically active settings, where two type of hydrothermal fluid of contrasting nature has been present in the system, and this repeated fluid pulses and metasomatic fronts play key role in mineralization and alteration, as we as I have also shown that uraninite is also associated with this tourmaline. So this tourmaline act as a geochemical barrier, and it buffers the overall system during the fluid evolution. So based on the change in the chemical condition, this uraninite is precipitated nearby to the tourmaline and cause the mineralization in this sector. So at last, I will conclude this with the shear zone act as a permeable fluid conduit, where deformation enhanced permeability facilitated multiple episodes of fluid for metasomatism and potential mineralization. Thank you, sir.
Thank you. So one query I have, did you analyze any of these tourmaline for boron content?
No, sir, because of the low concentration of, in chemistry, I have analyzed, sir, that concentrate up to 200 ppm or 1000 ppm or so. But in EPMA, I have not analyzed.
Thank you. At this juncture, I really appreciate the patience of all the guests who have joined virtually. Now we have come to the last presentation of the day. For that,
Thank you, ma'am. I will request K.L. Mundra sir to give memento to our presenter. The final presentation of this session will be given by Sri Ashish Mahanta sir, and the topic of his presentation is geochemical assessment of metasomatic alteration in uranium-bearing sericite chloride quartzes of Kumari area in Singum Shear Zone.
Good evening to all. The topic of my presentation is geochemical assessment of metasomatic alterations in uranium-bearing sericite chloride quartzes of Kumari area in Singum Shear Zone. Now, the area of my study lies within the central part of Singhbhum Shear Zone, which is in between Bandurang deposit and Moholdi block. So this is an emerging block, as mentioned by respected director sir. So an attempt has been done to understand the alteration, the type of alteration, the degree of alteration, and if any relation of the alterations with uranium mineralization. So I have taken a particular single rock type from this area, the sericite chloride quartzes, which is radioactive in nature. This is a lithoblock of one of the boreholes from where I have taken the samples, or samples have been collected. If we plot the U3 U8 percentage with depth, we can see that there are certain zones which show radioactivity. How these zones are, and if we observe them in our core studies, we can see that these zones show intense chloritization, or very intense chloride or thick chloride zones are present within these zones. These are some examples of these zones from the Kumari area in our borehole studies. Now, if we see these alterations in our petromineralogy studies, we can see that there are certain different type of chloritizations, if we can see here, where in one of these we can see that there uraninite are present along the foliation planes of these chlorides, along with sericite, surrounded by sericite and apatite in one of these photos. In another, however, there is no uraninite present, but magnetite is observed. Here, chalcopyrite is observed, and similarly, uraninite is also observed in this, in one of these samples. So we can see that there could be certain different episodes of hydrothermal fluids which have brought mineralization or have precipitated uranium. However, there are certain other episodes which has not, which were not precipitated in uranium. So this could be a certain observation. Now, for the alteration studies, I have taken two indexes, chloride carbonate pyrite index and Ishikawa alteration index, wherein the chloride carbonate pyrite index measures the intense increase in MgO and FeO associated with MgFe chloride development, and the Ishikawa alteration index majorly observes the intensity of sericite and chloride alterations. Now, based on the Grant 2001 plot, if we plot both these indexes, we can see that majority of our samples fall within the zone 1, which indicates intense chloritic alteration. And these are generally typical of proximal alterations within the fluid, near the fluid conduits. Also, the most of our samples have shown the values ranging in 65 to 95 in Ishikawa alteration index, whereas in CCP index it lies within 69 to 98. This again indicates that these rocks were highly altered, because less than 50 values generally indicate unaltered or weakly diagenetic altered rocks. So these are the cluster of the samples, and based on these observations, we can also say that some later intense chloritaization event might have occurred, which might have overprinted all the other early alteration events if they have occurred prior to that chloritaization. Again, plotting the Na2O and Ishikawa plot, we can see that all the samples are falling or are generally lying towards the sericite and chloride formation, indicating the sericitization and chloritization, and less of sodic metasomatism. And if we plot with K2O, the Ishikawa index, we can see that there have been some sort or some alterations towards sericitization. However, most of the, or dominantly, this major alteration which we have observed is mostly chloritization. Again, the ternary plot of MgO of Helberg 2003, we can see that all the samples, or the majority of the samples, are falling in the MgFe plot, which again indicates the MgFe metasomatism or chloritization. And if we see that the ratio or the difference in MgO and FeO, we can see that mostly these are Fe rich, the alterations. Now, if we see the plot of U3 and Ishikawa alteration index, we can see a slightly negative correlation. Well, generally, Ishikawa alteration index increases with K2 and MgO, which again indicates seismic alteration. However, so this negative correlation may indicate that uranium was not introduced during this potassic phase, or it may have been leached out by some other later fluids, which is possibly acidic or oxidizing in nature. So based on this, we can say that sericitization may represent a late stage overprint or a barren alteration phase, which has no or very less relation with U3O8. However, if we see the plot of U3O8 and CCP index, where the CCP increases with MgO and FeO and reflects chloritization, the positive trend generally indicates a reducing environment, favoring precipitation of U4+. These could be sites of fluid focusing, where both MgFe alteration and uranium mineralization overlapped, and also these are also associated with structural conduits, just like shear zones from where we had taken the samples. Now, one of the other things that I have noticed is that we can see clusters of different clusters forming other than the positive trend. Now, this could also indicate that there were different events of hydrothermal fluid flowing, where these were related or these were precipitating U308, but in different episodes. So certain different episodes of U308 and alteration index could be present. So based on all the findings, we can say that the chloritization is the most dominant alteration feature in say chloride quartzes in Kumari area. The CCPI versus alteration index plot of Ishikawa shows intense chloritization, lean sedimentation in the host rock. The ternary plot also shows the dominance of MgFe metasomatism over soda and potash metasomatism. The slightly negative correlation between E38 and Ishikawa alteration index again suggests that sedimentation was not the primary control on uranium enrichment in these cysts, and the positive trend between E308 and CCPI plot indicates a closer spatial and geochemical association of uranium with chloritization. Based on all this, we can support a model where reducing hydrothermal fluids deposited uranium preferentially in chloritized zones in sericite chloride quartzes of Kumari in Singhbhum Shear Zone. Thank you.
Thank you, Ashish. You presented very well and waited for till end. So really, I appreciate your patience also. If there is any question, we can take one or two. Otherwise, we will close the session.
Yeah, we can also look that way also. Yeah, that is one of. Yeah. Yes. Yes. This is one of the observations or one of the way we can think about it.
Thank you, sir. I request Shri K. L. Mundra, sir, to give a memento to our presenter. Before we conclude this session, I will request our session chair, Shri K. L. Mundra, sir, to hand over memento to Shri Subhas Ram, sir. Thank you, sir, for joining us, joining this session as a rapporteur. This session ends here and it will be followed by an open discussion and valedictory function. I hand over the stage to Ms. Shreya Mishra ma'am for the further coordination of the program.
Again, good evening to all the dignitaries present over here. So we have almost reached to concluding this session. Before that, we now move onwards to the panel discussion session or an open discussion session. So far we have already witnessed 4 interactive sessions and enlightening sessions by our honorable chief guest, special guests, and our experts of UCIL, AMD, GSI, and HCL. They have shared their valuable insights and views through keynote addresses, talks, and very valuable presentations. So now it's time to navigate the pathways by integrating the views of our esteemed honorable dignitaries and to discuss the views of all the pioneering minds present over here. So for that, I'll invite our convener, Sri S.K. Das sir, to kindly moderate this session and initiate the proceedings.
Thank you, Shreya. Good evening once again to all of you. So after 25 presentations, after the inaugural session, now we have come to the final session. That is our open discussion. What is the takeaway? The theme with which we started our thinking of this particular theme meeting. How far we have succeeded in initiating that. I would never say that we have found some conclusion. At least the theme what we wanted to discuss, whether it is communicated properly or not, we'll work on it. And for that, I'll start this session with my observation that in the very enthralling session anchored by Chanda ma'am, I could not hear the opening stanza properly, but she was telling something about poetic description of the Singum Shear Zone. And in that she was telling, we have understood the rhythm, the rhyme, the riches with time. It is a huge statement. We have understood the rhythm, the rhyme, the riches with time. As we all know, that Singum Shear Zone is a geological marvel. It is a paradise where every other day we are getting some surprises. Initially, we are drilling in the shallow part of the ore zones. We got some mineralization discontinued because of our drilling depth was, means machines were not having that capacity to drill deeper. After that, we had got huge amount of relevant data, our rethinking, and we got better facilities. We started to drill deeper and started to get better, and analytical facilities improved, everything improved. So she aptly told that I could not follow the entire stanza, but we have understood the rhythm, rhyme, riches with time. And of course, we have not completely understood. It is a dynamic process. Whatever we have told today, and whatever my all young colleagues they have presented today, it is just they're carrying out the exploration work, and this on the genetic aspect, what they have understood, their contribution they have presented. So it is an attempt from all of us from Eastern region side to convince our many other people have worked earlier, and with their whatever experience and wisdom we understood from them, from their reports, we try to move forward. And whatever understanding we have now, we never say that it is final. It's a dynamic process with more data, with more understanding. We'll keep on improving our thinkings. I would say now that have we reached the peak of exploration in Singum Shear Zone? Is the ore depleting? Or there is a chance that we may get better if you drill deeper? Only exploration can tell. No theory can tell whether you will get or not. But whatever model you are envisaging, it gives an idea, it gives the optimism that there is a possibility that we may get better if you drill deeper in certain pockets. Wherever there is no granitic intrusion, without granitic intrusion, we have the areas like Jadugoda, Bhatin, and adjacent areas. We are getting pristine mineralization. The grade is higher, thickness is better, number of loads are higher. But wherever the soda granite has intruded, lateranite is metasomatized, there the grade has little diluted. Means original mineralization got consumed, later on due to later processes of shearing and other things, because the shearing continued for a prolonged time, say from a 1.85 billion years to 1.64 billion years. At least for 200 million years, the shear zone was active. And the number of pulses that it would have brought up the solution, we cannot, whether it is 1 time, 10 times, or thinking of 3 generations of biotite, 5 generations of turmaline. Nobody can say, because what we are getting today is the overprint of everything. The final one we are getting now. And so many, after this 1.6 billion years also, so many other geological processes has also affected this particular mineralization. So for example, the Eastern Indian tectonism has affected. Then this NSMB was also collided with the Chotnagpur granite dicey complex, and that is another story which needs to be unraveled. So there are complex geological processes, but what we understand and what we get now, it gives us the optimism that if the competent authority at some stage of time, if they permit, at least we can just find out whether at a deeper level, mineralization, whether it is improving or not. Of course, our mining capacity is not there and the grade that will not support to get there, but for our understanding, so that the future people, they can have an idea that whether it is possible to continue the exploration up to that level also. And at the system I told you, there may be a number of earthquakes in this particular, because deep-seated earthquakes occur in the four regime. And if these earthquakes and volcanism have at some point of time brought up the deeper part of mineralization to relatively shallower level, we may expect the mineralization after 2 kilometers also, it may occur at 1 kilometer. Possibility I am telling from explorationist point of view, not I am analyzing any profit that financial angle I am not telling, whether we are having the capability or not I am not telling. From an explorationist point of view, genetically, can we expect mineralization to be at a deeper level? And there are a number of shear zones. It is not one, because this body has never gone as a single block during the subduction process. It has, in slices, it has gone. So the number of slices, that is why we are getting number of parallel shear zones. And as we go towards the western part, the shear zone is widening and bifurcating, trifurcating. What it is getting, I don't know. So we have to check each and everything. Then only we will know whether it is having the potential to give us a sizable deposit there or not. So these are the takeaways, what we understood from our exploration and our discussion with our young friends. Now, I want to take some comments before going to our AMD higher-ups. I would first request JP Mahakul sir if he can comment upon his observation during the entire days-long program and what he has from GSI point of view. What is his opinion? Please come, sir, for your comments.
Thank you, sir. The best thing about such programs is it throws many more questions to be answered rather than solving them. So that is how we progress as in science. And coming to Singum Shear Zone, of course, it is one of the major tectonic grain in the Eastern Indian Shield. You expect, as Das was telling, whether mineralization is only shallow. We really don't know what erosional level we are seeing. Now, the erosional level of the eastern part could be dramatically different from that of western part. We don't know. There is no studies so far done regarding the level of erosion of Singum Shear Zone, right? There are several geochemical proxy to do such analysis. I think if somebody does that, maybe we'll be able to know where exactly of the hydrothermal system we are. So that is something which needs to be taken up because AMD is continuously working on this tract. So this can be taken up to assess the level of erosion of the entire, right from the southeastern part to the place where it's placed into two parts. And of course, it goes as for our study, it eventually transect the Gangpur Basin and occupy the northern margin of the Gangpur Basin. And then again, it moves forward. It becomes, it is part of the Central Indian Tectonic Zone. So that is what, that is one aspect of it. There are several discussions which was held. I think there are major takeaways, I think, apart from the kind of genesis to understand the genetic aspect of mineralization, there are views that it is a coherent hydrothermal system where everything, uranium, nickel, cobalt, everything got precipitated from the same hydrothermal system, but then the source needs to be different. Like I'll tell you one sector that is where we did some work. You have this Roma Pahari granite in the southeastern part of Singum Shear Zone. So there are several mafic ultramafic schist which are tectonically interleaved within this granite. I mean, granite must have been emplaced along a shear zone as sheets-like bodies. Now, there has to be some work what is the source of nickel and cobalt? Whether it is the ultramafic, it has to be. I mean, in some cases, you cannot explain the cobalt and nickel through something else. It has to be ultramafic. Now, the ultramafic would have been genetically linked to the nickel and cobalt within the hydrothermal system. In a similar way, yes, some of this felsic component could be related to the enhancement of uranium. And of course, how do you explain the copper? I mean, copper, I mean, if you see, as I was discussing in the morning, no? So if you go away from away you are from the Dhanjuri basin, you don't have a rich copper mineralization, though the shear zone continues. So it is the Dhanjuri volcano sedimentary pile must have something to do with the copper mineralization. So these are aspects which are being worked out, and there are certain things regarding the splays that we discussed. I think AMD needs to work upon those things to see whether it is really unconformity related, as it has been opined in some of the papers, some of their findings, or it is related to hydrothermal system. And one more thing I just wanted to add, the silicic clastics what we have, AMD has done a good lot of work on those silicic clastics. But then again, we really don't know because they have vast expanse spanning over hundreds of square kilometers, like we discussed the Mankar Chua, where Mr. Kalyan Chakravarti has done a lot of work. And then we have the Mahagiri Gorget. You also have Thanjuri like sediment, which are undeformed and overlying the IOG. We have the Hadgard belt where the overlying silicic clastic AMD did work a lot, I think, in 80s. So these are the undeformed silicic clastic where you need to locate. I think there was a paper of Freemel some years back. I mean, you need to locate the paleoplacer by systematic study of all this silicic clastic by analyzing the paleocurrent direction and arrive at a conclusion where the thickest part of the sediment could be, and that way we can plan drilling. Yes, as Das sir told, we spend possibly the minimum in exploration, so don't expect miracles. I mean, as a government organization, most of us have our own. So unless you spend a lot of money, good lot of money in exploration, we are never going to have big deposit which may be hidden just beneath 500 meters. We don't know. Thank you, sir. Thank you.
Thank you, sir, for your comments. So as regards that, actually AMD is not having much data beyond Lota Pahar to Jarai Kerala. That part we don't have much data because of logistic reasons. We tried something in Gangpur but could not succeed. But nevertheless, up to, I can say, Chakradharpur, we have a fair amount of exploration and continuously we are trying to drill. With time, we will try to see phase-wise with a priority what can be done. And you must be knowing that AMD's Eastern region is doing at least 60 kilometers of drilling every year. It is a huge amount actually in terms of subsurface exploration that is input that is given to us. Moving on, sir, I will request now our AD R&D sir for his comments. So what do you think? Because R&D is the main theme of our what this seminar, sir.
During my session, I have already commented something, but since I have been given the chance, I'll just tell a few words. So there is a saying that if we want to search the elephant, we should go to the terrain where elephants are. So I feel we are at the right terrain and we are doing a lot of exercise. I'm especially happy to listen all my young colleagues who have joined last year and last 2-3 years, and I'm really happy that they have made a lot of effort in non-conventional ways like studies of biotite, studies of turmaline, studies of thorite, uraninite, allanite, and then they are trying to correlate many of the alteration features. They are trying to correlate the uranium mineralization. Not only these studies, we should integrate all these studies together along with whatever geophysical heliborne data and ground geophysical data are available. So those things are really now paying results. And in the olden days, we were having constant of deeper drilling and the constants of budget, as our GSI colleague has also said that we are working in the government sector. But nowadays, drilling is amply available, technology is available. We can drill up to a kilometer or even more. We have drilled up to 1300 meter also at Tilaitan. So that is not a constant nowadays, and I feel that is the because of all those things, we are getting newer and newer deposits and deeper intercepts also. The other part, which one of my colleague Biswajit has told, that the change of exploration norms, I think we can think seriously on this because the type of tabularity or tabular ore body we are getting, if we can succeed in getting these norms changed, maybe a lot of our effort will be saved for proving the deposit to getting the mining clearances. The other things which one of my colleague from remotely connected southern region, he has talked on tailings, RE and other things in tailings. So nowadays, Ministry of Mines as well as Government of India, they are all thinking from waste to wealth. So tailing is not a waste nowadays because tailing already we are having the material in almost 200 mesh size and it's available. Although we have extracted uranium, but many of the things is it was told in that talk that RE up to 1500 ppm, nickel, molybdenum, copper, and so many other elements are available. So if we can succeed in developing some flow sheet of recovering these elements, that will be a good choice. Our GSI colleagues have just now said, and earlier also in his vast presentation, he has said that there will be some new target areas, western part of Singhbhum as well as the southern part of the Cretan, the entire Cretan. So shear zone is not only available on the northern side, but there are many other branches. So maybe probably there are some problems of undertaking investigations due to some insurgencies. So whatever areas are available in Kolhans and other areas, maybe they can be taken up for finding newer deposits, as well as now HCL mining is also commencing back for copper. Earlier days we used to take up copper tailings and recover the heavies like uranium and other things. So we had a big plant of almost 40 full deck Wilflay tables. So those kind of collaboration should again start once the HCL mining is commenced. So we really conserve the whatever mineral wealth available. So these are some of my comments, and I thank the organizer and especially RDER for pressurizing me to come here. And really, I would have missed the chance had I not come to this place. And thank to Director MD for giving me the opportunity. Thank you, sir.
Thank you, sir. So actually, your presence means a lot to us, sir. Your presence made us so motivated. So, we cannot express in words. And as regards your comments regarding the nature of the ore body that we are telling, if actually, sir, in the process of giving the ore body at G2 level and handing over to UCIL, it takes a lot of time. So at least G3 level, we can assess the ore body, what is the resource, and we can inform them, and so that they can take up the parallel whatever statutory clearances they can take, and in the meantime, we can partly convert it to G2 wherever it is necessary. So that way you can think of, sir, whatever is the guideline will be given to us, we'll follow it. And before I call upon AD Operation 2 for his comments, I have a word for my junior young friends that if you understand something, you always deliver better. If you don't understand, just work, then your outcome is only target oriented. Because you are duty bound, you have to give it, whatever target is set to you, you have to give that. But you understand something, then you deliver much more than what target is given to you. So try to understand what you are doing. For that, you need the involvement. And for that involvement, it comes of your own. Nobody has to tell you that you have to be involved. Self-motivation has to come, and you have to be passionate towards your work. You are doing, continue to do good, better work. Now I will call upon our AD Operation 2, say, P.K. Sama sir, for his valuable comments.
Thank you, Das sir. First of all, I congratulate the convener of this theme meeting, the regional director of the Eastern Region, Das sir, and his team, all the in charges, field investigation in charges, laboratory in charges, and all the young officers present here for their wonderful presentations, very good quality slides, and completing their presentation within the time. However, time was less and presentations were more. It is to be squeezed up, and they have tried to follow it up as far as possible. It's really a pleasure for me and privilege for me to come here and attend this workshop. As Asaf invited and director approved it. So I really feel happy to be part of. Mundra Sahab told that really we feel very happy to come here and attend this team meeting. Regarding the presentations, I will say that all the presentations were really very good. But one thing is there, our young friends, they are really doing very good work in the field as well as in the analyzing in the laboratories and giving the many concepts. But Mundra Sahab also gave a hint. I will again say it is better while Das Sahab has very elaborately told the models we are making, and there are different way we can go further for the better or possibility of better mineralization. So I think the models should definitely be attempted. But before finalizing the attempt, we should utilize all the data, and our field geologists who are working mostly in the prospects here in drilling prospects. Besides, they are maybe taking the traverses here and there in the field areas where they are working. And they should utilize high resolution, our remote sensing data, heliborne data. They are in very detailed scales, they are available, and they know how to interpret it, how to use it, and how better we can supplement the model we are creating for identifying the new areas. And we should attempt it, I think, because that in the presentations, in field presentations, if that would have been also added, it would have been better. How the presentations were really fantastic. I will say sorry to Das Sahab. His presentation was really nice, but I could not give more than half an hour, and that we will hear in detail. And one presentation also I liked very much by the Chanda Maji in the petrology, who tried to explain the petromineralogical studies from west to east. We could not give them much time to it, but that presentation really I wanted to see in detail, because that complete description and the comparison along with the field observations, it is really very good basic geological study they have done, and she wanted to present. But due to lack of time, we could not see it in detail. But still, it was really very good presentation. And during my session, I will come. There were all the presentations were really very good, and our two officers presented virtually from the Bangalore, one Sudhakar and Swati Pant. Really, Sudhakar, that as Mundra Sahab told, tailings and these things are really valuable, and it has been discussed many times, and they are very much useful, and we have to think of it. And the Swati Pant also, the possibility of geochemical control in the central part, it was really very well. Still, she is in the touch with the studies she has done when she was here. And about this Panagiris of presentation, already Mundra Saab has told, yes, we should try to bring in that in light of the this AMCR 2016, it is the time to declassify it. And presentation by Dibakar Ghosh, Puskala, and were also very good. Now, and one presentation was from UCIL, and it was also really dilution control of the mining. That was also interesting to listen. And at last, I will not say much because it is already going to be 7:30. I again congratulate, especially to the young geologists here. Really, you are doing very good work. And there is, I think, younger team is the largest in the eastern region and the southern region. And they are doing very good work. And there need to be, they integrate the data. And what your seniors are not able to understand, try to convince them. It is like that, utilizing all the data available for the geological interpretation and the mineral exploration in different scales, because the time is of that you utilize all the data and come with the new areas and make the model, not only utilizing the remote sensing and this geophysical data, also utilize the AI and ML in your studies, which is the future we have to incorporate in our studies. Thank you very much.
Thank you very much, sir, for your motivational as well as enlightening words. We'll try to follow your suggestions, your guidelines in our future exploration program. Now the big moment, I will be listening from our director, who is the brain behind all these things. So before sir, that I just last part of the presentation is left out. So Sriya ma'am, if you can help, that's supposed to presenters over there, sir, so that felicitating them in the class, and it will be followed by your final comments, sir. Sriya, please take over.
Thank you, sir. So there are so many poster presenters which are present in the hall right now, and they have worked so hard. So it's time to just grace them with a prize or with a memento. So I would like to request our special guest and our director AMD, Shri Dheeraj Pandey sir, to please present them mementos. So I'll call their names. Kebalya Sahu, please come on the stage and take their Hirojit sir. Swayam Siddhi Mudli. Jugal Kishore Dehuri. Neelam Bhagat. Suraj sir. A.K. Maurya sir. Thank you so much, sir. Sir, it's time to listen from our director AMD. So, sir, we are very privileged to have you as our speaker, and very thank you for your talk and keynote address you have given in the starting of the program. So it's time for the to know what about the event and about our hard work of the Eastern region. So, sir, please say a few words about us.
थैंक यू श्रेया। मैं वहां बैठ के घड़ी देख रहा था, तो जो घड़ी चल रही है सुबह 9 बजे से अभी 11 घंटे होने वाले हैं। 10 घंटे 54 मिनट हो चुके हैं, तो शायद 11 घंटे में मैं खत्म करूंगा, ज्यादा नहीं बोलूंगा। तो सबसे पहले तो मैं बहुत बहुत आभार प्रकट करता हूं जो बाहर से यहाँ हमारे पार्टिसिपेंट्स आए हैं, GSI, HCL, UCIL से। उनकी जो प्रतिभागिता रही है इस थीम मीटिंग में, आप सबने देखा कि उससे कितना इसका मोल बढ़ा है, भाव बढ़ा है इस थीम मीटिंग का। तो फ्रॉम द बॉटम ऑफ माय हार्ट आई थैंक यू ऑल। और मैं ज़्यादा तकनीकी बातें नहीं करूंगा, क्योंकि आखिर में बोलने का एक फ़ायदा ये भी होता है कि सभी बातें कही जा चुकी होती हैं। तो मेरे दोनों एडिशनल डायरेक्टर्स, महाकुल साहब यहाँ पर आए, दास साहब थे, सभी ने जो एक बातें की हैं उसके आगे कुछ मैं जोड़ना नहीं चाहता हूँ। खट्टी मीठी बातें करूंगा जरूर, क्योंकि अगर क्रिटिक मुझसे लेना है किसी थीम मीटिंग का तो उसमें खट्टी बातें भी रहेंगी, मीठी बातें भी रहेंगी। तो मतलब जहाँ मुझे लगा कि मैं क्या सोच के आया था, जो मुझे नहीं देखने को मिला, नहीं सुनने को मिला, वो बातें शर्मा साहब ने लास्ट में कही। आई वुड हैव लव टू सी द यूटिलाइजेशन ऑफ AI/ML इन एक्सप्लोरेशन। ईस्टर्न रीजन एक ऐसा रीजन है, आज सुबह से हम लोग बातें कर रहे हैं, 1949 से यहाँ एक्सप्लोरेशन हो रहा है। I think maximum amount of data which has been generated in AMD is in eastern region, whether it is geochemical data, whether it is petrological, whether it is geological data, subsurface data, anything you see, any data you have, eastern region is the repository of the maximum data is in eastern region. And AI/ML में हमको क्या चाहिए? AI/ML में जो machine learning, जो teach करना machine को, उसके लिए data चाहिए। So every kind of data you have. So next time जब भी इस तरह का opportunity मिलेगा आपसे बात करने का, I would love to see the introduction of AI/ML in exploration. Maybe not a perfect example, but at least you should start somewhere. And recently आपको पता है AMD has won the first prize in that GSI hackathon. So I tell my colleagues who have done that exercise, ठीक है hackathon आपने जीत लिया, first prize जीत लिया, but how are you going to help AMD? So it is high time that now AMD starts exploring using these techniques in exploration. तो एक तो ये बातें थी जो मैं आपसे शेयर करना चाह रहा था. Then otherwise, this entire day has been a day of information sharing on various aspects of Singum Shear Zone, especially on the uranium, RE and copper mineralization. बहुत सी ऐसी बातें हुई जो मुझे भी पता नहीं थी, पहली बार मैं सुना. So it is really a good opportunity. And I'm also happy to see that besides geological and geophysical exploration in the field, a lot of R&D efforts have been made to incorporate them in our studies. But again, here I will put a word of caution. AMD being exploration-oriented organization, I keep repeating this time and again, R&D should help the exploration efforts, and it should not be the other way around, that we are using exploration to take forward R&D. That caution should always be there. Then again, one more thing that I would like to add is Kudada type जो setting है, it's a unique setting, like the first time को तुमलापल्ली में carbonate type setting मिली थी. So I would like to see more data generated on this type of deposit and factual data. Conceptual model ठीक है, we work on conceptual models, but if you have to prove something, you need facts, you need factual data. So if you can build up a data repository on this type of a unique type of environment that we are getting, and I would be very happy to see, maybe not in 1 year, 2 years, maybe after 5 years, जैसे IAEA classification में carbonate type आया for Tummalapalli, वैसे ही this IAEA classification should have a new category of this serpentinite type or whatever you call it. So that would be a huge achievement for AMD and in particular Eastern region. So try to think over that. Then regarding all the presentations, they were very focused and well presented. And actually such a forum provides one an opportunity to develop confidence in public speaking. Presentation, as you know, is an art. आप 10 स्लाइड्स को आधे घंटे के लिए प्रेजेंट कर सकते हैं, 10 मिनट के में भी प्रेजेंट कर सकते हैं, डिपेंडिंग ऑन द टाइप ऑफ द ऑडियंस and the time provided to you. So if you practice these things in such forums, obviously you have a huge opportunity when you go to a, say, कहीं बाहर विदेश में जाते हैं या कोई अच्छे फोरम में आप जाते हैं, तो उस तरह के जो इन हाउस इस तरह की जो मीटिंग्स हैं, दिस गिव यू अ गुड अपॉर्चुनिटी टू डेवलप दैट काइंड ऑफ अ पर्सनालिटी. And in the last, definitely I would like to say that I appreciate the efforts of entire team ER in organizing this theme meeting, and specifically RDER and his team for bringing out that souvenir and atlas in a very short time. I know I am aware of these efforts, and especially I would also like to thank the Planning and Management Services Group of AMD in Hyderabad, the way they have worked throughout to vet these two documents, provide suggestions to improve their quality. It has been a tremendous team effort. आप सोचिए एक टीम हैदराबाद में बैठी है, एक टीम ईस्ट इंडियन जमशेदपुर में बैठी है, without any physical contact. The documents have been exchanged, vetted, suggestions have been forwarded, they have been implemented, and again they have been approved. So this kind of the speed and the kind of efforts that have gone behind this are self-evident. So with this, again, I'll put a stop to this speech. I think 11 घंटे हो गए होंगे. So thank you once again. Thank you one and all, and Jai Hind.
Thank you so much, sir, for your words and for telling about the event and how can we make it better. So thank you very much, sir. As you have already told earlier, sir, that some discussions have, this type of discussions has changed the dimensions of geology. As you already mentioned that earlier, you have relooking to the past and how Bandurang and Turamdi areas came into the picture. So similarly, now it's time to take up it again as an assignment. Apart from our assigned assignments, this we can take as a new assignment or to integrate all the old data and how we can narrow down the areas, potential areas. As JP sir has also mentioned some areas in the southeastern part of the shear zone that there may be some splays kind of thing. So we can check there also. So if this session has not been done, we thought about that, but we cannot just narrow down that area. So this kind of practice we surely do from onwards. So now it's time to conclude this session, and I take this immense pleasure to present the vote of thanks. So I thank you all for joining this session, and today, we have a very thought-provoking and very interesting day in which all presenters has presented their views and under your guidance, sir, under experts of different organizations, they have come with us, and we interact through the lunch break also, through the high tea time, and throughout the day, we have been interacting through the sessions, and maybe there are so many things which are left out. So let us take this event as a beginning, not as a concluded session. So discussion starts from here. So in the finally, I would like to thank our chief guest, Sri Santosh Kumar Satpathy sir, for their presence. He take time from his busy schedule and make us to this event, and also our special guest Sri Dheeraj Pandey sir, additional director OP1. He has joined through virtual mode. Thank you for your presence, sir, and also additional director OP2 PK Sharma sir for their valuable comments and for their talk also, and our AD R&D Sri KL Mundra sir for their valuable comments and valuable questions and suggestions during the sessions and also during this open discussion and panel session also. I extend my gratitude towards the experts of UCIL, GSI, and HCL, which take their valuable time to come to this event, and their presence has means a lot to us. They have also presented their work, and this work has helped us a lot. So, sir, we expect future discussions on this type of future discussions also, and we are coming up with new thoughts, and we also expect it from you, sir. And we are continuously be in touch so that our exploration go hand in hand with our geological aspects also. So now we can say that let us move forward with enthusiasm and passion to drive the future of uranium exploration, unlocking new frontiers through the power of geological insights and innovation. So at last, but not the least, we have been fortunate enough to learn from you, sir. We thank you for accepting our request and for your presence and deliberation that made this theme-based meeting exemplary. And heartfelt thanks to our all the officers which are joined through virtual mode also. They have taken their valuable time, and they are stay connected with us till now. As director sir had already told that 11 till 11, from 11 hours this meeting has been going on, and they are stay connected till now. So very thank you to all the officers and retired regional directors and former directors for their time. And I thanks all the oral presenters and poster presenters for their active participation that made this event fruitful, and the support and cooperation extended by the technical section, engineering section, security section is commendable, who directly or indirectly helped for success of this event. A special thanks to all our committee members who are working hard for so many days to make this event successful. With deep sense of appreciation, I thank all who voluntarily worked both on screen and behind the scenes to make this event happen. Standing as a pillar of strength, they worked beyond the comfort zone to take on completion of this program and achieving this excellence. So once again, I thank you everyone on behalf of organizing team. And I thank you, our convener and organizing secretary, for guiding us time to time and support us during all the for all the facilities. Thank you very much, sir. So from the permission of our convener and organizing secretary, and of course our director AMD, I'll conclude this session. Thank you very much.